Welcome to the second day of NCRI 2022. So let's start our session with a plenary keynote on the topic GHG, estimation methodology, and carbon efficient technologies for sustainable road construction and maintenance by Professor Ankit Gupta. I welcome you, sir. Dr. Ankit Gupta, Associate Professor and Moth Chair Professor in Department of Civil Engineering, IIT Benares Hindu University, and obtained his bachelor degree in Civil Engineering from Government Engineering College, Kota, Rajasthan, and Master of Technology in Earthquake Engineering from IIT Roorkee. I welcome you, sir.
Can I have the pointer? Yeah, okay. So good morning, everyone. I hope I am audible to you all. Yeah. So thank you, KHRI, IIT Palakkad for inviting me for something on the resilient infrastructures. Okay. Resilient infrastructures. There are so many technologies which can give you resilient infrastructures. But the question comes the quantification. Okay, like as an implementing agency, maybe PWD, there will be 4 or 5 people coming to you, giving the different technology for the same project. How will you evaluate that technology for which to adopt and which will be giving you a more resilient infrastructure? Okay, so that is a big question. Although I do not have an answer for this, I'll try to shift my focus towards on a different topic, maybe a sustainability. Okay, again, that's all are the buzzwords which has been talked about a lot by many people. I'll not tell you what is sustainability. I'll just go through brief about this thing. But my whole question is, there are so many technologies available in the country. Can we quantify them? Like the simplest question as a pavement engineer is, there are two types of the pavements, rigid pavement and a flexible pavement. Can anyone tell me which is more sustainable? Someone can tell me, yeah, flexible pavements are not sustainable because in the rigid pavements, we can use directly a cement, okay? And then we do not need to heat the cements, we do not need to heat the mixes, mortars, anything. So probably the rigid pavements are more sustainable to us. But have we seen the production of the cement? That what kind of the emissions are there with the cement? I do not know the answer that right now what is the more sustainable one. But probably as an engineer, somewhere we have to look down the quantifications also to understand the sustainability. Okay, so just as a member of one of the committees in the IRC, we have come up with a very basic framework or a codal guideline for evaluating the GHG emissions, especially at the DPR level. Okay, so there is a kind of a mandate being given to the ministry that somewhere down the line, there will be the projects which will be awarded not only on the basis of the L1, the lowest cost, but probably sometimes there will be combination of a cost along with the emissions also. So for that, we need to come up with a certain guideline. Obviously, these are not a very robust guidelines, okay? These are just the first draft kind of a thing which has been available to us. Probably with that time, with having the more experience in this direction, we can always refine this document. Okay, so my whole motto of this presentation is quantification. Okay, so that quantification, probably as an engineer, we can quantify that which technology is sustainable for a particular project and maybe a different technology for another project. Okay, so I'll not go into the details of the sustainability. Okay, the carbon footprints has been talked about a lot. Probably the image which comes in the mind when we talk about the carbon footprint is like about all these black kind of the footprints are there, okay, which is associated with the emissions basically. Okay, now how to define these carbon footprints? There has been a lot of discussion that what is exactly a carbon footprint. Okay, so it is nothing but the total amount of the greenhouse gas emissions. Now we say the greenhouse gases because it consists of the different type of the gases. So normally we change all these greenhouse gases to a one kind of a gas, that is the total amount of the CO2 emissions. For a traffic engineer, I can relate this example with the PCU. So we change all our traffic to the PCU. So similarly, we are changing all the gases to the amount of the carbon dioxide, okay, in terms of the equivalent tons. This is again a one topic which has been discussed a lot about the carbon neutrality of our systems, okay. So ultimately, whatever the total amount of the emissions which we are releasing from our project, somewhere we have to do some kind of an activities to neutralize those carbon emissions also. So now those neutralization can be either by our activities, we can reduce the carbon emissions, okay. Our activities could be anything, by be more vigilant, probably just switching off the lights which are of not of use. Considering these things, and then the another things could be kind of an activities which is sequestering some kind of a carbon emissions, maybe like plantation of the trees and the etc. etc. So this is ultimately we have to come to a carbon neutral kind of a thing. So any project sustainability again can be evaluated in terms of the carbon neutrality. Okay. Now the status in the worldwide, this is a very old picture. I am so lethargic that I have not updated this because I know there will be some kind of the updates might be there in the peaks. But altogether there will be few changes up and down, but this remain will the same. Okay, so there is one country which is emitting more than the second country, than the third country. And if you'll just see the opposite as a per capita side, then probably we will see a different kind of a scenario. Maybe some Gulf countries, some Middle East countries, they are emitting more as compared to the per capita emissions. Okay, so these are just to understand that there are some kind of emissions going on in the world. Okay. Now, how to understand again this in the pictorial way? Now to understand by the sector wise. Now this is an important thing that if something comes to the infrastructure side, probably the emissions of the CO2 is almost 1/3. Okay, so that is the important of this sector that we need to understand, that if we can control the emissions from our sector, probably we can contribute something to the sustainability. Obviously, we are not the one who can deal with every kind of the emissions, okay, because there are so many different domains which is available in the whole society, which is again contributing to the emissions. But look, okay, we can do in our domain, like for the sustainability, okay. Now this is, every time we talk about the growth factors, the GDP values, the double-digit values, the 5 trillion economy, 13% GDP, 14% GDP. So there is always a repercussions of these values, okay. So these are just kind of an extrapolations being predicted that by the Indian emissions, if we'll go with a 5% or 6% growth, and if it is just going by the 7.5%, and believe me, these are not the realistic, these, we are still moving at an 8 to 9% nowadays, and we are aiming for a double-digit figure for the 14% of the GDP. Okay, so that kind of an increase, if it is there, probably it will go by the same trend, it will go very high kind of the emissions will be there. So somewhere we have to involve something in our activities, in our projects, so that at least we can lower down this trend. Okay. So this is just a very brief example. I could not find a good example from the Indian context. So that amount of the CO2 emissions, especially for the pavement construction. So that has been again given in from the US literature I've just taken. So almost like a construction of a 1.6 kilometers of an expressway, it is emitting almost like 1200 tons of the CO2. So almost for a kilometer, something around 750 or so tons of the CO2 will be emitted. Constructing it as an expressway kind of a thing. Okay, in our country, it is being discussed as a freeways in the US, and almost like a 210 cars which is emitting the whole CO2 in an year. So something around 130 or 140, the value will come. So that is the amount of the CO2 emission when we construct a 1 kilometer length of an expressway. These values will be slightly less if we'll come to the state highways or for the low volume roads. But again, this is the just a kind of a correlation with the amount of the emissions of the CO2. Okay. These are the mandates of the United Nations, we all know. Okay, so there were the conference, the climate change conferences are there. So COP21 was in Paris. Okay, so again there was a mandatory. There was a our Prime Minister has given the voluntarily carbon emission of 35%, and in the last climate change conference in the Glasgow, again we have increased this by the value of that we will be net zero carbon emissions by 2070, and we will reduce our emissions by 1 billion tons by 2030. Okay, so these are the voluntary statements given by our Prime Minister, but if it has been given by our Prime Minister, obviously it is comes the responsibility of the whole country to cater it. Okay, so this is how the things are coming. And obviously when the pressure will be there, probably we'll be more active towards these things. There are so many missions by the NHI has been adopted, the ministry has been adopted just to tackle out these things. Okay, I'll not go into the details of these things. But the pavement industry as a whole, because I belong to that particular domain of transportation, especially to the pavement side, now there are so many questions coming to us, like we have to think, implement something so that our roads are emitting less. Okay, we call that as a green roads or whatever the thing. Okay, but how to come this thing? So there is a lot of big question coming to us, how to do this thing. Okay, when to do this thing, where to do this thing. Okay, so at the various stages are there, on which stages we have to do these things. Okay, so obviously this is the various possible ways we are having. Okay, the first has been discussed in the morning yesterday. The documents and the guidelines, some of these were released yesterday also. So probably this one is a very important part in our implementing agencies or systems. We always follow code guidelines or circulars. Okay, so probably this could be the first step of implementing anything like this. Okay, so we need to come up with the various codes, guidelines, circulars, which can at least start something. Okay. There are so many already documents which is available by the federal highways in these directions, PR, maybe the International Road Federations, World Bank, ADB, Austroads, and similarly IRC also felt the same kind of a thing, that there were no much documents available in the sustainability side, on the carbon emission side, on the greenhouse gas emission side by the IRC. So IRC has taken that mandate almost 3 years before, and then we have developed some kind of a document which I'll be discussing at a later stage. Then the second thing is, the most challenging is the creating awareness among the stakeholders. Okay, believe me, this does not work. Okay, the stakeholders, if you tell to contractors that please do some kind of a techniques which are sustainable, he'll not think about the sustainability of the environment, he'll just think about the sustainability of his pocket. And that is very natural also. It is nothing like to be laughed upon and to be, make fun about, because obviously a contractor has to earn a money. Okay, what he will think is obviously depending upon his project. Okay, so all these things, it's good maybe at a these kind of a discussions level or maybe at a school level, but I have personally seen with my limited experience, this is not giving a much kind of a help to us until unless we can give up with a certain kind of a provisions, guidelines, or some kind of a rewarding activities are there. Okay, so the possible ways to increase all this thing is, okay, creating awareness. We can always tell someone, but probably 1 out of 1,000 will be aware by our these kind of lectures. Okay, policy implementation is again have to be talked at terms of the top level. Okay, so they have to come up with a really kind of practical policies which can be implemented. Then the rewarding schemes probably we need to introduce. Okay, so if someone is saving the carbon emissions, can we give some kind of an advantage in a next kind of a contract, next kind of a bidding process? So that could be, and that there has been a lot of examples in the various parts of the world where they are being given certain kind of a benefits in the next projects when they are achieving something different kind of the ratings they are achieving. So this could be a one mechanism, but again it has to be dealt with the policy implementation. The green technologies, there are so many green technologies are available in the whole country, in the whole world. How to find out which one is more green and which one is less green, and which is most fitted for our project. Okay, so as an engineer, we have to find out the solution. Okay, no one can other tell us that this one is good for you. Okay, so as a engineer from the agencies, as an engineer, we need to find out that which of the technology is really good, sustainable, green, cost efficient for our project. Okay, so there comes the cost effective. So none of the green technologies will be adopted if it is not cost effective. Yeah, again, in the cost, there are two terms, initial cost and a life cycle cost. So there has been a lot of debate. Obviously, we are not at a position right now to talk much about the life cycle cost. Means I have, with my limited interaction with the peoples in the ministry or with the peoples in the implementing agencies, they still focus on the initial cost. Okay, so if you'll go with the technology with a probably higher 15 to 20% initial cost, probably no one will allow you easily until unless you have some good solid background, some good justifications for that kind of a thing. Okay. Community participation is also one way, the creating, showcasing the successful stories and the projects. Now, this is something which we need to do. If you are doing some project, if it is really coming out well, if it is really giving you a well results in terms of the emissions also, then the whole agency should be basically showcasing these things to the others also. This should be used as a good document to again justify our policy makers that kindly give us more chances to go with the more green technologies, because we have already showed this thing, and this is in terms of a quantification, we are saving this much amount of the green, means which we are saving this much amount of the emissions basically. My always point will be focused on this R&D, and I'm very happy that KHRI is being supported by the PWDs in a good way, and somehow some research and the development is always taking place, because there is always room for the R&D. Okay, R&D cannot be saturated one. Okay, so obviously when we are talking about these things, the implications, because once can come up with you a certain kind of a thing, because this technology is very good, sustainable, and maybe initial calculations are showing that it is very good for you. But what about its future? Okay, maybe if you are using some kind of a chemicals in your roads, whether it is giving you some kind of properties with the change properties with your water quality, okay, some leachate is there. So what are the future about that particular chemical inducing in our road construction? Okay, so again, that need to be checked by the R&Ds or the various kind of the distresses which can be occurred because of these kind of the chemicals need to be properly researched. Then there has been a lot of discussion that how to develop the manuals, guidelines, codal provisions. Okay, so the first thing which came into the mind for the various kind of the peoples are the development of a rating system. So let us rate the different kind of technologies or the different kind of the projects on the basis of a certain things. Now, what are those certain things? Okay, like how you will rate a certain project by a green kind of a thing. Okay, so the first thing is the carbon emissions calculators which has been developed in the various parts of the world. There are so many carbon emissions calculators are available, okay, by the IRF, by the ADBs. Okay, so there are different agencies which have developed the carbon emission calculator. So this is probably one way we can find out our DPR level emissions by using these carbon emission calculators. But this is a data intensive kind of a technique. You need lot of data for finding out the carbon emissions. Like for example, if you are using some kind of a fuel, okay, a fuel may be a gasoline or petrol in area. Okay, even the petrol can emit a different amount of the emissions if it is being used in the different areas, because the chemical composition of the petrol can also be slightly varying. Some are like a lead based petrols are there, okay, some are ethanol based petrols are there. So again, the coefficients of the emission coefficients are different for these kind of the small things. This is just one of the material I am telling you. The various kind of the materials which we are using in our projects will again have a different coefficients, okay, the emission coefficients. And these emission coefficients will vary from place to place, even from the country to country also. So again, that kind of a data, if we are not having, probably we are ending up at different wrong calculations. So that also need to be understood, that whether we are using a calculator, whether it is really giving it as a good values or not. So then the people have thought upon in a different area also. Let us not talk about the whole carbon emission calculators. Let us talk about the project and only just think about the working temperatures on the field. So that is again relating to my first example with the rigid pavement and the flexible pavement. Okay, only for a project you can always say that probably rigid pavements are a more sustainable techniques, because the working temperatures are the normal working temperatures. You need not to increase the temperatures for mixing and the compaction and the other things. But again, it is not giving you a very clear picture. Okay, so this is again need to be used very carefully when you are using two similar type of the techniques. Okay, not like a rigid pavement versus a flexible pavement. I'm only giving this example, rigid versus flexible, as a generalized one. There could be many examples with the different kind of the technologies, maybe for the road construction, for the bridges, etc. Okay, then probably we need to think more. Okay, if someone is having any good idea, any out of the box idea to compare the projects at the emission levels, it is always welcome. Okay, but again, we have not seen much of the ideas in this direction in the literature. Okay, now there are so many technologies available. Okay, it all can be compared. Okay, again, some can be good for a certain project. Okay, some cannot be a fit for a certain project in terms of the emissions. Okay, so again, let us not go by a blind fact okay, the cold mix is probably the most carbon efficient technologies as compared to warm mix. Okay, I'm using all this sentence assuming this that I do not know anything. Okay, I might be wrong also. So these are my hypotheses that I'm just thinking that probably cold mix is a more carbon efficient technologies because I'm using the working temperatures. Okay, but again, I need to understand that how this cold mix or the emulsions are being generated. Okay, what is the amount of the energy I'm releasing in the emulsion manufacturing industry? Okay, so again, that need to be totally evaluated to come to a conclusion that whether my cold mix technology is really a sustainable one or not. Okay, recycling has been done. Okay, again, it is a good sustainable techniques. The quantification is important. Use of waste and the marginal materials, preservations of assets. So whatever we are creating, if you can understand that these are the assets, then probably we'll preserve them and then we'll do a better management of these assets. And again, my favorite line is R&D point. Okay. So this is probably the first document which has been released by the IRC. So IRC SP 133, released last year only. It was again a very basic draft document. Okay, it is not, I'm not telling that this is something very out of the box or a novel idea. We have just drafted a guideline. Okay, again, along with me, the whole G3 committee was there. So this is probably the first document which can at least give you some kind of a guideline to evaluate the projects at the DPR stage in terms of the carbon emissions. Okay, so now this, we have that kind of a guideline. This guideline is having few examples also, solved examples that how to include your projects at the DPR stage. So I'll be just briefly talking about this. I'll not be going in the much details at how to do the calculations because it is very simple. The only issue is how to get the emission factors. Okay, so till now, most of the emission factors either are being taken from the some kind of a literatures. Only few of the literatures are available in the country and mostly from the CPCB, the Central Pollution Control Board. So that has been taken in this thing. Most of the other emission factors has been taken from the different parts of the world. So again, we do not have that good data for our conditions. So that's why we have used the other countries. So these are of three different parts. I'll not go into the much into introduction, but it includes two things. One is for your new kind of a project. So at the estimation when you will do for a DPR level kind of a thing, okay, before the start of a project. And the second thing is the operation and the maintenance stage. Okay, so when you have to maintenance, some kind of a maintenance project is there, or the operation stage of the of your project is there. How to find out the emissions also, that is also being considered in this document. I'll not go to the what is the concept of a green. We all know the reason we all talking about this green. Okay, so let us directly come to the objectives of this guidelines. So this is just to facilitate the procedure of the GHG estimations. Okay, again this is an approximate estimation. This is at the DPR stage. If something is deviating from your DPR thing, then obviously it will not give you correct calculations. So that again need to be ensured that their project has to be gone with a DPR, whatever which has been mentioned in the DPR. If there is deviations from the DPR, that needs to be incorporated to account for the changes in the emissions. Okay, and this also highlights the importance of the various technologies. So at the last, we have just given the various technologies which is available in the different codal provisions are there for those technologies. So these are just summed up here. These are just highlighted here. Again, there is no recommendation being given that this is the more efficient one as compared to the other one. So it depends upon project to project. It depends upon the engineer who has to do these all calculations and find out which one is better for him. Okay. These are some important terminologies which has been used, that what is the meaning of a carbon footprint, so which we have understood. The emission factor is, which is very important for this document is, so it is the rate of the emissions which is per unit of the material consumed or the activity which you are doing. So this is something very important to find out the emission factors for each and every activity also and for each and every material also. And this is the most challenging one, okay, to find out a country-based emission factors or a country-based material emission factors. Okay, so this has not been researched a lot in the country. Okay, so most of these factors are either being taken from the outside documents or some of the documents later with the Pollution Control Board with the fuel kind of the emission factors were available. So those fuel emission factors have been taken from the CPCB. Yeah. Then there are different type of the emissions. One is the direct emissions, which we can always see, okay? And then there are some indirect emissions, which is not there in the project, okay? Like for example, you are using any materials, cement, additives, okay? These are directly being supplied to you. So you are not able to see the indirect emissions of this, like the construction or by the manufacturing of these kind of the raw materials, what are the emissions which has been done? Okay, so again, that indirect emissions again need to be dealt on. Then the embodied carbon emissions, that in a certain activity or a material or a machinery, what is the total amount of the embodied carbon emissions? So that is the indirect emissions which has been done in manufacturing of the machine, material, that has been there in the inside. Like a cement comes with an embodied carbon emission in that, because it has already emitted something in the environment when the cement was being manufactured. So that embodied carbon emission has been taken in this code rather than the indirect emissions. Okay. CO2, then sequestration, like whatever the amount which is being released, again the project has to do something to sequester that or to absorb those carbon emissions. So there are two types of sequestrations which has been discussed or which has been there in the whole world. One is the sequestration done on the ground surface, okay, by the terrestrial environment, and the second which is being absorbed by the marine environments. Okay, so in this document we are not considering any marine environment sequestration, because wherever the marine environment is there, we are not considering that part, because we cannot create any kind of a marine environment. But the terrestrial ecosystem we can create. Okay, we can have more plantations. So that kind of the absorption is also being given in this kind of a document. So if you are releasing, if you are basically cutting some trees, how much emissions you are doing. If you are planting some trees, how much sequestration you are doing. And again, that depends upon the soil condition type also. The soil is also having some kind of a factor in the sequestration. So that soil factor is also being given. Again, some help from the soil peoples, from the, there was an institute in Palampur in the Himachal. So there was a CSIR lab is there, which deals in the geology systems and in the soil systems. Okay, so again those scientists were being approached to give us some kind of a idea about the sequestration potential of the different type of the soil. So that has been used in this thing. Okay. So there are three different type of the methodologies which has been discussed. So one is the tier one. It's just on a basis of a fuel. So as we were discussing, probably that the temperature based kind of a thing. So only fuel. So if your project is using more fuel, you can just quantify in terms of the fuel base. That probably I'm using this amount of a fuel, so this is a more releasing one, carbon releasing one, as compared to the project which is using less amount of the fuel. Again, that is simple, but again, that is not giving us a very clear picture. Then the tier 2 uses the country-specific emission factors. Unfortunately, we do not have any this kind of data fully readily available with us, so that this has not been considered. And the type 3 or the tier 3 is basically we are totally doing the calculations with the detailed emission models, measurement data, activity-based models, everything. Okay. Whenever I'm using these words models, believe me, it is not so tough when I'll come to the exact part. So this is the first part, means the second part, which talks about the estimation methodologies for the road construction part. It has been shown that we have to do the estimation for the construction period, we have to do for the maintenance period, we have to take care of the emission factors, we have to do the methodology for the calculation of the CO2 sequestration by the trees or by the soil. And then finally, the total emission efficient technologies and the materials has been discussed. Now, there are so many activities which is causing the emissions. Okay, we all know that the use of materials, the transportation of the materials, removal of the trees or the green cover, amount of excavation, the lead for the cut and the fill, the fuel electricity which is used in the labor camp, okay, use of construction machineries, all these are the different kind of the emission related activities which takes place during the construction of any project. I am more focused on the road projects, okay. Or the maintenance kind of a thing, then the material quantity, the fuel used by the machineries, lead again to transport the materials, street lighting, usage of electricity in the nearby areas or in the camps, other components of the construction period may be applicable. Now that depends upon the different kind of the maintenance activities. If something is not being listed in these things, those components or those activities can be listed. Okay. Now these are the various components which has been considered, the embodied or the direct emissions which has been coming out the construction material. So for this we need the emission factors. the direct and the embodied emissions due to the combustion of the fossil fuels, and emission due to the various kind of the fuels, the embodied carbon emissions of the vehicles and the machinery. So if a company claims that my vehicle, I am manufacturing it with the renewable sources or with the least amount of the energy, then probably that machinery or that vehicle is again having a less amount of the embodied energy. So again, that has been, obviously these kind of the data are very difficult to obtain, so somehow we have to go by the published data, or the manufacturers, if they were telling that my vehicle has been manufactured and this is the amount of the embodied energy in my vehicle manufacturing, then it could be included. Otherwise, you can omit those, considering the similar kind of the machineries are there in all the projects. So we can assume it as a neutral value and we can omit these things. Okay. On the loss of the potential carbon sink in the form of a removal of the green covers, okay, or the direct emission due to the burning of the all the removed timber. Because if some timber is being cut from the certain projects, we are assuming that it will be burnt. Okay, so we are basically trying to be on a more critical side, that if some wood log is being cutted from your project site, so we are assuming it has to be burnt and it is releasing some more carbon emissions. Okay. This is the whole model. Okay, there is nothing any complex in the modeling. So this is the only one equation we are using, nothing more, and it's a very simple one. If you talk about the emissions, it is a two type of the emissions. That is the embodied emissions of the material itself. Like for example, cement, if it is given to you, there will be some embodied emissions in the cement. Like manufacturing of the cement has taken some kind of emissions, okay, in the industry. So that value will be given to you by the manufacturer probably, if it is the correct value. And then the second is the direct emissions. Now this cement, when you are using in your project, is it giving you some kind of a direct emissions or not? So this emissions will be either of an activity or a material or a fuel, anything. And the total emissions can be calculated by the emission factor multiplied by its source. And the source is nothing but the activity multiplied by the intensity of that activity. So it could be a construction activity. So the more construction, like for example, if you are using a fuel, okay, so intensity is the amount of the fuel, activity, how much fuel you are being using, and then the fuel efficient, the fuel emissions basically. So this is one way. So this is the only model which we are using. Now the second part is giving the methodology of doing all these things. Okay. So this is the simple approach for you for finding out the emissions at the construction stage. So I'm only talking about this construction stage. I have a different methodology for the operation and the maintenance stage. So now what are the different activities which is involved? Like what are the different type of the materials which are involved? Maybe hydraulically bound material, unbound materials, rubbers, plastics, all these materials is having some emission factors multiplied by the total amount of the material, multiplied by the emission factors, which will give you the total emissions from the material side. Okay, maybe bitumen you are using, maybe the aggregates you are using, all these things. Then whatever the amount of the fuel you are using, so petrol and the diesel, probably these are the two, or probably kerosene if it is there. Okay, then where you are using this petrol, maybe in the crusher plant, maybe the roller plant, okay, maybe paver, maybe wherever you are using these fuels, multiplied with their activity, okay, the amount which you are basically burning multiplied by the activity, it will give you the total amount of the emissions during the construction phase. Okay. Now the next point is the cut and the filling. Basically, we are doing from the cut and the fill side, or any kind of a material transport. Okay. So in the cutting and the filling also, we are using some kind of a fuels. Okay. Or we are basically taking out some excavations. We are doing some excavations and filling up some material. So whatever the activities we are doing, and we are again multiplying with their fuel efficiencies multiplied by their intensities, or the amount of the fuel which has been used. And we are getting the total amount of the emission. So this is a very simplistic kind of methodological flowchart. No more, nothing engineering involved in this thing. The whole issue lies with the emission factors and correctly finding out that what are the intensities of your activities. Probably what amount of the fuel you will be using, what amount of the green cover you will be cutting. Okay, so all those activities should be enlisted at the DPR stage. So at least this can give you a brief idea or an approximate idea of the amount of the emissions. Okay. Now these are some another stages. Maybe there is some campsite which is there. Okay, so you need some kind of a cooking, lighting, all the whatever the kind of the fuel which has been used there. Okay, corresponding emission factor. So these are the campsite activities basically. And then finally, whatever the amount of the timber which has been cut from the areas, okay, the green cover which has been demolished. So whatever the total amount of the emissions which is coming out from the removing of this green cover. Okay, so all this has been considered in the construction stage of a project. Okay. Now during the emissions, there are again maintenance part, there are different type of the emissions. I'll directly come to the, because most of these are similar. Again, in the maintenance activity, because maintenance is keep on changing day by day with that amount of the technologies coming in the maintenance side. So if any of the activity which has not been listed, that can be easily listed by the engineer by using the same kind of a formula. There is nothing any new in the formula. Okay, the only thing is that activity needs to be listed in this methodology. Okay. Now this is the important point, like the emission factors. Okay, so if you will see the emission factors of the bitumen, aggregate, cement, sand, steel, okay, general or the recycled steel, stone, soil, general plastic, CNG. Now these are mostly being taken from the IC, means again the inventory for the carbon and the energy division from the UK. We could not get any good values from our Indian literature, but probably this is something which we need to work, because there is a lot of variations in the bitumen emission factors which has been used by the different countries or the different sources of the bitumen. Okay. Similarly, the quarried aggregate can be of a different kind of emission factors depending upon the type of the mineralogy of the type of the aggregate. Okay. So again, these needs to be worked upon. Maybe someday we'll have our own country specific emission factors or the area specific emission factors. Then probably we can use these factors someday from our country. Okay. Otherwise, most of these are taken from the IPCC guidelines or the CPCB values. So these are the weighted average specific emission factors for the various fossil fuel. Now again, we'll talk about the electricity. Okay. So I can have a one embodied emission for electricity. But again, I need to make sure that from where this electricity is coming. From a renewable sources, from a solar source, from a hydel source, from a coal-based plant. If a coal-based plant, whether it is coming from a normal coal-based plant or a lignite-based kind of a coal-based plant. Okay, so again, every kind of electricity is also not same. It depends upon the generation or the generation power or the generation source of the electricity. Okay, so again, these factors have been given in the code for an easy reference kind of a thing. If someone thinks that someone is having a better value, they can always use. So these are just as a guidelines which has been given. Now this is about the soil sequestration. So depending upon the different type of the soils, these sequestrations values have been given. Again, up to the different temperature, different climates, it has been there. Okay, so again, these can be used for the finding out the amount of the sequestration done by the different type of the soils. This is the total amount of the sequestration which we can do for the different type of the soil. So this is the formula which we have to use. Okay, I'm not going in the detail because this is really required when we need to come up with a DPR kind of a thing. Okay. This is again about the trees. Okay, so in the trees, we have considered the two different kind of, the diameter of the tree less than 11 inches and the diameter of the tree more than 11 inches. Okay, so for those different trees, because a diameter will have certain kind of implications on the amount of the carbon available in the trees. Okay. So again, that has been considered, and it has been considered that 25% of the height of the tree will be below the ground. So whenever the height of the tree is being considered, it is multiplied by 1.25, considering its branches or the roots inside the ground area also. So this is just for finding out the sequestration part. Earlier we have found out the emission part, this is the sequestration part. Okay. Again, not going into details. Now, this is the various methodologies or the materials which, the technologies which we all know. Okay, so there are so many technologies which has been given, like the optimization of the pavement design is based on the various GHG emission types. So there are so many ways available for us. Composite pavements. Okay, we all know either a flexible over a rigid or rigid over a flexible. These are the various composite pavements. So IRC 37 gives a lot detail about the types of the pavements. Okay. This flexible and the composites one. The bitumen stabilized bases and the sub bases again being given in the IRC 37 or the IRC 120. Soil stabilization, maybe chemical stabilization, mechanical, again discussed a lot in the IRC 28 or the IRC SP 89, which has been nowadays much more used in the FDR techniques, the full depth reclamation. Use of high modulus binder, again, HIMA kind of a thing is there. Okay. Then improving the strength of the subgrade soil by either using the waste materials, by stabilization, chemical, mechanical stabilizations. Okay, use of geosynthetics. Madam is there, probably she'll be dealing more with the geosynthetics thing. the locally available or the marginal materials is there. Okay, so all these kind of the things are available. Okay, so this is just a brief gist which has been given in the guidelines that these are the technologies available. No comment has been given that which technology is more efficient, carbon efficient or not. It depends upon project to project. Okay. Many industrial wastes are there, so you can use the slags. It is already there in the IRC SP 121. Use of various kind of the stone industry waste, maybe limestone industry, maybe marble dust, all these things. Use of fly ash, SP 58 is there, or the IRC 112 is there. Use of the construction demolition waste is there. Use of the foundry sands are there. So there are so many things which is available: plastic waste, rubber waste, modified binders, okay, waste materials, alternative filler, use of wrap. Everything is available in the IRC. Okay, this is how to use, but these are the technologies which can be think upon on a carbon neutral or basically a sustainable technologies in the green side. Okay. Now, how to do this thing? Again, we have to go back with the same calculation. Now, this is the third stage basically where we talk about the maintenance part. Okay. Now, this has been dealt separately because the construction can have a different activities which are not similar to the maintenance of a road project. Okay. So, that's why this has been dealt separately. So, now here we have to take the fleet composition because the traffic will be there. Okay, so what is your fleet composition? What are the fuel type which has been used by the fleet, and their vintage year, means the year of the manufacturing of the traffic, okay, the vehicles. Okay. Then the mode-wise fuel efficiencies, okay, the petrol giving a different kind of a fuel efficiency, the diesel is having a different kind of a fuel efficiency, total amount of the traffic volume, trip length or the projected road length, road configurations, pavement roughness, the distresses which is available on the pavement, existing or the proposed tree cover which is there alongside the maintenance of the roads, and then the volume to capacity ratio. Now these are the things which has been considered in the operational stage. Okay. Again, a similar kind of a methodology will basically find out the AADT of the vehicles, of the different compositions of the vehicles are there. Okay. Again, we need to see their vintage years. Okay, now this vintage year data is again being given by the CPCB. Okay, the fuel efficiencies will be given by the CPCB. Then the different kind of the fuels which we are using right now for our vehicles are either the petrol, diesel or the CNG. Then multiply all this by the emission factors for these things. Okay, multiplied by the intensity, that is the amount of the traffic, and you will get the total amount of the emissions for a particular section. Okay. Now this talks about the stage 2, that in which basically we are using the operation stage. Then what are the total amount of the vehicle is there, okay, the different classification of the vehicles, again their vintage, again with the different kind of the fuels. Now here we are not taking the direct efficiency. Now here we are using one more method basically depending upon the average speed of the fuels. So it has been seen that if you are moving at a average speed values, that will give you a higher efficiency of a fuel or lesser emissions will be there. So here a different methodology has been considered. If you have that data of the speed data of the different type of the vehicles, then that can be considered. So because we know that there is some range of the speeds in our vehicle mileometers that will give you the minimum emissions basically. Okay, so that has been that approach has been considered in this stage 2 part. Obviously that needs some speed data and the fuel efficiency data in the different speed ranges. So this is just one example for to understand that fact, that considering that we are getting the almost zero efficiency. This is assumption that whatever the emissions we are getting at a 50 kilometers per hour, we are considering it as zero. Okay, so whatever the base we are considering it as zero. So if you go to a lower speed, probably your emissions will be higher. If you go to a more higher speed, then your emissions will be higher. And this we all know. So that is probably the reason or the logic that we have used the second type of methodology for the maintenance stage also. Now again, this is the different type of the emission factors by the different type of the fuels for the different vintage of the different vehicles type also. So if a vehicle which has a two-wheeler which has been manufactured in the year 1991 to 1995, then the amount of the CO2 emissions is 24.75. Okay, so this is the different vintage values which has been again mentioned with the help of the CPCB in this document. Okay. So finally coming to the conclusion that it is just a very initial first draft. I'll not say it's a foolproof document, but just a kind of guidelines which has been released, just to start something. Maybe in some of the projects, it can be taken up, or if not being taken up, it can be taken up as an exercise to just try to find out the emissions at a DPR stage for any kind of a project. Okay. Again, what I heard from the different sources, that probably there will be some time that this projects will not be awarded only on the lowest cost, probably as some kind of a combination with the emissions along with the cost. Okay, so there is a lot of mandate which has been given by the various funding agencies, maybe World Bank or the ADB, that to include these kind of methodologies at least at the DPR stage, and at least have some kind of a control over the emissions for the different type of the projects. So for that reason, there was a lot of pressure on the committees to prepare such kind of a document. So probably this is the first type of the document which has been there. Now coming back to the topic of the resilient infrastructure. Now probably a good question for us is, can we have a resilient infrastructure quantification also? Okay, there are so many resilient infrastructure technologies which we'll be discussing. Can we have a quantification of which technology will give me a more resilient infrastructure or a less resilient infrastructure? So probably that could be again a one good idea. Or, obviously there will be so many different type of the natural disasters which you have to consider, but considering for example like in a Kerala, okay, you have fixed type of the disasters, maybe the flood is one of the things, landslide is one of the things, okay. So then considering these things, can you quantify your projects on the basis of the different technologies, that which is more resilient and which is less resilient in terms of some numbers? Okay, so that could be again a one good approach. We can still try. I mean, I do not have an answer for this thing, but probably this could be a good food for thought after this whole presentation. Okay, so this is my opportunities and the challenges I normally discuss. Okay, so more efforts are required to understand the emissions. So we do not have these emission factors for us. Okay, we need to create these emission factors and quantify the same during the construction and the operation stage of a project. Again, research values, because these emission factors values need to be find out. More GHG emission calculators. This is a very basic, just we have used one formula, we have just given a guideline. Probably a more better version of these calculators could be there, or probably a more easy one, software based kind of a thing, having the inbuilt values. Probably that could be a very helpful for the engineers like us. Okay. And the research on the soil types, again the soil types, we have just taken some values from asking some scientists, but again there is no any research which is done by our infrastructure people in this direction. And ultimately we have to come up with this kind of a studies, more environmental studies of a project, full life cycle cost analysis, cost benefit analysis. Okay, these are something of very good documents to justify to the policy makers for either going for a one kind of a technology or a different kind of a technology. So this is something we have to see some kind of these documents after the completion of a project that talks about these things. Okay, normally we complete the project, we start thinking about the next project. We hardly come up with a report with a new project, okay? And talking about all these things, the environmental studies, full life cycle cost analysis, cost benefit, normally we do it because we have to justify the new technologies. The challenges are so many. We have to convince the implementation organizations to adopt such calculators. So still, it is not mandatory to adopt these calculators, but maybe in somewhere in the down the line, there will be these calculators will be adopted. Codal provisions and the incentives, basically incentives we need to talk more, okay? So if someone contractor is doing something good, are we incentivize them? Okay, and the policy initiatives has to be taken up from the top level. Okay, so this is all. Let us start thinking green, although we are here to talk about more about the resiliency, but probably we can just, it's a kind of a correlation. Resiliency is also having some kind of a correlation with the sustainability. So let us start talking about thinking green, greener, or the greenest, okay? So my acknowledgements to the IRC SP33, the content has been taken from there. My all teachers, students, and especially my IRC G3 committee, which is responsible for taking out this document. I'm not the only person. Thank you.
Thank you, sir. So now it's a doubt clearance session. If you have any doubt regarding the presentation.
Sir, you mentioned that carbon sequestration differs from topography to topography. What are the, for example, some area topography is rich with minerals, and some areas are run by, the vehicles are vintage period. So what are the main methodologies employed to decipher out the carbon sequestration potential of a particular topography?
So there is nothing like any topography we are considering because it is only the soil type which is responsible for the sequestration or the type of a tree, the age of a tree or the diameter of a tree.
Sir, what about the canopy, tree canopies? Any carbon sequestration potential?
Of the tree canopies. So
Canopy.
that is included in the tree. So again, if you are having some kind of a trees which is having some more sequestration potential, because we have considered a general tree, which we say assume that it is having some kind of a stem along with some branches and the leaves. If some specific kind of the trees are there, we need to study. So that's why I told that it's a very initial first kind of a draft guideline which has been released. Okay, so that we don't have that kind of an experience and that kind of a data available to us. So probably again this could be even more improved also.
Some more are the quantification of resilience.
So quantification, so once we have the emission factors, the quantification could be done easily. So the whole thing is the emission factors basically, or the sequestration potential. Either the emission factors which is releasing the emissions or the sequestration potential if something is sequestering. So the sequestration potential, if you are having some type of a spatial trees like a canopy kind of a trees, so maybe that need to be identified by some kind of a R&D studies. If we have that values, we can easily find out the sequestration potential of those trees and probably the projects.
Okay, sir.
Yeah.
Thank you, sir. Any doubts?
Sir, as you had mentioned regarding the linking this to the DPR, so that means the broader objective will be a sort of a net carbon, or that's what we are looking at as a single point of a net carbon. For example, suppose we are looking at a highway arboriculture. So we're looking at some sort of a carbon sequestration. So is it for per kilometer, okay, at least we should have such and such carbon sequestration, or are you looking at something more than that, like carbon neutral? It's not possible, but are you looking at some sort of a net carbon in these things?
No, so initially this was being developed only for the total amount of the emissions out of it.
Okay.
So once we'll have that emission values, then probably that can be think at a later stage of about thinking of the sequestration or the net carbon kind of a thing. But this is only initially developed for the total amount of the emissions which is coming out of a project by using a one kind of a technology or whatever the conventional technology. So it basically, the idea is to basically compare 2 or 3 ideas at the DPR stage. Maybe a conventional one, maybe some kind of a technology, maybe for example just like a warm mix additives or using the cold mix for example, and then come up with the 3 values, and then probably it will give, and then the cost has also been associated with the DPR, so there will be multiple DPRs basically on the different type of the technologies, then to come out, then to select the best out of it. So this was the idea. I'm not sure how long we'll go and we'll have that kind of a time to prepare the 2 or 3 different type of the DPRs for the different technologies and then selecting best out of it. Because our projects are always like kind of a shooting gun on the head that used to be completed within few months. Okay, so DPR has to be completed within 15 days or 20 days or so. I'm not sure how these things will be there, but the idea is basically to compare the different technologies at the DPR stages and then basically go for the one which is having a good combination of a cost along with the emissions. That factor has still to be worked out, that what you are considering, 80% cost and 20% emissions, or 70% cost or 30% emissions. So that has to be taken, that the call has to be taken by the policy makers.
So I have one more question
Yeah.
regarding this one. Is it something we are putting the responsibility of the manufacturer? For example, it's a packed product.
Yeah, yeah.
So any food product itself, we can have, if there is something which is mandatory, like this much kilocalories, like that.
Yeah, yeah.
So are we looking at that way, just like the star rating in the electrical part?
Yeah, yeah,
So are we looking at that way? Are any efforts going on to that extent to put the responsibility on the manufacturer side itself to display the whatever these factors, emission factors, because that is the key thing, unless
Yeah, yeah,
unless
I
and until we
understand
can
your
get
point.
a realistic idea, we cannot come up with a total
Yeah, so there will be, obviously, when these things will really come into the practice, the manufacturers have to give the total amount of
Yeah.
the emissions or the emission factors. So for few of the products, it is there. Few of the products which they claim that they are more sustainable,
Yeah.
they have started selling this thing with the emission factors. Okay, so some of the products are giving right now this is not mandated, but obviously when this comes into the practice, every manufacturer will start giving these values. So hopefully, obviously it's a long way to go. It's nothing like the things, the code have been developed and the things have started. I think the implementation of this code probably will take more 3 to 5 years down the line. Even it is totally been implemented from the policy makers. So it is all upon the policy implementation basically.
So one more doubt
Yeah,
regarding this emission factors, and are we looking at the construction emission only in that part, or is the road user cost while after the construction that emission? But obviously we are looking right now only in the construction emission
Yeah.
factor, isn't it? I mean,
So that the operation cost has already been, operation stage also been considered
that
in
is
this
also
thing.
being
Huh.
considered.
So the construction stage, operation stage and the maintenance stage, all these three stages are being considered.
okay.
So that is a road user cost also in terms of the emissions you can discuss for a project.
Thanks. Thanks.
Thank you, sir. As a token of appreciation, we would like to present a memento to Dr. Ankit Gupta. I kindly invite Srimati Beena Ma'am, Chief Engineer Buildings, to present the memento. Thank you, sir. Thank you, ma'am. Next, I would like to invite Minimol Kurula McCaffrey to deliver the keynote address on the topic Innovative Technologies for Sustainable Highways with Reduction in Life Cycle Cost. Minimol Kurula, Head of Strategic Initiatives and Projects at McCaffrey India, has more than 25 years of experience in the field of civil engineering to solve complex challenges. Active member of authorizing subgroups on the technical committees for ISO, BIS, IGS, IRC.
So I would also, first of all, give my heartfelt thanks to KHRI and Palakkad IIT for inviting me and giving an opportunity here. And definitely thanks to all the audience here, the respected chief engineers, the academicians, and everyone, because it is not easy to come on a Saturday and continuously listening about sustainability, because sustainability is, as Professor explained, it's having a lot of dimensions, and it's not an easy topic to make it simplified in a straight line language. So for the G3 committee of the IRC, it's very encouraging to note that it is really progressing to a stage that it can be understandable by a civil engineer very easily how the different small techniques can be really contributing to sustainability. So I was also a part of the G3 committee, Professor was mentioning. And when we started working on that, it was more about how to plant more trees. So how to planting more trees on the roadsides, it requires a lot of space. So it's more about, we were discussing in the committee about how can we acquire the land, because enormous land is required if everywhere we have to plant a lot of trees so that a carbon reduction will be happening. But from there, definitely a number of very dedicated members started working more deeply in the granular structure of how the carbon emission can be decreased, how the fuel consumption can be decreased, how the sustainable materials can be used, so that a net carbon reduction or the carbon credit of our country will be coming to a impressive note in front of the world countries. So fine, I am talking about a small contribution from the flexible type of materials which I am dealing with. And definitely it is not about, I'm promising that I will not talk about anything particularly about a brand or anything. I will be talking about with the complete generic terms, but I will see that I'm talking more about how in a simple language I can bring about how these materials are contributing to sustainability. All right. So for me, the sustainability, there is, as I mentioned, that a lot of dimensions are there, a lot of aspects are there. But in simple terms, if I can claim to a client organization, I'm contributing something to the sustainability through some technology or through some methods or some value engineering. If I can claim that there is the whatever I am using, it's technically strong. Finally, it has to work. For sustainability, I cannot dilute the quality. It should be economical. It should finally, if it is non-affordable, whatever it is, it definitely, it maybe we can use all the nice words, carbon credit, sustainability, but it should be economical, it should be affordable. Then it should be durable. As Professor said that the maintenance part, that also we are doing very sustainable technologies. At present, there is a material reduction, there is a fuel reduction, but within 3 years, if maintenance is required, then definitely we are going to again emit carbon. Definitely. And maybe the maintenance cost, the type of inflation what is happening, the maintenance cost may be more than the initial cost. And finally, we can have an assessment of carbon footprint reduction. And the way the G3 committee is progressing now, at least for IRC, that granular structure may be coming within, I know people like Professor Ms. Tamosi of ICT, they're all working very hard to bring it in a common language so that we all will understand that. All right? And there is a complete paradigm shift is happening. When we were studying civil engineering, the type of material and construction, the syllabus, what we were studying, what I am seeing that at present it is completely outdated. Whatever I studied, I am not at all using. We studied a lot about timber, but how much in the present construction I am using whatever I studied? Very less. The concrete and steel, of course, it is useful every time, but the shift is happening. From concrete and steel, it's going to different materials, bioengineering materials, nanotechnologies, polymeric materials, and glass fibers. So all these are in use. So unless we are not understanding all these materials and how that can be collaborated, we cannot remove completely concrete and steel and start a new era. We have to bring those type of materials which will work individually as well as in a collaborative mode. Okay? So the present education has to be changed, adopting the different options. Then only the engineer, tomorrow's engineer, we didn't use that. But at least the future engineer should use his capacity to understand the different types of options which are available and select a more sustainable model. So I'm introducing my part A. I'm introducing the polymeric materials, which we can say that something which is a huge change which has made for civil engineering as well as other industries. So in that, the most popular materials only I am mentioning here, I'm sure that at least you must have heard about it. Okay? So the most popular family members, it is such a big family. Okay? Lot of uncles, aunties, sisters, brothers, cousin sisters, nephews. So it became a very big family. But I am talking about just a few very popular products which are being used in the Kerala roads also. And you must have heard at least one time. So the first is geotextile. It's like, as I'm more working in North India, there if I am going to meet anyone, they will tell that kappada, isn't it? Okay, so it's correct. There is nothing to laugh in it. It's a textile, but different types of textiles are there. The main classification is woven geotextile and non-woven geotextile. Woven geotextile is something like our regular cloth, which is having a warp and weft direction, and its main use is for either for reinforcement or confinement. Okay, and in India, the sole reinforcement application started with woven geotextile. Nowadays, it is outdated because more smarter materials have come in the industry. Okay. Now, non-woven geotextile, as per the manufacturing methods, they are different types of products are there. They are thermally bonded, then chemical bonded, knitted, then, knitted is again coming into the woven category, then needle punched. So all these are non-woven, and these non-woven are very good in hydraulic applications. Hydraulic application means filter or separator. Filter, something which is allowing the passage of water and which is not allowing the soil particle to move. So it can very well act as the filter functions, especially for drainage or for separator. It is the ideal material. Then a very popular material which is in use, it is geogrid. Okay, so the geogrid is something which we can equate to steel reinforcement. It increases the strength. Why we are using in the RCC the steel? Everyone knows, right? All engineers knows it. The concrete is weak in tension. It is very good in compression. So we are introducing tensile elements there so that it will be good in tension also, so that it will prevent all the cracks, it will absorb the strains. The same way, this polymeric material, which is having very good tensile strength, even 10 times or 15 times more than steel. Those type of the geogrids are there, which can reinforce the soil, and if you are using those type of polymeric materials smartly, we won't be having the problems of cracks. And we know the cracks are many times, once it is happening, like cancer, it can propagate. And the right time, if we are giving a medicine there, we may be able to stop it, and we may not have to go for a very big maintenance or rehabilitation. So the third material is geomembrane. So this doesn't have that much application in payments. So I don't want to that much glorify, but in some cases, like if you want a sealing, if you want a perfect a capillary cutoff, there we can use it. Why? This is an impermeable material. So concrete, even if we think that it is impermeable, we know that it is not impermeable, right? But if we can add a geomembrane, we can achieve the impermeability to a great extent. And of course, frankly speaking, there also we are not achieving 100% impermeability, but we can come very near to that. Another popular product, which is very much now the IRC guidelines, as well as MORTH, the modification, it is all incorporated. It is the drainage composite. So the drainage composite, as the name indicates, it is a composite material which can be used in pavements, which can be used in slope stability applications for the purpose of drainage. It's a combination most of the time, a drainage core net which is sandwiched between two geotextiles, or one side a geotextile and the other side a geomembrane. So this is having very wide applications in pavements, in railway track, in airport fields, where we will not be able to have space for aggregate drains. And the second, the use is, if we want to reduce the aggregate quantity, especially where the aggregates are not cheaper, there we can go for the drainage composite. And finally, two more products, Geomat and Geocell. Geomat is something which can be used for erosion control. We know that our coir geotextile, which is very effective, jute geotextile. So the geomat is an alternative to that. It is a polymeric product. So more durability is there. And you can combine it with the tensile elements when we have to have a erosion control in a steep slope. Okay? And geocell, it's again a very smart confining material which is having honeycomb structure. And you can fill it with different types of material. Either it can be filled with aggregates or a frictional material, or you can fill it with even with concrete and use it for basal reinforcement or for erosion control. And nowadays, it is being proposed for base and sub-base stabilization also. So these are some of the most popular material, but the common quality of all these products are they are having very good durability. Okay, durability in the sense of we know that plastic, the polymer, it's one of the problem is it's non-biodegradable, right? So that's why we tell that plastics use should be reduced. But in construction industry, definitely we can use this demerit of plastic for the purpose of durable structures. If we can protect a geosynthetic product against sunlight, in fact, it will stay forever. Most of the geosynthetic manufacturers, they are having, or I'm talking about the established manufacturers, they will be having the certification of their products. Certification which is talking about this product will be retaining its characteristics for 120 years, or maybe 150 years, or maybe 60 years. That certification will be there. So definitely, it's not going to end. From 121th year, it is not going to vanish. It will be still there. It can stay for, as I mentioned, that if we can protect it against sunlight, it may stay forever. But 120 years, we are giving because there should be a design base and someone has to design it based on that. Okay, so I'm not going to the depth of the designs or the technical aspects, but to substantiate the use of these materials will be increasing the sustainability. So I would like to mention about the life cycle cost reduction. So bringing that, I'm presenting few case studies which are successfully done in the last few years, even in the COVID time. Usually when I present in Kerala, I used to talk about structures which are standing 20 years and all, but I am taking the last decade. Once the IRC guidelines, the approvals, everything has come and the technology became popular. After that, a lot of case studies has happened in across the country, and how the initial material cost saving has happened, and the life cycle cost, of course, it is a prediction, okay? It's not the life cycle cost analysis. If it is to be done, then we have to do at least means 20 years, 30 years, the study. Then only we can tell that, yes, this is proven. All right. So the first one is, yeah. So the cross section, I think it is visible. It is in a AP, Gundur. And in this case, the soil was very poor. The subgrade soil was silty clay. That means CBR was less than 3%. And of course, when you are designing a flexible pavement there, the section will be quite thick. The base, the sub-base, everything was coming as a huge section. And from the department, the request was, somehow please reduce the base and sub-base thickness, okay? Because we were proposing there, we can even reduce by, if we are reinforcing the base, the bituminous layer can be reduced because it is more costly. But the engineer was against that. He told that I need this much thickness for the bituminous layer. You please reduce base layer. I don't want anything to be reduced, only base layer if you can reduce, then I am happy. So the three types of geosynthetics were used there. You can see the cross section. An extruded geogrid is introduced between the base and subbase layer. A separator geotextile is introduced between subgrade and subbase, because the poor soil, if we are putting our subbase over it, there will be a migration of this fine silty clay to the subbase, and that will contaminate. After some time, it's definitely its performance will be started degrading. Then there is the use of a drainage composite. In the cross section, you can see that the drains which are provided, if you are comparing it with IRC SP 42, the dimensions are very less. A conventional pavement designer will not allow such type of narrow drains. So, but here, still aggregate is being used, but a drainage composite is introduced. And IRC 34, definitely we cannot just go against IRC 42. So if we have to go against that, we have to use another IRC, right? So IRC 34 is there, which is permitting the use of the drainage composite as fin drain or the edge drain to work as an equivalent to the aggregate drain. So as it is a first step for this particular department, we combined it. Aggregate drain is given and a drainage composite also is combined with that. So that together with, there is a material reduction. For the base material has reduced almost 40%. And if you are seeing the cost, overall material cost for the entire road project, that has come to 15 to 20%. And the life cycle cost reduction was estimated as 43%, which is really something which is impressive. And you may ask that, how you decided that 43%, I will come to that. So the solution, the design of the geosynthetic materials, especially this, the base stabilization, where extruded geogrids were introduced, it was designed using IRC SP 59, which is published in 2019 August. So there is, there are workout examples also. So if you're asking how you can design, it is very clear, it is very crystal clear how it is being, has to be, how we can improve the modulus factor by the application of the geogrids, and how the overall performance will be improved. It is quite clearly given in the annexure of IRC SP 59. And for the drainage composite, as I mentioned that IRC 34, as well as the MORTH last revision, it is giving the specifications. And for the design, we may have to combine the principles of IRC SP 42 as well as IRC 34. I just mentioned all these IRC guidelines because many times the question will come to people like us, where I will get the design of this, okay? So the design formulations, the specifications, the material description, and even the construction methodology, that's now getting covered in the MORTH and IRC guidelines. And the new development during the COVID time, a number of BIS codes also has come. So which really permitting beyond the road sector, the other departments also will be now having the clear guidelines on how the specification of the correct material can be selected and how the designs and the particular coefficients can be selected when these materials are being used with different types of soil. Okay? Because we cannot have the universal coefficients. It will depend on different type of the soil. So the guidelines are available. So you can see the extruded geogrid. Why extruded geogrid? Okay? Because as I mentioned, like in the case of the geotextile, even geogrids are not, everything is same. There are different types of geogrids are there. Woven geogrid is there, knitted geogrid is there, which were more popular last decade from 2000 to 2010. The Indian manufacturers were having only woven geogrid. For all other geogrids, we had to import from somewhere by paying 40% import duty. But in the last decade, so many manufacturers started producing other types of geogrid. So we can now select. For example, when we are going for the use in payments, their extruded geogrids are one of the best material. So that is why I am specifically writing extruded geogrids. But when we are going for the soil reinforcement application, like reinforced soil structures and all, the extruded geogrid may not be the right solution. Okay? There we may have to go for the bonded geogrids or geostrips. So this is again one of my message. These are, even if the family names are there is a number of subclasses there. And if we want to go for optimization and to best, definitely, we are talking about finally the sustainability and life cycle cost. So for that, for the optimization, a right selection is required. It's not a rocket science. We can, all the client organizations or consultants or the professors who are involved in DPR preparation or the quality verification, they can ask the manufacturer always, where is your technical data sheet? Okay, and the manufacturer is supposed to submit that, and the manufacturer is supposed to prove that. Whatever it is written there, it has to be proven. Okay, so definitely it can be asked, and that nowadays the advantage is that everyone is having the website, you know, even the Panwala or Namada Chayakadakaranu und website. So you can go there and see that it's not only the one who he is submitting, the whatever it is published in the website, there you cannot publish a wrong data. So through that also it can be verified. Okay. So, and you can see the cross sections, unreinforced and reinforced, the thickness reduction, whatever it is happened, indicatively it is shown in the illustration there. Okay. So the drainage composite, as I told that it is a core material which is sandwiched between two geotextile, and the core is for making the water flow to happen, and the geotextile will act as a filter which will not allow the soil particle to migrate within the drain, and it is allowing the water to go. And how the design will be? For the design, the discharge capacity has to be calculated, it has to be estimated based on the existing drains as well as the entire drainage network for the road. All right? And finally, for the separator geotextile. So even if in the different set of products which I told, the geotextile is the cheapest and very affordable, but definitely its selection also is important. For the selection of geotextile, two characteristics has to be the most important. One is the mechanical properties. Mechanical properties means its tensile strength, its puncture strength. If we are placing in a material which is having sharp edges, then definitely it may get punctured. So the material in such situations should have enough puncture strength. But if we are using it as separator or filter, we need to see the hydraulic properties also. The hydraulic properties are apparent opening size and permittivity. So apparent opening size is the size of the pores, and if the pores are too much big, the soil will go away from there through that. Okay? And the permittivity is the ability of the geotextile to make the water to flow through it. So these two characteristics are so important, and the right type of combinations need to be selected before deciding the correct geotextile. Okay? So this Andhra Pradesh project, it is a simple application. It is we have seen that it is a silty clay with a CBR value less than 3%. The water table level was higher, and the heavy design originally which was there with the conventional design, that has reduced, the base material has reduced to 40%. The overall material cost has reduced to 15 to 25 between that value, and the life cycle cost, the predicted reduction is 43%. So this is a project, next project, my story 2 on geosynthetics. This is from Gujarat, and here I can tell that it has already completed 10 years with a very good performance, and a number of papers published in national and international level, because this may be the first time in a public works department a significant length is enhanced with the various types of geosynthetics and monitored. So this is in Bhavanagar, and a road which is under the PWD that was totally disturbed due to very poor soil. And here ground improvement was a big requirement, because the soil CBR, the earlier one was less than 3, here it was less than 1. That means almost a slush. And this is a creek area, and it used to get waterlogged during the monsoon time. So something like our Alapi Changanasheri situation. And only thing, it is a creek area, and water will be having salinity also. So here, extremely soft soil, and this high ground water table, as well as high maintenance and repair cost. It was like every second year they had to do a lot of repairs, and after that also the riding comfortability was extremely poor. And uneven settlement and failure was also there. There was a consideration for liquefaction analysis, but it was seen that there is a saturation will be there, but the whatever the wheel loads which are coming, that is not high enough to liquefy it. So you can see the site condition. All right. So in this case, the first Gundur case study, I talked about 3 materials. One is the extruded geogrid, second is the geotextile, and third was a drainage composite. All are being used. But additionally, let us go to the cross section. Additionally, 2 more materials, okay? 2 more materials, like at the top, in the asphaltic layers, you can see a rod mesh is marked. It is in fact not polymeric materials, it is a steel mesh. Because that time the glass fibers, nowadays glass fibers are so popular, but that time glass fibers were not that much popular. So here a steel mesh is used in the asphaltic layer, and at the bottom for the ground improvement, there was a plan for them to use some type of stone columns and all, but it has come as a very big costly item. Okay, and it had to be brought from some distant places. Again, our carbon footprint was causing a problem. So, because the engineers there and the consultant was aware of it, even if the guidelines are not talking about carbon footprint and all. So, we avoided it with a bonded geogrid of high strength and high stiffness. Okay, so the extruded geogrid, whatever we are talking, between base and sub-base, if it is having 40 kilonewton per meter, the bonded geogrid, which is used between the subgrade and the in situ soil, it's having a tensile strength of 200 kilonewton per meter, and its stiffness value is between 1000 to 2500 kilonewton per meter. So a very high modulus and very high strength. And its damage resistance, creep resistance, all these are quite high. And that was being used in the ground. And even if any liquefaction tendency is there, that also will be absorbed by this material. And apart from all this, it was recognized that these are all strengthening, but the drainage is the key. So the edge drain, I mentioned about the edge drain in the last case study. Here also that was introduced, but here some retention also was necessary. So the initial conventional solution, it was PCC was adopted, but in this slushy material, if you are using PCC, you have to go for again a heavy ground improvement, or your base width will be quite high, and then also it can get cracked. So it was replaced by small gabion walls, just 1.5 meter for the base layer, and the upper layer a 1 meter. So together that has brought down the cost from 54 crore for a length of 14 kilometer to 34, 55 to 34, which is almost 37.5 percentage cost advantage. So that was a remarkable turning point, I think, for the highway industry. And this case study is being really come as a illustration that the type of geosynthetics, if you are selecting in a proper way, it can reduce the overall cost and it can prevent maintenance costs for years. The last 10 years, there was nothing, no cracks, no problem, no deterioration. And the 2018, the same department has extended the scope. This 14 kilometer, now I think they are going for the either stretches which are coming as the continuation, they are adopting in a different way. Definitely the solutions has little more optimized, but they are adopting the same solution. So now asphaltic reinforcement, I mentioned that steel mesh is being used. It was for preventing the reflective cracking and for absorbing all type of cracks. And for nowadays, the glass fibers are being used as a quite cost-effective alternative for asphaltic reinforcement compared to steel mesh reinforcement. Steel mesh reinforcement, of course, that will be really enhancing the durability in a bigger way. It will give higher strength, but you know, the rod mesh is definitely a costlier option. It may be something like 500 to 600 per square meter, whereas glass fibers you may be able to do with, say, between 75 to 200 rupees per square meter. Okay, so definitely affordable cost also is a part of sustainability. So now, if asphaltic reinforcement is to be done, everyone will first think about the glass fibers, okay? And it can definitely absorb the strains, it can prevent the reflective cracking. But if you are seeing that a lot of moisture intrusion is there, and that is causing the deterioration of the pavements. So in that case, you can use a composite, asphaltic interface composite, which is the combination of glass fibers and a geotextile. So the glass fibers will enhance the strain absorbing behavior, the reflective cracking will get prevented to a great extent, and the geotextile will be preventing the moisture intrusion. So the 3 case studies which are mentioned, those are being used in Andhra, in Jaipur, as well as in Bagdogra. So as it is a highway conference, I'm more talking about the highway case studies. But one place the glass fibers have used a lot, that is actually airfields. 2009 to 2014, so many airport payments, especially the payments in northeast area, they are being reinforced with the glass fibers, and they have really given a lot of relief to the engineers who are otherwise constantly doing the maintenance for these airfields. So glass fiber geogrid, you can see the image, glass fiber geogrid as well as the composite, where glass fibers are combined with a geotextile. And then the rod mesh also is there. Rod mesh is, you know, the gabion mesh. So it is in the longitudinal strength is quite good, but the transverse strength is only half. If you can shoot a steel rod in the other direction, it will become a rod mesh. And rod mesh is extremely good. South Africa has done a lot of research, and it's really good. But the problem is, one is the cost. Second is, if you want to again rebuild a rod, the milling will be difficult in the case of the rod mesh. Okay, so I'm going to the part B of my presentation. Here I want to talk about something which is very close to my heart. That's about the slope stability. In the slope stability also, a lot of innovative materials are coming, like IRC's one very popular manual, Hill Road manual. It's a very beautiful document, but many chapters are now having outdated technologies, so they are revising it. In the revision, all these are, it has already gone inside that. Maybe within a year it will get printed. Okay, but the good part is the original Hill Road manual, which was written, I think, 25 years before, that was also mentioning all this. It's not nothing which is newly coming. Okay, so only the revision is incorporating more advanced version, but originally it was there. So I'm really means and say bowing in front of the people 25 years before who thought about and who were having a vision. We will be having less aggregates, we will be having the less, we have to reduce the usage of cement and other type of conventional materials. So with the new, the Hill Road manual, as well as a slope guideline which is getting now printed within maybe 4 or 6 weeks, it will get printed. So all these type of new technologies which I am going to mention, that is getting covered. Okay, so you don't have to think about, okay, she told a lot of things, so but how we are going to use? It will be in front of you with the slope guideline from the H4 committee of IRC and the Hill Road manual, which is going to get published from the Hill Road committee. Okay, so I think all of you know nowadays about reinforced soil technique. So the reinforced soil techniques, if you are not having that much familiarity, I will request that. See, there is almost all big contractors in India, now they are, either they got projects already or they are going to get in NH66. From Kanyakumari to Kasaragod, we will be seeing all different types of contractors are having 35 kilometers each. 21 packages are there, and a lot of reinforced soil walls of different heights that is getting constructed with different agencies. So you can see all types of reinforced soil systems with the different types of geogrids, different types of fascias. So that is in Kerala. Concrete panel, segmental block, everything you will be able to see. So I'm not going to talk about so much it is, because it is already has come to Kerala, okay? If our Kerala, I know that a very sensitive subject, but if Kerala is coming, there will be a lot of reinforced soil wall, because we will not be able to go with the RCC or conventional structures, then it will be huge cost. That can be reduced only with the use of this type of alternate technologies. And again, we will be, if that is happening, Kerala is happening, we will be seeing from one side to other side, lot of reinforced soil wall. But with the reinforced soil wall, a lot of cut slope stabilization also is necessary in NH66 as well as in Kerala. So let me talk about that. So cut slope stabilization, and we Keralites are very much sensitive about even 1 centimeter of our property is going, right? Okay. So that was the whole problem. The acquisition, land acquisition was the greatest problem in Kerala. But I think NH66, they managed maybe a more, the friendly approach was there from the government side. So in the cut slope stabilization, the biggest challenge, whoever the consultant I met, they all told that everything is fine in Kerala. We can go with a very good vegetated fascia and all. But the problem is, everywhere people want 90 degree cut. Okay? So that is a problem. So if you are going for a nailing with a shotcrete fascia, which is a conventional method, or maybe a geogrid wraparound with a vegetated fascia, whatever it is, a little batter has to be there if it is to stay. If we are making a vertical cut in our lateritic soil, we think that it is really good, it can stand, but it is one of the dangerous, very dangerous material my friend Professor Unnikrishnan may be able to talk in a better way the laterite, the challenges. But I can tell in one line, laterite is a very misleading type of material, especially in places like Kerala, which is having a lot of rainfall. So there, if you are going for vertical cut, whatever be the solution you are doing, that will be having a implication. After some time, that verticality will cause a big problem. So anyway, that is not my topic for today. But what I want to say that if we can make a slide batter, we can really bring sustainability to it. Because we can have a vegetated fascia there. The type of soil we are having in Kerala, that's quite facilitating the vegetation growth. And the monsoon, whatever we are having, now I think it is spread in the whole year. It's not like the earlier times only in 3 months or something. So definitely the greenery will come. We will not be having any issue. Okay. So let us see that few of again the case studies which are being successfully implemented and which are working, which we can really import to Kerala or we can really adopt here, and so that we will be having more sustainability in our solutions. Oh, sorry. It's gone. Okay. Okay. So before going to the rockfall or landslide, the first one I selected for Kerala is the debris flow barriers. Something which always in my childhood I used to think about when we are seeing Adimalil, Urul Potal. I used to think that what is this Urul Potal? Okay. So, but I think now we all know that what is Urul Potal, right? So every year we are having in Kerala some calamities and a lot of small and big disasters which is happening, and it is mostly affecting the people around there. It's a social disturbance more than an engineering disaster. And how we engineers can rebuild it, how we can make it like that a sustainable system there. So I would say that let us learn from Uttarakhand, which really devastated completely. 2013, the flood affected Uttarakhand. I can tell you that if you were visiting the Uttarakhand just in 2013 after the flood disaster, you won't be able to sleep. You won't be able to sleep for weeks and weeks. Because I know that. It is my personal experience. After seeing that, I was not able to sleep for weeks and weeks. It was such a bad stage. You see, you look at the hills, it's all completely gone. You look at the valley side, it's also completely disturbed. You see the huts, buildings, everything is in a bad shape. But if you're seeing that now the last 10 years, they have done a lot of rebuilding exercise and they have incorporated a lot of sustainable technologies. I will not say that everything they are doing good. They are also doing a lot of something like just short-term solutions, but they are really brought some sustainable technologies. And more credit I want to give, the different departments were involved. NH was involved, BRO was involved, the state PWD was involved, but they have brought, at least in some DPRs, the monitoring, that also, which is also important. So it's otherwise it's all claims, right? Everyone is telling it will be a sustainable technology, it will be carbon footprint reduction. So I can tell to professor that for all my material, this is the carbon rating, but it is not in India. It is UK, some manufacturers have worked hard because I think that it is a requirement there. So I can tell that it is 80% to 200% I can reduce. But that will be having only validity when I am proving it and somebody is authentically validating it. So in UK, at least, UK means not the United Kingdom, Uttarakhand, they they have done some validation, and for some structures, the instrumentation also. Okay, so here I am giving to the credit, and definitely we may not be able to copy USA or Brazil or Southeast Asian countries, but we can definitely copy our Uttarakhand people, okay, or Himachal, even Himachal, very good work is happening. We can definitely, because Kerala is in so many ways, we are ahead of them in so many ways. We can definitely bring that here. So the first one, this is very near to the Kedarnath temple. So a system has to be used for debris flow protection. And what is being adopted, it was an umbrella system, okay? So when they have adopted it in India, maybe 2 or 3 agencies only were having the umbrella system, who can give the material as well as the technology, the design and the installation. But they adopted it. And the implementation agency was Nehru Institute of Mountaineering. They have implemented it. What is an umbrella system? It is something like an umbrella, which is having a fascia, which is with a high strength mesh. And then there is a nail, okay? A nail will be there, and those are starting as a combined product, okay? Combined product. And the advantage is that you can quickly place it, because these type of places, they are having avalanche prone. There you cannot just send your engineers and supervisors and team and peacefully sit there. It's a very risky area. So you need to quickly install it and move away from there. So they placed a series of this type of umbrella units, and from that, the last 4 or 5 years, the debris flows are properly getting prevented to create any problem for the pilgrims which are visiting the Kedarnath. Okay? And the beauty of the solution is, when the debris are falling, the system is getting more and more stabilized, because the nail is getting more and more embedded. Definitely, after a few years, it may require some maintenance, but it may not be coming every year. It may be, means, at least 10 years, 15 years, somebody has to go and do some debris collection. That can be used for the construction of some other stretches where landslides are happening there. Okay? So you can see the debris trapped by umbrellas. This was the initial year, just after the placement. So 4 days before, I got very beautiful pictures from Mr. Sudhir Mathur, who was the earlier geotechnical head of CRRI. He has gone for a quality evaluation of this Chardham roads, who is appointed by NHAI. And he just clicked this photo without knowing that we were involved in that. He told that, Mini, I have seen a very beautiful system. It is working. Shall I share with you? I told that, okay, sir, please share. And he gave a lot of photos. It is in my phone. I can share with who is interested. It looks very beautiful and very stabilized. Very stabilized, because when I was seeing the initial photographs of all this umbrella system, I was really feeling that, oh, whether this can really work or not when big debris are coming. And what Sudhir Mathur sir has shown me the photos, it's the debris are collected and it looks a very solid system, because the debris also is now a part of the structure. It is also becoming, means, I say, more stronger and more supportive, all right? So you can see the Kedarnath. And another aspect is that this snow umbrellas, this will act as a snow umbrella also. So this is an avalanche prone area, and when avalanches are happening, it will protect. So it is having a multiple way of protection ability is there. So if you permit, I can talk about the Chardham quickly. More than talking a lot about that, I will just show the photographs, because I think that I have taken a lot of time. So this is the Chardham Uttarakhand package 1 and package 2. There's the road was getting disturbed totally by the uphill slope failures and downhill slope failures. So in the uphill, there will not be so much space for doing a gabion wall or a reinforced soil structure and all. Whereas in the valley side, yes, you can place these type of structures. So in the uphill side, the combination of drapery systems and barriers were adopted. What is drapery system? Drapery system means when you can place, drape the hill slope with, say, with a coir, say with a jute, or with mesh or high energy panels as per the requirement. When your slope is more becoming steep, you have to go for high strength and high stiff material. But if your slope is gentle, there we can go with our materials like coir, which can be draped very easily and which will bring the vegetation very effectively and having very good moisture absorption ability. Coir is such a beautiful material. So whenever I used to go to different parts of the world for talking about the erosion, they all used to tell that you Keralites are so lucky, you are having such a wonderful material. So the coir is a drapery material. But the coir is having limitation when we go for higher slope or the rock outcrops where a lot of weathered material is there. There we may not be able to just go with the coir. We may have to go for something which is having higher strength and drapeability. At the same time, the drapeability. Okay? There we may have to combine coir because coir can still act as a vegetating material, moisture retention material. Okay? So in these stretches, you can see a lot of drapery systems application, including coir, and then a lot of barriers. And these barriers, earlier, Uttarakhand was using the concrete barriers. But after this flood-affected stretches, it was seen that if you are going for concrete barriers, the type of foundation it is required will be huge. And it's very difficult to construct it also. So in that case, they adopted steel barriers, okay? And steel barriers with a lot of flexibility, which requires foundation minimum, and which is standing more with the cables. And there are cables which will be acting like a fuse, so that if a problem is there, the fuse will act as a warning, so that we can go and rectify that area only. We don't have to remove the entire thing. So I'm just showing the photographs. Is it visible? Yeah, what you are seeing the image now, it is a reinforced soil structure which is having 25-meter high in a very high seismic zone with a lot of geological instabilities are there. Faults, it's showing all the vulnerabilities of the higher Himalayas. It's a 25-meter high reinforced soil structure, and there is a gabion fascia you can see, but gabion is not working as the stabilizing material. It is a geogrid is working as the stabilizing material. It's going almost 14 meter at the base level. After the 2 blocks, you can see again the reinforced soil structure is continuing, but with a vegetated fascia. Okay, and for that the coir has gone from our Alapi only, and the entire structure is working the last 4 or 5 years very nicely. And this is an instrumented structure. There are strain gauges to measure the strain, the pressure gauges, pressure cells, in the inclinometers. It's continuously monitoring that whether the structure is having any type of abnormal movements or any type of subsidence it is getting subjected. So far it is working well, but the monitoring will continue for another 2 to 3 years. So this is the structure, the cross section is there. I don't have the time to explain in detailed way, but if anyone is having the interest, there are published papers on it, I can share that. Okay. So finally, let us come to Kerala. Okay. So this structure, many of you may be knowing that this is very near to Kudiran tunnel, which is a very sensitive area, you know. For years before, suddenly a landslip has come and the traffic was stopped there, and it has to be re-established very quickly. And a lot of credit to the officers. I'm concluding. Yeah. Lot of credit to the officers who are involved, as well as my colleague of that time, Mr. Anwar, who was in Kerala. So they together has decided that they have to do a gabion wall quickly, and within 3 to 4 weeks, if I can believe whatever they told me, so they have reinstated within 3 to 4 weeks, a gabion construction and a slope protection with the coir geotextile. And the Kudiran is a global case study for us. So all the 50 countries, 100 countries where we are operating, the Kudiran is always a case study because of the speed. Within no time, it was being erected. So this was the cross section. And finally, Ponmudi, I selected this because last day Professor Unni was telling me a failure there. So I thought of, okay, let me my presentation can be ended with the Ponmudi case study. So the Ponmudi, it's really a hilly place, and a narrow road is going there. And years before, suddenly I got a call from Professor T.K. Gopalakrishnan sir, and he has told that, see, there is a repeated problem in Ponmudi. Maybe if you can send one of your junior engineer, I can explain that, and she or he can go to the site. So I sent one Anusha Ramanujam, who is from Palakkad. So she knows Tamil and Malayalam. So she came here, and with the departmental engineers, they visited the site. And everyone talked about stories that some rigid walls were constructed. Not sure it was RCC or masonry or whatever it is. But the main story was this, that every year from the river, which is the river body which is there, the rocks are coming and it is hitting. And after that, the structure is failing, okay? So, and there, the space is quite limited. There is a undulating rock at the bottom, so you will not be able to place a foundation properly, otherwise you have to excavate it. Accessibility also is limited. So definitely they were not able to, that visit, they were not able to come to a conclusion. So a second visit has happened. So this time TKG, Professor TKG, I think many of you may be knowing, many of you may not be knowing. He insisted that when you are coming, please come with a laptop and go to the site. Sit there and analyze. Okay, so we have gone with a little more preparation and went to the site. And what was being seen is, okay, yeah. So this is the site. Okay, now you can see a gabion wall there, but it was in a damaged, as I told that RCC or structure was there, and lot of seepage forces were there from the adjacent hill. The 6-meter narrow road, whatever it was going, a lot of seepage forces were there. But apart from that, when we discussed, we found that whoever has earlier conceived it, they have not taken the surcharge load from the hill. So they have taken up to the traffic load only. So once we are putting the traffic load plus the surcharge load, of course, whatever adopted earlier, it will fail. It is bringing a factor of safety of 0.5 or 0.6 only. So it was obviously you have to do a design by taking the seepage forces as well as the surcharge, then you will get a good retaining wall. So definitely you may have to think about the stone hitting also, but stone hitting alone didn't cause the retaining wall failure there. So once it is being done, a simple gabion structure, but with the proper foundation to fix the gabion properly to the bottom, and having apart from gabion is a complete free draining structure. It is having 30 to 40% voids. But apart from that, some drainage, additional drainage pipes also is provided. And together that, I think it is constructed now 12 to 14 years before or 16 years before, and it's working perfectly. So lessons, again, this is a part of the G6 disaster committees, one of the monograph, the Ponmudi case study. And these are the lessons the committee members have really highlighting there. It's definitely, once it is getting printed, you can see that. Now again, as a nutshell, when I am summarizing, so we talked about the use of different types of polymeric materials and the combination of it with different steel products. The good part of this geosynthetics and all, it is a very collaborative material. It's not like you remove everything and then let me go and stay. No, it's a very collaborative material. It will go with the steel, it will go with the concrete, it will go with the stone masonry. Okay, so it can really assure a lot of material reduction, life cycle cost reduction, and the quality improvement. It can work with the vegetation very well, so there is a ecological recovery, it will happen. It's many of these materials, at least in the granular level, some carbon credit evaluation is there, so we can have some primary understanding about that. And definitely, this is one option, not like this is the final option for everything. This is one option to get sustainability and life cycle cost reduction. So I would like to play this video, which is like a summary of what I talked about geosynthetics. Sorry. Can you press there? Yeah, it's a 1-minute video only. Thank you. By that time, if anyone is having question, and whether I am having time. It's a music. Let it be there. Any questions? Maybe I may get 1 minute or 2 minutes.
Madam, in the Gundur case study, the question was to reduce the thickness of the base layer, right?
Where is it? Oh, okay, yeah. Yeah, base layer, because it was coming 450 or something.
Okay,
so
and
the demand was to reduce
the
it.
base layer.
Yeah.
And the CBF was less than 3,
Yeah.
right? There are other solutions also, right?
Yes.
So many solutions. GeoCell is one such solution. So
Yeah,
why did
yeah.
you choose specifically this
Yeah.
geogrid, extruded geogrid?
Yeah. So the point is that GeoCell in 2013, okay, 2013, by that time, the GeoCell use what was established in India was erosion control and ground improvement. Even ground improvement, it has not come in any of the guidelines or anything, okay. Second is, when GeoCell is being used, you need to have, again, the aggregates, proper aggregates, and the construction will be slower because you need to pin it, okay. So these two we have considered GeoCell also, at least because there was a ground improvement possibility as well as base and sub-base stabilization was there. So we considered GeoCell and GeoGrid, but GeoGrid has come as a far more economical. So that is why we have gone for GeoGrid.
So this
And GeoGrid, extruded GeoGrid, the advantage is that you are going to get the friction, interlocking, and with the additional strength mobilization with its junction efficiency. So these three combination will make it quite attractive.
So the conclusion is that extruded geogrid is economical than going for a geocell.
No, it may not be. It depends on where you are working. Okay. It depends on a lot of factors. It depends on the type of place where you are getting a very good aggregate. Okay. Like last day I was talking with Ambika Bell, who is heading the payment division of CRRI. She was telling that one particular project in Uttarakhand, a lot of landslide has happened and very good material, which is excellent GSB material she is getting. So she is just putting geocell there and filling that material. Okay. So in some cases you are having wonderful aggregate. Very near to that case, geocell may be the better.
Okay, ma'am.
So you need to do instead of coming to a conclusion, oh, GeoGrid is the best or GeoCell is the best. Someone need to involve a specialist who knows about it and do the analysis. You ask the specialist, tell me that I am using GeoGrid. What is the total cost approximately? I'm using a GeoCell. What is the total cost? Including the installation cost. That is what we are forgetting. We think only about the material cost, but including the installation cost. Forget about maintenance cost because that is of future, right? So that much ask the specialist to tell you. So instead of going for somebody is pushing, my material is the best, and if you are putting everything will be magical. There is no material like that. You are having the authority and the freedom to tell that I need the best optimized section.
Okay, madam. Also, you have provided a composite drain
Yes.
on this side, right?
Yes.
And have you provided a vertical shield or like vertical geotextile membrane on this side?
No, this drainage composite, it is there, what you are seeing as
It is
the
wrapped in the
edge drain.
geotextile itself.
Edge drain is, it is vertically being placed.
Okay, whether it has a wrapping or not, I'm asking that.
What is it?
Any geotextile wrapping is given for that?
See, the drainage composite, the geocomposite is having two geotextile and a drainage core. That drainage core can be, it can be a geonet. Geonet means that it can be a polypropylene net or something, or it can be even geomat.
Okay, madam.
Okay. It can be geomat or geonet sandwiched between two geotextile. So there are different manufacturers will be having different combos. But what you can do is you can open MORTH 700. There is a drainage composite specification is there. IRC 34 is there, especially for flooded areas and all. So you can ask the specification matching from there.
Thank you, ma'am.
Thank you, ma'am. As a token of appreciation, we would like to present memento to Ms. Mini Kurula. So I invite Srimati Hygiene Albert, Chief Engineer Design, to present the memento. Thank you, ma'am. Next, we will have a paper presentations in 6 prominent tracks. Since we are running short of time, we are starting the paper presentation immediately. And the paper presentations will be conducted at 4 holes simultaneously. And the details are displayed in just the name board just outside the hole. And this is the symphony hole, and the paper presentations on the topic resilient payment technologies. It's in harmony. The paper presentation is on safety and resilience of transport system. In Sonata, climate resilient infrastructure, and in Melody, resilience in infrastructure project delivery. And since all the authors are ready for the presentation, and we will have the tea now, and we will all are interested to present at the holes, 4 different holes. Thank you. Completed his BTech in BMS College of Engineering, Bangalore, has published various peer works in peer-reviewed international journal and conferences and in national conferences, and has been honored the best student paper for relationships between structural, functional, and X-ray microcomputer tomography parameters of pervious concrete for payment application by Transport Research Board of National Academics. Welcome you, sir.
Thank you. Thank you very much. So, shall I start the presentation? Yeah, I'll just keep my video off so I can share my screen. Yeah, is my screen clearly visible in full screen mode? Okay. So, yeah, it's in between good morning and good afternoon. Yeah, so today basically we will talk about the resilient payment systems for urban infrastructure, challenges and possible opportunities. So basically this lecture I'm trying to confine to urban payments or urban infrastructure, because unlike highways, the urban payments also undergo severe damage or some other issues during some disasters. So let us see what kind of payments we have and how to address them, right? Before that, let us see a few things about sustainability and resiliency. So now, these two are like buzzwords in every sector of engineering. Talk about sustainability and resiliency. We hear these two words in every sector of engineering, be it computer science, electrical, civil, mechanical, etc. But these two, sometimes people use as a synonym, but these two are two different keywords or two different important words if you to understand initially. So let's say sustainability, if you see, it's the ability to meet the present needs without compromising the needs of future generations. So that means what? Whatever materials in terms of, let's say, payments, whatever materials we're using in construction, so we are using them to satisfy our current needs. But are we thinking of that? Do we have enough resources for next generations? That's where the question of sustainability comes into picture. So basically, it is the ability to be maintained at a certain level or a rate. Let's say, for example, we have built so many kilometers of highway. Now, if you want to further build more roads, should we use new materials or can we recycle the existing material so that we keep the rate of development at a constant rate? That way, we can be sustainable. On the other hand, if you see resiliency, so resiliency has a lot of definitions you can see in internet. So one definition I took from RDI, Resilient Design Institute, which defines as design of buildings, landscape, communities, and regions in response to vulnerabilities, disaster, and disruption of normal life. That means when we build any structure, be it pavement or a building, anything, that should be resilient to take care of any disaster, what it will be subjected to. In that case, if it cannot take the disaster, then that cannot be called a resilient structure. That means what? Let's say the building can be sustainable, but that may not be resilient. Like for example, we have seen like masonry buildings. Take a masonry building with all low carbon bricks, everything, etc. That way, the building can be sustainable, but if it earthquake or any other disaster happens, that cannot be resilient, right? So the incessant development, what we see in urban areas currently in India and other metro cities, so calls for sustainable and resilient infrastructure. So that way, we need to, when we build any infrastructure, it should be sustainable, also resilient, right? So if you see a typical sustainability definition, there are three domains we can say. One is environment, society, and economy. So now, if I see this intersection point where these 3 points are meeting, let me, I've shown a green color. Let me call this as gap. Now I'm calling it a gap, and it is related to quality of life inversely. Now, more quality of life, right? Lesser gap, or more gap means what? Lower quality of life in urban areas. So if you want to reduce the quality of the gap or increase quality of life, what we can do basically, we can bring the resiliency into picture. So when you bring resilience, the gap in this region decreases, or in other words, the quality of life improves. That means when you build any structure, it should be sustainable and at the same time resilient, so that we can actually balance the infrastructure, right? So resilient can be improved by following sustainable practices and vice versa. So obviously, these both should go hand in hand, and resilience and sustainability aims at improving the quality of life, what we generally see in urban areas. So generally, the sustainability addresses long-term problem, while resiliency addresses short-term problems, mainly in urban areas. Because in urban areas, we see severe heat wave, let's say 5 days complete heat wave is there, or let's say a severe storm is there. All these things cause for short-term problem. So I'm showing you a typical, it's a theoretical plot of resiliency. You can see in this particular graph, right? There is a, in the y-axis, we have facility performance, how it is performing. On the x-axis, we have time since it was constructed. So initially, when it was built, it is built for some particular performance. Now, with time, what happens basically, the performance decreases due to usage. But if there is some disaster, let's say severe flooding is there, or there is some, let's say earthquake is there, the performance decreases or goes to zero, or let's say to very lower level. So any resilient structure is something which can again recuperate or recover immediately and start providing continued performance. If it is less resilient, it will take more time to recover and again provide performance in the later stage of the life. So that way, our structure should be resilient where after any disaster, it should recuperate itself and start serving the public. That's where the resiliency comes into action, right? So now let us see urban development. With that background, we will see the urban development. Like you see in India or in other parts of the world also, urbanization is a very major problem, right? The WHO forecasts that 68% of world population will be living in urban areas in next 30 years. By 2050, we can see almost 68% in the urban population. So now what happens? As the urban area increases, so the development increases, the number of roads, number of buildings, the vehicle, number of vehicles, everything gonna increase, right? So with this fast development, the practices are neither sustainable nor resilient. So this actually gives call for what we call a severe threat for present and next generations. And finally, it is leading to something called as urban microclimate. So the urban microclimate is a very serious issue in many metro cities like London, Delhi, Kolkata, everywhere, because the climate in urban area is entirely different compared to the climate in surrounding regions. So let us see why it occurs and what are the positive factors. If you see a typical graph I'm showing you, where the red line with increasing urban population, basically what you can see in the lower graph, the number of weather calamities are increasing. That means what? The urban population, the urban areas are actually contributing more towards global climate change, right? Because they consume more energy and also emit the maximum amount of GHG, because we have vehicles, we have ACs, many things are there in urban areas where the contribution of urban area is very high compared to the rural areas. That is why with more urbanization, we can expect more climate disasters. Maybe you would have seen recently in many urban cities, we have flooding situations or heat wave situations where temperatures are rising. We can experience intense storm in short duration. All these things are basically positive factors of this incessant urbanization. If we talk about payments, now the payments basically is a part of urban infrastructure where they constitute around 35 to 50% of total area. To take any layout or in residential plot, etc. So approximately 50% to 35% is made of payments. Now what is payment do basically is? They will actually seal the surface. You build a pavement, maybe asphalt or concrete or any other pavement material. They will convert the natural ground, which was basically a soil, which had good infiltrating capacity, which had high latent rate capacity. It will convert into an impervious fabric in terms of pavement. We seal it with the pavement layers. So now what happens? Over time, we can observe some changes. Typically, in urban areas, we can see 4 changes. One is hydrological aspects, temperature in surrounding environment, noise characteristic, and air quality. Now, these are the 4 major changes what we have seen, and these changes are being felt nowadays. Not whenever the pavement is built, we don't feel it. But over time, when there is change in the weather conditions or climate conditions due to development, now we are feeling the change. Let us see this each change individually and let us understand it. Talk about ambient change in ambient temperature. Now, as we know that when we convert a natural ground into a pavement, the pavements are a material such that the thermal characteristic are they will try to store more heat. To take soil, soil has very high latent heat capacity. So what happens whenever the solar radiations fall on the soil, that heat is used to convert it into the moisture into vapor, it is consumed there. What happens the pavement, the impervious surface, whatever heat comes on the pavement, it is being stored. So this is what happens over time, the pavement temperature increases. Now you can see here, I'm showing 2 infrared thermometer readings here. In asphalt pavement is showing 73 degrees and concrete around 54 degrees. This is around 2 p.m. in the afternoon data. Now we can imagine that the 73 degrees, whatever the pavement surface is at that point of time, over time, this will exchange the heat to the air. Whatever air we see in the unit, that air will be actually warmer because of the pavement heat transfer. So basically, this causes something called as urban heat island effect. The overall development, like buildings, pavements, whatever we construct, they will lead to a system called as urban heat islands. So we call heat island because at that particular portion, we have more temperature. So we call it heat island. Certainly, this heat island is making a lot of buzz nowadays because everywhere with urbanization, people are actually seeing more frequent heat waves, right, in many cities. That's the main cause is urban heat island effects. If you see a typical pavement temperature, right, and air temperature. So this study was done in IIT Kharagpur in 2015, maybe 7 years back. So we can see the air temperature is somewhere around 34.2 degree maximum. But if you see the bituminous or asphalt pavement, it is reaching around 61.5 degree maximum. A difference of 27.3 degrees there. So where this heat again goes, again it get exchanged to the air, making the air warmer. So this way, the urban dwellers start consuming more cooling requirement like ACs, fans, where in turn consume more electricity, and a chain reaction begins. So that way, it is the construction of pyramids is some way causing the problem of urban heat island effect. I'm showing a typical simple calculation here, where you can see that so you can see here that the 1 kilometer of 20 pavement, let's say a 3.5 meter wide, can store heat energy of almost 4,000 megajoules. This is heat energy which is being stored on a pavement to this temperature difference of 27.3 degrees. That way, huge amount of energy is stored, and this energy is given back to the atmosphere during the evening time, increasing the air temperature. The second thing is something called as hysteresis lag. Now, what is lag basically? The air temperature and pavement temperature will not reach the same, the maximum temperature at the same time, because the pavement temperature or the pavement material takes certain time because of difference in specific capacity. They take certain time to get maximum, due to which there is a lag. And due to this lag, if you see this particular line, what I'm showing here, this dashed line, this should have been ideal air temperature, but due to the excessive lag, now the air becomes more warmer, and then it continues to be more warmer compared to what it has to be actually. So this way, increase in temperature is caused due to this concept as well. Right. So now, further, as the urban area becomes more warmer, what happens? As we know that the warm air rises. As the warm air rises, it also takes moisture with it. So water evaporates, and finally a cloud diffusion begins and start forming the clouds. Right, where when these clouds form in the urban area, we can experience intense short duration rainfall. So you might have seen recently in Bangalore or Hyderabad, in Chennai, everywhere, we expect very short duration, maybe 20 minutes or half an hour, with a very heavy, intense rainfall. What happens now? So whenever intense heavy rainfall takes place, already our payments or our ground is sealed with buildings with payments. This causes, again, flooding situation, what we call as fluvial flooding. So where huge amount of water starts accumulating in urban area, blocking all the drains, blocking all the roads, right? So this way, again, the second problem arises. Second problem is change in hydrological characteristics. Now, since the rain has been occurred intensely, the rainwater has no place to go because soil cannot infiltrate, it is sealed now. So what happens in the situation? If you see the hydrograph, I'm showing two hydrographs. One is pre and post urbanization. If you see the pre-urbanization, the runoff quantity is very less, and the time of concentration is very long. That means the amount of runoff takes longer duration to reach a particular point. So you have very less runoff and long time of concentration. But if you see post-urbanization, where the water has no place to go, you just want to build up within the area. What happens basically here? The runoff quantity is very high, and then the time of concentration is very low. That means you can expect intense flooding situation within short duration of time. That way, we can nowadays we can see everywhere this flooding problem in major metro cities, right? So you can see again some studies in Iraq and London. You can see how the increase in built-up area is causing increase in the runoff quantity. This is in Iraq and this is in London. You can see in London the curve is shifting towards left. That means what? It is shifting towards left means decreased time of concentration, and it also rising, increasing in height. That means what? Increasing in the runoff quantity, right? So this way it is causing the problem. So again, finally, this what condition comes to basically metro cities if you don't adopt resilient payments. And certainly the drains what we have currently in urban areas, they may not be able to take this amount of quantity of runoff immediately because either they are under designed or they are not maintained or they are clogged. Due to several reasons, the whatever runoff the urban area generate, the intense rainfall, they cannot take them. This way, whatever we call the roads, all-weather roads, so these all-weather roads now cannot be called as all-weather roads because they cannot be used in these kind of situations. So the question of resiliency comes into picture once again here. Even though this payment is made up of recycled materials or even made up of many other sustainable solutions, but resiliency is still pending here, right? So along with the imperviousness, what happens? We are sealing the ground. So along with flooding, the other issue is that water recharge. Since you have sealed the pavement or sealed the ground, the water has no place to go. Eventually, the amount of water availability in the urban area decreases. And that is where the prediction has been made by many agencies where in India will be the first country to face severe acute shortage because of the urban area or urban development what is being seen in India, right? Because they're encroaching lakes, right, and building apartments or layouts. So where these lakes once upon a time used to hold the water, but now they have been built buildings or maybe some other apartments where the amount of water has been lost, right? So that way, so in next 30 years, at least 1.69 to 2.73 billion people will suffer acute water scarcity. Already we can see in many areas like Bangalore, Delhi, there is so much of water scarcity where the only way they can drink water is the municipal supply to the vehicles. So they cannot get the water to taps because of lack of groundwater. Right. And second thing, in India, only 8% of water, rainwater is actually saved. Remember, 92% is not saved basically. So we need to bring in again solutions how to address imperviousness and also water recharge. The other thing problem is changing air quality. So as we know, the increased urban population will cause increase in trips, maybe work trip, school trip, or different kinds of trip. And finally, it leads to more air pollution and again increased vehicular emissions. So that way, it's a chain reaction builds up. Now, as per WHO, 98% of world population breathe air which exceeds WHO prescribed limits. So as we know that vehicle emissions has a lot of pollutants like NOx, carbon monoxide, carbon dioxide, PM 2.5, etc. They all cause the respiratory disorders. And in urban area, transportation is major pollutant because in urban area we don't expect industries, etc. It's only transportation causing the major pollution in urban areas. So the question arises, even though we are using BS6 emission standards, can they reduce the urban air pollution alone? May not be possible because if it was impossible, we could have seen drop we could have seen better air quality, but that's not the seen yet now. So it's not been yet felt better air quality. So the emission standards alone may not solve the problem, right? And second thing, the air pollution is spatially in nature. That means to take urban locality, within the urban locality, some portions may be having more air pollution. Typically, you take a bus stop or a bus depot, then we can expect more air pollution because it's a closed area. People are densely populated there, so we can expect more exposure, so more air pollution. To take roads or highways, these roads encounter less air pollution because the air is free flowing and the exposure conditions are very low, right? So one study done by Singh et al. In 2021, you can see that around this is a total amount of pollutant released in India in 1 year due to vehicle transportation. So you can see it's in teragram, 10 power 12 grams. So it's a huge number we can say where it is causing significant pollution. And India stands #1 in carbon contribution in the world. But we can check in the data, right? So again in Delhi, if you see Delhi alone, this is the density or let's say extent of pollution in 1 square kilometer. As we know, Delhi is very pollutant city, and this is a very big number which actually creates serious things in mind how to reduce this pollution, right? So obviously this causes severe respiratory pollution in the long run, right? And the things like bus depots, parking lot, etc., they have generally higher pollution concentration. So can't we or can we provide some other solution there where we can reduce pollutant? So how are other countries doing? How are they actually reducing air pollution? That we will see later. So with these kind of questions, with this thought what we saw, the question arises, are urban payments resilient? The current prospects may not look like. The reason being, these payments, even though we call it all-weather roads, in the event of rainfall, they get flooded. So they become non-usable and we can't use it. Second thing, also they start increasing the urban ambient temperature, which causes again causing increasing cooling requirements. So the other thing is that it produces noise as the vehicle moves, and also it doesn't address any vehicular emission requirements. So finally, where is the lack? So basically, the lack is we can attribute many reasons. So basically, the lack we see, we are accepting still the normal solutions. We are still using bituminous or concrete payments, right? Or we are not using any advanced technology or how other countries are doing. We are not thinking of those things. So because lack of experience or lack of expertise or mindset doesn't look into taking new technologies. So because if you see recently in urban payment, in urban domain, have you come with any new payment technology? Right? We haven't come with any new payment technology, where it can address this problem. Even though we face this problem daily, but still the problem is being continued without solving or addressing it. And the other issue, do we need impervious surface for every applications? Because you might have seen in urban areas, we have seen impervious concrete pavement for cycle track, a concrete pavement for a pedestrian walkway, which actually not required. So why, if you see these photos here, you can see a cycle track, but it's an impervious concrete pavement. So expect a cycle load. Do we need very strong pavement for this? And second thing, that during event of rainfall, since it's being impervious, it will contribute to total runoff. So because if it was made, let's say, an impervious surface, it could have been actually addressed the some issue. But here, since it's impervious, again it contributes to runoff, making the overall urban area flooded. So basically, we need to come up with a scheme or a methodology where we can identify locations right within urban area, and we can give different technology of payments which is suiting for a particular requirement. That way, we'll discuss some particular payment technologies which you can implement in several places within the urban area. First, let's see the pervious concrete payments. The pervious concrete payment is basically a payment where it is a pervious concrete slab. So how we have impervious concrete slab? Similarly, here we have a pervious concrete slab. So this pervious concrete is a special concrete with interconnected pore system. So basically, in this concrete, we don't give any fine aggregates. We basically provide a mixture of porous aggregate. So this way, we get good amount of pores within the structure, where at least 15% porosity is maintained, right? So with this particular pervious concrete, we can actually achieve a strength of up to 30 MPa easily. The 30 MPa is very good enough for a pedestrian walkway, for a cycle track, for the parking lot, etc. So that way, this pervious concrete can be provided in those locations where we encounter low volume traffic. You can see the picture I'm showing here. This is an image of X-ray tomography, where the green color indicates the pore structure. Right? When we remove the gray, which is a concrete, the green color, what you see, it's a pore structure, and you can see the pore continuity. So it is completely, it has completely pore thing from the top to the bottom, where whenever the water or falls on it, or whenever rain occurs, it can easily percolate from top to bottom, and it can be transferred to soil for water recharge. And you can see a 2D image I'm showing here. These 2D images show how the pores are spread from top to bottom homogeneously. So that way, these pervious concrete can be one of the solutions to address this issue, right? Typically, it consists of a pervious concrete slab, right, and a reservoir layer and a subgrade. This reservoir layer acts as a temporary storage for the water. So whenever the pervious concrete slab acts as a gateway, the reservoir layer acts as a temporary storage, because the infiltrating capacity between the pervious concrete slab and subgrade is very much different. So to store the water temporarily, we just put the reservoir layer where it slowly percolates to the subgrade. So there are many studies where they've shown that after rainfall, the water has been percolated subgrade even to a depth of 1 meter below surface. That means the water can easily percolate subgrade, right, from the reservoir layer. And this is some test sections where it has been built in Tirupati in municipal office. You can see this section where the municipal entrance approach road, where on this road daily the cars or bikes and these small trucks will daily go on this, and this has been working very excellently. And this is test section what we did in IIT Kharagpur when I was doing PhD there. So this section we just like to understand how to actually construct those payments, because we have a different mixture, we have a different technique to build. So we try to construct and see how this can be actually built in a very easy technique. These are products what we come up in India from different institutes. So if you see in IIT Kharagpur, we have normal pervious concrete, where made up of different aggregate sizes with different porosities. So recently in IIT Bhubaneswar, we came up with what we call a two-layered pervious concrete. So this two-layered pervious concrete functions very well, reducing the abrasion and also reducing the clogging. So basically it reduces the clogging and also reduces the abrasion, making it much more robust than the normal pervious concrete. And also IIT Tirupati, they come up with Parampin, that is pervious all-weather payment systems, where it also addresses strength and clogging problems. And IIT Bhubaneswar and IIT BHU has also come up with pervious paver block. So these many products we have in India, which can actually act as a resilient payment system for urban areas, right? So along with the stormwater problem, whatever runoff it occurs, it can take into account. So along with that, the pervious concrete pavement can also reduce the urban heat island effects. So how? Basically, if you see, the thermal properties of pervious concrete are very much conducive to reduce urban heat island effect. So if you see the albedo, now albedo is a parameter which is basically a ratio of reflected radiations or incident radiations. So basically, people who work in climatology, they will very well know about albedo. So basically, any material will reflect some radiations. You see the asphalt material or bituminous material, they are having very low albedo. That means they absorb more heat, they won't reflect. But the pervious pavement will actually reflect the heat, I mean, it reflects solar radiations without actually storing them, right? One way. Second thing, the thermal conductivity of pervious is very high. That way, it won't actually store heat. It starts conducting immediately to the air or to lower layers. And also the specific capacity is high, making it takes more time to heat the pervious concrete. So by the time the temperature will reduce, and hence the pervious concrete also won't store more heat. The same experiment we have done in IIT Kharagpur in this particular year, where we compare temperature of bituminous or asphalt layer and pervious concrete layer. You can see a 10-degree difference was found between the temperature of bituminous and pervious concrete layer. So this 10 degree will make a significant contribution towards reducing urban heat island effect. So this way, the pervious concrete can address both the flooding problem or pluvial flooding, what is in urban areas, and also the urban heat island effect. So application was, if you see these applications, you can see ideally parking lots are very good because these parking lots cannot require a dense asphalt or concrete pavement. Certainly because we expect maybe maximum a 2-ton car to take any big car like Toyota Fortuner or any big car, hardly 2.5 to 2 tons. Those cars may not require dense asphalt concrete pavements. So there we can provide this kind of pavements because the parking lots are generally exposed to the surface open to air. Whenever if you provide dense concrete pavements, they will actually result in lot of flooding because all the water which is coming on the parking lot will add on to the surface runoff. That way, if you provide the pervious concrete pavement, they can act as an artificial lake, right? And they can actually recharge the groundwater and also reduce contribution towards runoff from parking lots. Second thing, pedestrian walkways. So in the walkway, generally we have seen it providing dense paver blocks. Now these dense paver blocks actually they're not required because we generally if you see we provide M20, M30 concrete paver block for walkways, which is very much not required for a this walking purposes. And these paver blocks also become slippery over time. But if you provide pervious paver block, they improve skid resistant and also it doesn't also help in water recharge over time. And on cycle track already we saw that we can provide these pervious concrete cycle tracks. And finally, the campus roads in ITBT parks or institutions or residential layouts where you don't expect heavy traffic vehicles at all. So that's why we can actually design the urban area such a way that we can identify some locations where we can put this kind of payments, observe the performance, develop the identify merits and demerits, and come up with further solutions. Right? Then, resident solution number 2. If you see the second issue was air pollution. Now, as we know, even we have BS6, still air is polluting, getting polluted. So basically, we have something called as photocatalytic payments. Now, this photocatalytic payment works on the function of photocatalysis. This photocatalysis is a process where the material gets degraded in the presence of catalyst and the light. So whenever light is being incident on a surface, it's solar radiation. And if you have a catalyst, example, titanium dioxide or zinc oxide or a silicon carbide, they can actually react, right, breaking the pollutants like NOx, let's say NOx, nitrous oxide, into less damaging nitrate or nitrogen and oxygen. So this way, we can reduce the amount of pollution in the urban area, right? So that way, you can see many, in many countries, they're using it. For example, if you see this in the top picture, the mixture of titanium dioxide and water is being sprayed on the existing asphalt pavement, where it acts as a photocatalytic layer and it reduces the amount of air pollution. So this study has shown that approximately in and around the region, 40% of nitrous oxide concentration was reduced with this implementation. Second thing, if you see in Belgium, they're using the paver block where the top 5 to 6 mm is made up of the photocatalytic concrete paste. So again, this study has shown that approximately 36% of nitrous oxide concentration was reduced in the particular region due to photocatalytic concrete. Obviously, we can also go with pervious concrete, where the pervious concrete provides better reaction sites for the photocatalytic activity, right? If you see application-wise, so these photocatalytic materials can be either sprayed on the existing pavement, or we can actually lay, when you lay a new pavement, a thin layer can be applied on the pavement, right? So if you see application-wise, ideally we can go with road intersections, because these intersections we have more pollutant concentration because of repeated acceleration, deceleration, etc. Right? So reaction take place at a faster rate. And we see bus depots. Now there are many good studies we see in India also, where they have compared the respiratory health issue or respiratory health of a bus conductor or a bus driver with a control like a teachers, right? The very good studies where they compared this health issue, health, respiratory health. They found that people who work in the bus stops, right, or railway stations, they're having severe respiratory disorders compared to control sample. The reason being they're exposed to more pollution. This way, these bus depots can be sprayed with the protective material, eventually reducing the concentration of pollutants in the particular region, right? And obviously, cycle track and walkways, because the cycle track and walkways or pedestrian walk, they're exposed to more pollution because when the people walk or do cycle slowly, you're exposing more for the air pollution. That way you inhale more polluted air and it may cause more damage to the health. So those track, we can actually spray these kind of components, and certainly we can also put in near hospitals or the ITBT parks, etc. So this way, these payments or this kind of technology will reduce air pollution over time and decrease or improve the air quality in and around the urban region. Right. The third solution is something related to the snowfall. So we know that in South India we will not see much of we don't see any snowfall at all. But if you see in the north regions like Himachal Pradesh or Shimla, etc., there snow is a very big problem. But due to snow issue, what happens? The whole roads gets blocked for several weeks or several days, which is impacting their socio-economic development. Right, everything comes to standstill there. So because recently I had gone to Shimla, a few months back, where I was told to check out immediately because the prediction was snow was coming the next day. So I asked what will happen. So then they told, people told that if snow occurs, at least 1 week will be everything will be blocked. The roads, the hotels, the electricity may not be available, the water may not be available. So it becomes very problematic for them to actually move from one place to another. Right? Even though we call it all-weather roads, during snowfall they become non-functional. Right? So as we know that this tourism contributes approximately 121.9 billion USD in the year 2020 for country's GDP. Tourism in the northern country like Shimla, Himachal Pradesh, every year huge amount of tourists goes there to see the snowfall. But whenever there is a blockage or there is a snowfall, it is stopped because of the roads are completely covered with snow. Right. So how do we actually make it snow free? Right. So in that case, we have hydronic payments. So these hydronic payments are the payment technology which has been tried and tested in many snow-prone regions. You take it Sweden or Norway and many other regions, they have come up with hydronic payments. These hydronic payments are very interesting payments where we, within the payment, we lay a pipe. So through this pipe, you have to circulate the warm water or a hot water where it can increase the asphalt pavement temperature or a concrete pavement temperature and melt the snow, eventually making the road easy to travel, which will actually play a very significant role in the socio-economic development of those people in the snow-prone regions. You can see here, the hot water reservoir is there. This hot water reservoir, the hot water can pump it through the pipes, right, which passes through the pavement, right, and warms the pavement. As pavement gets warm, the ice will melt, right, and then the pavement becomes snow-free. And again, this water can be recycled to the hot water reservoir to again circulate it once again to the pavement. And this is how a typical cross section looks like. So you have an asphalt pavement. Within the top, let's say 60 mm, we lay this pipe. Certainly, there is a lot of work is being done in this domain in many parts of the world. Even in IIT Bhubaneswar, we are trying to work on this, where we are trying to optimize the pipe diameter, the pipe pattern, and the thickness of the asphalt layer, etc. We're trying to optimize and understand how we can come up with the optimized structure this way, right? And if you see some implementation pictures, so these are typical how the cross section looks, what I showed. So you can see here in this particular region, so this is a heated portion, a reference portion. Now if you see in this heated portion, when after some time, when the hot water is being passed through the pipes, eventually the road becomes snow free. So third what, when the road becomes snow free, people can actually use it for transport activities without impacting the tourism or the local requirements. So if the application wise, we can apply in snow prone regions, right? Obviously, and also it will prevent blockages, improves tourism, and improves social development of those people within the region because they contribute significantly to tourism of the country, right? So with this, how are the other countries are doing? If you see our neighboring country like China, so even China also facing the heat of urbanization. Even they also face situation what we face in India, like flooding, UHA, etc. So how are they trying to tackle it? In China, they come up with something called as sponge city. So this sponge city is an urban development scheme where they're trying to make the urban development more water friendly. Wherever possible, providing lake, using permeable pavement, constructing green roofs, it can actually reduce the urban internet effect and also recharge the groundwater. Similarly, in USA, they call it low impact development, what called LID. So LID means where you develop the infrastructure without causing high damages to the environment or the urban area. So if you build an asphalt pavement or a concrete pavement wherever is not actually required, that becomes a high impact development because the development may impact the environment in the long run significantly. What we saw in the previous slides. Like in Australia, we have water system urban design. In Germany, decentralized urban design, and in UK, sustainable urban design systems. So like this, they have particular plans because even they're facing the same issue what India is facing. But India, what are we actually doing now? Do we have any schemes? Even though we have smart cities are there, but if you compare the other countries' version of what they call smart cities, they're somewhere lacking behind in actually implementing those new solutions, right? So that's where challenges comes into picture. The challenge if we see challenge-wise, one is we mostly follow normal approach, right? We don't try to implement new technologies or we are not aware of new technologies which will actually make us to plan or utilize the normal approach and lack of past data and experience. Generally, whenever you want to implement something new, we look for how it will perform or what is the experience of other experts with this technology. But whenever we don't implement, it's not implemented yet. So we need to actually implement it and then start collecting data and understand the merits and demerits and then make corrections to further implementations. And we'll change mindset accepting new technologies. So whenever new technology comes into picture, mainly in urban area, we need to freely accept them because going with the normal approach may cause severe damage in the future, coming future, and less time frame. We don't have much time frame to start thinking what is the cause, how to proceed. Already we can see the heat of urbanization everywhere. So basically, we need to start implementing solutions, understand it, then revise it wherever required. And also, do we have relevant resource for research? So whatever our labs or our engineers, what do we have? Do they are accustomed with this kind of technologies? If not, should train them to make them ready for these technologies. So that's where the opportunity comes into picture. If you see the opportunities, there are plenty of opportunity in India for urban payments because we are still moving with asphalt or concrete payments. But if you see the technology what I discussed now, so those are not being implemented yet in India significantly. So one can take the opportunity to implement them, right, through urban municipality and understand their performance. And so we can actually build up a good document or repository to further implementations. And collaborating with local municipal and experts. Local municipals can take the action or take the initiative because they have all the powers to do it. They can take initiative of implementing them in local areas because development should start from locally and then go towards the region ones. So local municipal can take initiative, implement them with experts, and then implement further to make it more resilient. And huge potential for research in domain in resilient payments. In India, we don't much work on resilient payments, but yes, there is huge potential for research in this domain because there are several solutions to be addressed in urban area, which we can actually do through a good amount of research. And finally, a training program for on resilient new technologies. So basically, we can come up or we can train our engineers, maybe government engineers or private engineers, on what resilient technologies are there, how to implement them, what are the do's and don'ts, merits and demerits, so that they are aware it, and slowly, once we sensitize them or once we educate them, they can be implemented wherever possible, and then we can actually make the urban system more resilient, like how other countries are actually doing, right? So with this, I end my lecture here, right? As one professor by MIT, Chomsky, he tells that the general population doesn't know what's happening, and it doesn't know that it doesn't know. It's very interesting thing that the population of urban people, they don't know actually what's happening. But we as an engineers can actually address this problem through proper techniques or proper training to make the urban area more resilient and sustainable. Right? Yeah. So we can take up some questions now.
Sir, how will you connect the urban microclimate with the island heat effect of urban island heat
Yeah,
effect?
urban microclimate.
Urban microclimate. How you connect that with the urban heat island effect?
Yeah. So now actually what happens, whenever we over time we've seen that the urban temperature has been rising, right? Due to building materials. Now this increase in temperature, it will actually cause the warm air to rise up, right? And as warm air rises, it causes more rainfall. So this kind of thing you can observe in rural areas. You won't see in rural areas, intense rainfall. That way, the increase in temperatures cause the urban microclimate.
About the photocatalytic agents interventions, how far it will reduce the future problems?
Yeah, actually, currently we see many countries that are implementing it's performing very well. At least 40% of this NOx, nitrous oxide, can be reduced by applying photovoltaic materials. So we can just spray it on the existing road and it performs very well. And every 2 years we can actually spray it. That's how the other countries are doing.
Okay, sir. Okay.
Yeah.
Thank you, sir.
Yeah.
So regarding the pervious concrete, is there any study has been done regarding the time and the rate of permeability?
Yeah, we have done a lot of studies on that particular aspect in IIT Bhubaneswar and IIT Kharagpur also. Like we have seen that the permeability can range from 0.5 to 5 centimeter per second, which can actually take care of any amount of rainfall in India. In fact, in the second half, we have a presentation on showing how we can design the pervious concrete for different urban areas in India, maybe at 4 p.m.
Okay, sir.
Yeah.
Thank you, sir.
Yeah.
Next, we will begin the paper presentation session.
So, should I be present here?
Pardon, sir?
Yeah, should I be available now for the meeting for this presentation?
Thank you, Dr. Anush. We would be continuing with the paper presentation. So if you're interested in attending, you can stay back in the Zoom. I think the papers that you are co-authored would also be happening in the few moments. Yes.
Oh, sure. I'll be available.
Okay. Thank you.
So let's start the paper presentation. So the first, and we have panel. So the first paper presentation on the title, Resilient Pavement Construction Using Alkali Activated Inorganic Polymer Concrete, authored by Thomas John V. and Dr. Roy M. Thomas. And now it's presented by Thomas John V. Welcome, sir. And sir, we have total of 10 minutes for the presentation, followed by 5 minutes questionnaire and answer session. And at the 8th minute, we will ring the bell. So can you please play it? So this will be the 8th minute bell. Yeah, okay, so shall we are starting the session.
Respected senior engineers, distinguished faculty members, fellow engineers and fellow researchers. This is a study based on experimental basis and field study. The title is Resilient Pavement Construction Using Alkali Activated Inorganic Polymer Concrete. This is generic name. The most popular name is geopolymer concrete, but I am not using the term geopolymer concrete because of specific reasons. So alkali activated concrete is made out of raw materials such as GGBS, sorry for the spelling mistake, GGBS, GGBS plus pi ash, and a combination of so many other things. And the commonly used alkali activator solution is sodium silicate or sodium silicate plus sodium hydroxide. And the direct advantage is high strength. Very high strength concrete can be made. Very easily we can make M60, M70 grade concrete. Early strength gain, within 3 days we can attain 90% of the strength in many cases. It is durable according to literature, and curing at ambient temperature is possible without using water, and it is overall economic. Indirect advantages are low embodied energy, lower carbon dioxide emission, use of industrial waste materials, and conservation of natural resources such as limestone, water, etc. And it can be considered as a partial substitute for OPC. And the limitations are brittleness. Any material which is very strong in compressive strength, and if there is no proportional increase in the tensile strength, the material will be brittle. And if it is not properly designed, there could be chances of efflorescence, carbonation, surface erosion. And there are limitations in technology dissemination to the grassroots level. The absence of code for RCC is a problem. And, recently, an IS code has evolved for the precast applications. And the next thing is embodied energy level. This is based on a literature, and I have made the calculations. Regarding the embodied energy, for alkali activated concrete, it is 1198, and for the conventional concrete, it is 1812. And corresponding savings in the carbon dioxide emission is also shown. And assumption is taken based on we are using 400 kilograms per m cube of the binder. So this is a study conducted with the fly ash. F stands for fly ash and G stands for GGBS, various percentage of fly ash and GGBS. And we can see that at higher strength, 93% of strength is available at the 7th day itself. And maximum and minimum strength is given because in the case of polymerization process, there is a variation, great variation in the strength. And as per the previous IS code I have shown, the design strength is taken as 10 megapascal less than the target strength, irrespective of the grade of concrete, mainly because of the variations in polymerization. And this is a compressive strength taken by the 100 mm mortar cube. The previous one is conventional standard mortar cube. This is 100 mm mortar cube, and we can see that even for 1:4 mortar ratio, a 50 megapascal strength is available at the 28 days, and even on 3rd day, it could get 48 to 50 megapascal. And this is a concrete using the previous ratios, fly ash and GGBS in various proportions. And the mixed proportion is 1:1.5:3. The mixed design is not so significant. The major factor is the content of the binder per m cube. And for various mixed proportions, mixed proportion is 1:1.5:3 for all the mixes. And for the various proportions of fly ash and GGBS, it is given like this. And the maximum strength is obtained when the fly ash content is 0 and GGBS is the highest. And variation is also given with respect to the maximum and minimum strength. And this is the study done with GGBS alone for various mixed proportions. And as we have seen previously, where the GGBS content is more, the strength is more. And down when we are coming to 1:4:8, 30 megapascal is available on at the 28th day. The economic analysis is taken like this. The cost of the aluminosilicate powder is taken as an average of rupees 5 per kg. The cost of the required alkaline solution is rupees 11 for 1 kg of the powder, and total cost comes to 16 rupees per kg for 1 kg of powder and the equivalent amount of alkali required. So the quantity required for M25 to M30 is 150 kg, and the cost at the present rate is 2,400 kg. And assuming that we are using 350 kg per m cube of cement for such a strength, the cost incurred is 2975, and with an additional benefit of not water requirement for curing and low carbon dioxide emission. And this is the binder requirement for various proportions and various strength. And as you see, when it goes for higher strength, it may not be so economical because not only the powder content is increasing, the cost of the alkaline solution is also increasing, which is more detrimental. More than the cost of the powder, cost of the alkaline solution is very detrimental. So while going to higher strength, it may not be economical than cement. And that average density wise it is higher. Density is 2430 to 2530. And applications can be used for any precast applications. I have brought some products here. Any precast application, paver blocks, flooring tiles, cover blocks, artifacts, etc., etc. And for road work, it can be tried. There is some limitation. I will tell what is the limitation. For making lightweight aerated compounds, this is a lightweight aerated block. Specific gravity is 0.4. And for making heavy duty industrial flooring, because it is acid alkali resistant as per the literature. And for making precast pre-stressed elements, I am doubtful about that because this product has got more shrinkage, so it may not work in the case of pre-stressed concrete components like our electric post and all. It has to be checked whether it can be done. For making anti-sea erosion work, I have done a trial with a specimen at Chellanam. And for enhancing the durability of the existing structures, that is my concept. If we encapsulate the existing weaker structures, or if we can grout with this material, the durability can be enhanced. For making self-compacting concrete, this is an ideal option. And for making turfing block also, it is feasible. The field advantages are compressive strength very high, 60 to 70 MPa. Required slump can be attained, and slump retention can be also attained with suitable admixtures. There is no need for chemical admixtures, even though many of the researchers are using different types of chemical admixtures. I am using only very limited way mineral admixture only. The soapy action of the silicate solution will give better pumpability. That has to be checked because I don't have the concrete pump with me. So it is also an added advantage. No need for water curing, as I told you earlier. Low heat of hydration and good surface finish. No plastering is required for the products. Coming to the summary, F0, the 100% fly ash cannot be set at using the sodium silicate alone. Definitely, when we are using fly ash alone, we need the use of sodium hydroxide. So I don't like to use the sodium hydroxide because it's a hostile material. So I have used only ambient temperature conditions only. Studies show that sodium hydroxide is a dispensable material. Only sodium silicate can be used to attain the required strength. And when the GGBS content is more, the strength increases. And then optimum condition will be 25% fly ash and 75% GGBS. So the content part is over. So the limitations are, it can cause efflorescence, carbonation, etc., if we don't properly design. Earlier I had the problem. Now I have overcome the problem. I will show you the case studies quickly. This is a large pothole at Trichure. There was an inherent reason for that, and this was filled with paver blocks using sodium hydroxide and sodium silicate. So after this is a finished view, and after 6 months, the top surface eroded, mainly because the free sodium hydroxide on the surface reacted with the carbon dioxide from the atmosphere and formed sodium carbonate and calcium carbonate, which are the softer materials. The top thin layer is eroded, and still it was intact for 3 years. And after 3 years, the entire surface was covered with bituminous pavement. This was a recurring problem at Trichure. This is at Westport Junction because of some inherent problem, because of some leakage of the pipeline underneath. But after laying this, that recurring problem was stopped. Leakage may be still underneath, but that recurring problem was over. This is a comparison of The square one is alkali actuator conduit, the other one is conduit thing. This was done at my institution. This is a closer view. What small dots you see is the bug holes. It was there even when it was laid because it was made with very low water content. The center portion is not having any bug holes. So if we conveniently adjust the water content, bug holes can be avoided. Okay.
Sorry, I mean, the 10 minutes is over, so you could please wind up. Thank you.
This is a pervious block. Thank you.
Thank you. Any queries, questions? We can take up some questions. Anybody?
I have displayed some products here during the lunchtime. If anybody is interested, can see.
Okay.
Thank you.
Thank you. Thank you so much. The next presentation. So the next presentation that we have in this track is .NET, a design overlay thickness prediction model for asphalt payments using deep neural network architecture. The authors are Ashwini K. Haridas, Naga Shiva Pavani Peraka, and Krishna Prapurna Biligiri. I hope Dr. Pavani is here on the online platform.
Yes.
Yes, Dr. Pavani. So you could share the screen. As we discussed before, we have 8 minutes a break. So that is a bell that would ring indicating that you have 2 more minutes. And we would request you to wind up the presentation by 10 minutes, followed by a 5 minutes discussion.
Thank you.
Thank
Let
you.
me start sharing my screen.
Yes, sure.
So I guess my screen is visible now.
Not yet. Visible, Pavani. Please continue. Thank you.
Thank you. Good afternoon to the engineers, faculty members, research scholars, and the organizers of NCRI. So I am Dr. Nagsal Pavani Perka. I am currently working as an assistant professor at GMR Institute of Technology, Rajam, Andhra Pradesh. So today I am here to present a paper, research article titled .NET, which is a design overlay thickness prediction model for asphalt payments, which was developed using deep neural network architecture. So first, before entering into the contents of the presentation, first I would like to thank my co-authors. So Ms. Ashwini K. Haridas, she is right now working as an engineer at Vasuprada Consultants Private Limited. So this article has been drafted from some of the results presented in her master's thesis, which was submitted at IIT Tirupati. And I would like to thank Dr. Krishna Prapurna, he is my PhD supervisor, and who guided Ms. Ashwini for carrying the MTech thesis work. So the contents of the presentation include introduction to the basics related to the pavement overlay thickness design and the neural network architecture, followed by the objectives, methodology, and the development process of deep Yeah, as we all know, the asphalt payments usually deteriorate over time due to the application of cyclic application of repeated traffic loading and seasonal and climatic variations. So, due to the coupled effect of these parameters, payments usually experience and a lot of distresses. So, which will not just increases the maintenance cost, which also increases the vehicle operating costs as well as the vehicle operating costs. So, which could be termed as like road users cost. So, in order to conserve the payments, we have to maintain the payments in a regular manner so that it can the payment could be serviceable during its entire design life. So in order to improve the service life of the payment, regress maintenance activities, maintenance interventions have to be planned in an effective manner. So in order to plan the recurrent maintenance interventions, so payment condition assessment have to be performed at a regular interval. So the payment condition assessment includes both functional as well as the structural condition assessment. So after performing the functional as well as the structural condition assessment, the one should come to know what is the structural integrity of the existing payment system and how much um, uh, like whether the payment is able to bear the traffic, the future traffic or not. If it is structurally deficient, we have to perform we have to go for either minor rehabilitation, major rehabilitation, or reconstruction activities based on the structural deficiency of the existing payment system. So HMA in asphalt payments, hot mix asphalt overlay is one of the predominant resurfacing techniques which we mostly perform on asphalt payments. So the designing, like when we design an overlay, design for an overlay, we always consider about one should consider the structural performance of the payment. So usually the structural performance of the payment is mostly evaluated by performing either destructive tests or non-destructive tests. So in non-destructive, so the destructive tests include the coring of the coring a certain portion from the existing payment system and analyzing and performing various laboratory tests to understand the structural and strength related parameters of the payment. But whereas in non-destructive testing methods, we usually go for like either falling weight deflectometer. We use a Benkelman beam, falling weight deflectometer, or rolling weight deflectograph to measure the response of the payment system due to the applied impulse load. So the non-destructive tests are mostly categorized into deflection-based methods and wave propagation-based methods. For wave propagation-based methods, we mostly use ground-penetrating radar. So the results that the responses that the ground-penetrating radar gets from the during the test requires a highly computational intensive, and which is considered to be not economical for the agencies which are very tight in budget. So in order to develop and get the deflections at the by simulating moving traffic load, so most of the agencies have been using falling weight deflectometer to study the structural integrity of the payment systems. So the basically after performing the falling weight deflectometer test, we get the deflections measured at several radial distances from the applied impulse load. So those deflections will be further assessed using various mechanistic and empirical methods of overlay design to study and determine the overlay thickness for the studied asphalt payment system. So during the ME, for designing an overlay thickness considering mechanistic and empirical methods, in addition to the deflections, we consider the expected future traffic, environmental factors, structural condition, and material properties. So, but the ME methods are found to be iterative, and we have to perform and a lot of analysis have to be performed to get the overlay design. And the researchers have come up with the use of artificial neural networks to automate the entire ME-based, to automate the overlay design, considering various factors. Okay. So let me show some of the articles in which they have used the artificial neural networks to predict the overlay thickness or to study some of the parameters related to the structural performance of the payments. So in some of the studies, researchers have developed artificial neural networks to detect potholes. In some of the studies, researchers have developed artificial neural networks, which is referred as NN, to predict international roughness index from the distresses. And in one of the recent studies, researchers have developed an artificial neural network to study the deflection ball parameters from the functional conditions, which included the distresses, roughness, and the traffic loading. So, in order to, but basically the
Dr.
interfaces
Pavani, can you hear
associated
me?
with the following by deflectometer test to evaluate payment structural condition includes rigorous back calculation process, frequent conduct of condition assessment tests, and determination of payment layer thickness through trial pit studies or using ground penetrating radars. So these activities were found to be laborious and resource intensive. So also the overlay thickness design based on ME methods is complex and requires sophisticated analysis too. So a few ANN tools which were developed by the researchers had showed that it is possible to have or ANN to develop a design overlay thickness prediction model for the payments. So therefore, in this study, we have so there is a need to develop a deep neural network based approach to develop a deep neural based approach for predicting the overlay thickness for the payment systems considering various parameters.
Dr. Pavani, you have less
Yes.
than 2 minutes.
Yeah.
So you may please, you may go to your findings maybe.
Yeah, I'll continue. So the objective of the study was to develop a deep neural design overlay thickness by using deep neural networks. So the .NET has two deep neural networks involved in it. The first deep neural network was developed to predict the deflection ball parameters considering the functional, traffic, and climatic condition. The second deep neural network was developed to predict overlay thickness from the output from the deflection ball parameters which were obtained as an output from the DNN1. Yeah, for this study, around various data has been used and several reprocessing steps were performed, and DNN architecture was developed. And several trial runs were performed to get the appropriate design for the DNN architecture. So for the development of the DNN usually depends upon the data. So for the development of the .NET, so the data of road sections present in USA and Canada and Andhra Pradesh road development, Andhra Pradesh were considered, and the data included array, annual leasing, average precipitation details, and these data has been several preprocessing steps were performed on these data. So that
Pavani,
it
the time given for the presentation is over, so I would request you to conclude the presentation, please. Thank you.
So after several trials, the DNN1 and DNN2 had these attributes. So the DNN1 and DNN2 had obtained a mean average precision. So this is the structure of DNNs that were developed to obtain overlay thickness design as an output. So, yeah, after performing several trials, the system has obtained an R square of 0.85, and for testing it's around 0.82. And here are the error histograms and that were shown. Yeah, in order to represent the ability of prediction, so the linear regression models were also developed, and the DNN has obtained better performance in predicting the overlay thickness from the various parameters.
Dr. Pavani, please conclude the presentation. We are actually overshooting the time. Sorry.
Yeah, sorry. Yeah. So it has observed that the DNN, the .NET architecture has achieved better R square, and and the results are being showed that the .NET could be used where the frequent conduction of FWD test is not possible. So it could act as an aid for the roadway agencies to calculate the design overlay thickness without even performing the FWD test and it actually gives or predicts the overlay thickness considering the functional, which is IRA, from IRA, traffic, and climatic conditions.
Thank you, Dr. Pavani, and I'm apologies that I interrupted in between due to the time crunch. Any questions from the audience?
How reliably the deep neural network predicts the oncoming futuristic traffic density? Because everywhere we experience data crunch, data everywhere, but not a workable data. That is the situation. So how far it will be precise, the deep neural network precise in deciphering out future traffic density?
Sir, in order to obtain that, so the performance of the prediction of a DNN mostly depends upon the data that we mostly use it to train. So for this, for the development of this deep neural network, so we have used the historical data of from the road sections which were constructed in US, Canada, and Andhra Pradesh, where the data was available from long back, way back in 2000, like 1970s to till date. So, which also included various the variation in the traffic volume that had happened over the period of time. So, I guess the system is now efficient to like I cannot comment on it whether it's sufficient to predict the effect of the in growth in the traffic volume for predicting the overlay thickness. But there is also always a chance to improve the DNN performance by training it on a lot more data points.
Okay, thank you, Dr. Pavani. We would move on to the next paper presentation.
Panel, please note the next paper ID is 8691 and the topic is experimental investigations on regenerating potential of waste cooking oil in high recycle asphalt, a rheological study by Shobit Jain, Umesh Saho and Anush Chandrapa, and presented by Shobit Jain.
Yeah, good morning. And I shared my screen. Can you see my slides?
Yes.
Yeah.
As we said before, we have 8 minutes, 10 minutes of presentation time. So 8 minutes, you would get a warning bell. So I would request you to be in time. Thank you.
Yeah, sure. Thank you. So, very good afternoon, all the engineers, faculties, and the scholars. I'm Shobit Jain, research scholar from IIT Bhubaneswar School of Infrastructure. I am here to present my conference paper titled "The Resilient Approach to Utilize High Recycled Asphalt Content Using Waste Cooking Oil." So these are the points I'm going to discuss in my study. Okay, due to unavailability of the natural resources, like the application of reclaimed asphalt pavement is gaining a lot of attention by the pavement engineers. So, and the RAP, utilization of RAP can reduce the consumption of both virgin aggregates and the fresh bitumen simultaneously. So despite from these advantages, the RAP has main issues, main problems with the performance at the lower and the intermediate temperature, as RAP contains the hard binder, which shows the tendency to fail in cracking. For the solution in this aspect, rejuvenators are being used in India and also overall the world, and it restores the properties of the aged binder to restore the properties of aged binder to the level of the fresh binder. Currently, waste cooking oil is being used as a rejuvenator, and this utilization results in the economic and environment benefits, as it reduces the demand of the fresh materials and also reduces the big issues like the disposal issues. So why WCO? As the WCO has some components, same components structure as like the bitumen, and it contains like asphaltene and maltines. Maltine in higher proportion as compared to the asphalt binder. Now, after the aging of the binder, the asphaltene proportion increases as compared to the maltines. And these maltines can be again introduced in the aged binder by addition of the waste cooking oil, which results in the same asphaltene to maltine ratio. As we all know that the utilization of waste cooking oil is increasing globally, which tends to be a higher production of the waste cooking oil, and very limited appropriate ways are there to utilize the waste cooking oil. So another thing is also by utilizing the RAP, the demand of natural resources can be reduced. So these are the research significance of my study. The major objective of the study was to evaluate the potential of waste cooking oil as a rejuvenator. Further, the determination of the optimum doses was the second objective of this study. In this study, the waste cooking oil was collected from one of the public hostel of IIT Bhubaneswar, and then it was filtered to remove the. Then it was filtered from the filter paper to remove the impurities. For the binder selection, the crumb rubber modified binder was selected for this study, and this study was done for the binder incorporating the 50% RAP reclaimed asphalt pavement binder. And in the method section, firstly, the RAP binder was produced from the lab by performing the short-term aging followed by the long-term aging. Then the rejuvenator binder was prepared with the mixing of RAP binder, fresh binder, and the waste cooking oil at different dosages. After preparation of the samples, some basic test was performed followed by the rheological test. This one is the dynamic shearometer, which we used to determine the rheological properties of the binder. The main output of the rheological testing or the in this study was we determined the shear modulus and the phase angle. So this one is the CAM model. This was selected to understand the behavior of binder at the extended frequencies. First the penetration test. The higher addition of waste cooking oil results in the higher penetration value as it softens the binder, while the binder with 50% RAP and 5% waste cooking oil showed the similar penetration value as compared to the unaged binder. Same findings were observed in case of softening point, where the binder with 50% RAP and the 5% waste cooking oil showed the similar softening point as compared to the unaged binder. And again, it is very clear that the addition of WCO softens the binder, which results in the lower softening point. Now, the rheological testing, the addition of waste cooking oil reduces the complex shear modulus as well as the rutting parameter, which was shown in this figure as G star by sine delta value. These figures shows that the result from from temperature sweep and the frequency sweep. The result showed that the rejuvenated binder with 5% waste cooking oil showed the higher rutting resistance, and the rejuvenated binder with 10% WCO showed the lower rutting resistance as compared to the unaged binder. From the master curves, except then the binder with 10% waste cooking oil, all the rejuvenated binder with 5% oil and 7.5% WCO showed the similar master curve as compared to unaged binder. But in the deep, the interesting part is that the rejuvenated binder with 5% oil showed the higher complex modulus at the lower frequency and the lower modulus at the higher frequency, which indicates that the rejuvenated binder with 5% WCO showed the better, higher, and intermediate performance, intermediate temperature performance. In the conclusion part, the addition of aged binder increases the viscosity of the blended binder due to the presence of hard binder. And at the same time, WCO reduces the viscosity of binder as it softens the binder. The optimum WCO was selected as 5 to 7.5%, as the binder with these WCO showed the similar properties as compared to unaged binder. For the chemical testing on the binders, the mixture performance evaluation and the morphology testing are the future scope of our study. And these are the references. Thank you. Is there any question I would prefer to answer?
Thank you, Shobit. It was well on time. Shobit, I just had one query. So your aged binder is also a CRMB, or is it a virgin?
Yeah, same binder.
Okay, so you had a CRMB 60, aged was also CRMB 60.
Yeah, yes.
And you modified with 50% of RAP.
50% aged binder, 50% virgin binder, and then additionally WCO at different doses.
Okay.
Shobit, this aging was done in PAV?
Then firstly, the short-term aging was done in the RTFO, then the long-term aging was done in the PAV.
So it was not a sort of a recovered binder from any RAP material?
Yeah, no, it was not actually. Yeah, actually, I'm going to perform same findings for the recovered binder from the field, and then I will compare it. But now, till now, I just performed only on the laboratory aging. Right.
Fine, thanks.
Just one more question in that line. So, what kind of aging conditions did you use for the PAV? Like, did you fix up as per any specifications?
Yeah. There is a ASTM D6921, which shows the 90 degrees Celsius.
Oh,
Yes.
you used 90 degrees Celsius?
For the 20 hours. For 20 hours. Yeah.
90 degrees Celsius for
At the
20 hours.
2.1 ampere pressure. Yes.
Why particularly 90 degrees Celsius?
Actually, from the literatures, I found that at this temperature and this pressure, we got the aged binder for about 7 to 10 years in the laboratory, matlab in the field condition, simulation as a field condition. So I just
Any doubts? Thank you, Shobit. The next paper presentation is on the topic Design and Evaluation of Novel Two-Layered Previous Concrete by Spurti BM, Anush Chandrappa and Umesh Saho. And now it's presenting Spurti BM. And panel, please note the paper ID is 9098.
Hello.
Hi, Spurti.
Ma'am, is my screen visible?
No. No.
One second. I'll just try to reshare. Now is my screen visible, ma'am?
Yes.
Okay.
No. Yes, Spurti. Spurti, you
Yes,
have
ma'am.
only 10 minutes for paper presentation, and the
Okay.
first bell will ring at the 8th minute.
Yes, ma'am.
So you can start the presentation.
Okay. So very good afternoon to one and all present here. I am Spurti BM, research scholar at IIT Tirupati and a former postgraduate student at SIF, IIT Bhubaneswar. So the topic for my presentation today is the design and evaluation of novel two-layered pervious concrete, what we also call as 2LPC. So here's my outline of the presentation. So coming to the introduction, see, with the increase in population, it demands for more and more urbanization. So for providing the, for catering the demand of the infrastructure, we keep on building more and more structures like buildings and more pavement structures. But unknowingly, with this kind of development, we are actually replacing the natural ground by an impervious fabric. So this kind of development is impacting the environment with two major issues. One is the change in thermal profile of the city, what we popularly call it as UHI effect, which causes a lot of thermal discomfort to urban dwellers. The second important problem is the flash flooding. In the event of rainfall, we see a lot of water getting generated into runoff, getting converted into runoff instead of the infiltration. So just for an example, if we consider a parking lot in Bhubaneswar city of area of 1,900 square meters, we consider the annual average rainfall, we see that the amount of runoff generated is about 3,000 meter cube per year. So if somehow we are able to harness this water for different purposes, it can actually cater the daily water demand of 23,000 people per year. So as a strategy, effective strategy, people have been using pervious concrete pavements, which actually infiltrates the rainwater coming from the to the groundwater. So what are these pervious concrete pavements? It's a special type of concrete where we have a very high amount of interconnected voids, about 15 to 40%. With because of the inclusion of so much of voids, we the strength is limited to 25 MPa, and we basically use this in low volume road applications. It is already proven to be a sustainable pavement material because of the multiple benefits it offers. But these pervious concrete properties are assessed in the laboratory, and it is observed to be satisfactory in the laboratory. But when it is coming to the problem statement, when it is actually implemented in the field, we see that within the 2 years of installation, it is drastically failing to perform in the performance criteria, that is to provide functionality. The first important problem is the clogging. Clogging is the blocking of the pores due to the periodic settlement of fines that come along with the storm water. So it basically fails the purpose of installation of the pervious concrete, because that is important. The second important failure is the raveling distress that we find because of the open matrix of the pervious concrete. The aggregates easily come out with the action of traffic loads. So there is a necessity to recheck the design ideology of the conventional pervious concrete material. So instead, if we can somehow able to design the modify the mixed design of the pervious concrete such that it becomes clog resistant and also abrasion resistance without compromising its strength and permeability parameters, it's kind of a win-win situation. So instead of designing the pervious concrete layer as a single layer consisting of same size of aggregates from top to bottom, we have come up with an innovative design of preparing the sample with two different layers, having top layer having the finer aggregates and the bottom layer having coarser aggregates size. So with this, the important design criteria is that at the interface, there is a high chance of blocking of a pathway for the passage of water because of the sinking of these small size aggregates into the void spaces. So that our research objective was to develop a methodology such that this two-layer pervious concrete becomes permeable and also further evaluate its properties and then to compare it with the conventional pervious concrete. So first step is to finalize the layer gradation. That means what are the different combinations of aggregate sizes that could be used in this 12PC. And then we go for mixed design and sample preparation. Then we characterize the samples and then evaluate its functional and mechanical properties and then compare it with the conventional pervious concrete to see how better it is performing. Coming to the material and methods, the design approach adopted here was to first finalize the layer gradation by studying the different 2D AutoCAD models of different combinations of two-layered pervious aggregates samples, where we find out the interface porosity through some theoretical calculations. And we see that out of the 12 different combinations considered for the study, we selected the samples having interface porosity greater than 20%. And coming to the sample preparation, the geometry of 2LPC was cylindrical specimen with top layer 50 mm and 150 mm bottom layer. Two layers were differently, it was separately designed with NRMCM guidelines, targeting a porosity of 25%. And then the mixtures were prepared and placed. The only thing is the time difference between placing top and bottom layer should be less than 10 minutes. So these are the various mixed proportions considered for the study. So we have 2LPC, and for the comparison, we have CPC made up of 6.75 mm and 9.5 mm. In the similar way, the bottom gradation for the 2LPC has 6.75 and 9.5, with the top layer 50 mm of 4.75 aggregates. So in order to check how it is behaving different, we need to assess some properties. That is, for the property assessment, we conducted basic property test, which includes porosity and density. For the mechanical property assessment, the strength and abrasion resistance was assessed by unconfined compressive strength test and the Cantabro test. Coming for the functional properties, the one important property for pervious payments is permeability that was assessed by in-house fabricated permeometer setup. And coming to the next property, that is clogging potential. That means how much reduction in permeability is observed when the material is subjected for clogging action. That was assessed and the percentage change was calculated. And then in pervious concrete pavements, actually in field, how they carry out the maintenance activity, how they rejuvenate the sample is through the street sweeper machines and through vacuum sweepers. So that kind of situation was simulated in the laboratory by cleaning the samples through brush cleaning and applying the vacuum, and then check how much permeability is recovered after subjecting it to rejuvenation. In addition to this, image analysis was carried out to find out the interface porosity through image analysis technique. Coming to the results and discussions, the interface porosity results showed that there exist two different porosities at the interface, which are coming from the top and bottom layer. And it showed an excellent match. The theoretical interface porosity, what we predicted from the AutoCAD models, and the actual interface porosity existing existing in the 12PC from the image analysis, it was found to be almost equal. And also the important observation was that the size ratio, that is D1 by D2, top layer and the bottom layer D1 by D2 ratio, if it is greater than 0.5, 50%, the interface porosity is also satisfactory. And the comparison of basic properties, we compared the total porosity. It was found to be much more higher than CPC for 12PC. And also the density falls in the range of the conventional pervious concrete, which is less than 2,400 kg per meter cube. Then coming to the permeability was found to increase with the porosity exponentially. This is a characteristic feature of the pervious concrete material. And also when we compare it with the CPC, we found that the permeability for 12PC samples were much more higher than the CPC. And it was found to be in the range of 0.16 to 0.75 centimeter per second. If we consider Indian cities have subjected to heavy rainfall, that is around 200 to 400 mm per hour rainfall intensity, it is much more higher than that. So it could be actually implemented in the field for the stormwater drainage purpose. The clogging studies result showed that with the addition of the clogging material, permeability drastically reduced, and it was about to it is almost reaching zero. When we compare the two clogging behaviors of CPC and 12PC, we find that 12PC initially the rate of reduction in permeability for 12PC is much more higher than CPC, but eventually both of the materials reach the same reduction in permeability at the end. Because of this surface deposition taking place in 12PC, we find this kind of behavior, which could be explained by this diagram. So we assess the clogging mass obtained in this, resulting in this. So we see that in case of 12PC pavement, whatever the clogging material, it is getting deposited on the surface around 59 to 65%. It is getting restrained at the surface level, and very less amount of clogging material is entering into the matrix. Whereas in case of CPC, we see that almost 90% of material it is getting into the matrix, which eventually clogs the subbase also, and also the top layer where the matrix of the pervious concrete also gets blocked, and it again becomes difficult for the infiltration of stormwater. The strength, unconfined compressive strength results showed that 12PC performed slightly better than, yes ma'am.
Your time is over for the presentation.
Okay, I'll just quickly sum up.
So you can conclude your
Yeah.
presentation.
So coming to the summary and conclusions, the methodology adopted for the design and development for this two-layer pervious concrete was found to be acceptable because of the properties obtained. So basic properties indicated that it is well within the range of the conventional pervious concrete. So this green color shows that it is better. The blue color shows that it is in the range of the conventional pervious concrete. So we see that the interface porosity, the rejuvenation potential, the abrasion resistance is much more higher than that of the single layer pervious concrete, which makes this material resilient. So thank you. If is there any question, I can take up.
Thank you, Spurti. Any questions?
Yes, Murthy. How was the permeability measured? Which test method you were using?
So permeability was measured by using this falling head permeability setup. So yeah, yes.
I think you mentioned you have used some 75
Yes,
micron downsize fine. So did you categorize what percentage was sort of a clay or some sort of PI value, plasticity value? Did you classify that?
Okay, that characterization was not carried out, but for preparation of this slurry, what we considered is the literature. We gone through the literature and found that the stormwater constituents present in this will be around 75% will be having silt that is less than 75 microns, and then fine sand it will be consisting of. So we considered this mixture as a slurry, and we maintain the stormwater concentration at 10.52 grams per liter. So that is the actual concentration of stormwater that we see.
But still, if you have a clay type of particles, it will be a completely different behavior, isn't it? So
Yes, sir. Yes, sir.
Any questions? Thank you, Spooty.
Thank you, ma'am. Thank you all.
So we are concluding the paper presentation. So now we will have a lunch break. And
Good afternoon, everybody, and I thank the organizers for inviting me. I hope all of you can hear me. I will wait for my slides to be projected, and I'll start. Slide presentation. Okay, fine. Good afternoon again. Today I'm going to be talking about transport systems, ITS systems, in the context of road safety. So today's presentation, essentially, I'm going to cover two different topics. First of all, I know that we have a mixed audience. I'm going to spend some time talking about what ITS is, and then I will talk about how ITS can be used for road safety. Road safety is obviously a topical topic. Our country is, in terms of accident statistics, we are not doing well internationally, and the issue of road safety has come to everyone's consciousness because of the recent unfortunate incident of Mr. Cyrus Mistry. So this event, in terms of infrastructure resilience, the aspect of safety is quite topical, and we are going to be talking about looking at how technology can help improve safety. So first of all, ITS. What is ITS? ITS stands for Intelligent Transport Systems. If you search in Google, I'm sure that you can find a number of different long-winded definitions like the one that you're seeing here. But at a high level, ITS is nothing but the use of technology for traffic transport management, management of roads, management of railways, public transport management, etc., so that you can operate your transport system in a manner that is efficient and safe. And when you say technology, it typically means communication, software, and hardware. They all come together to deliver a function that will aid the operation of the transport infrastructure. Next slide, please. I don't think my... Yes, thank you. So if you could operate the slides, that'll be nice. I don't think this is working. So who are the users of ITS system? There are... Sure, thank you. So firstly, we have traffic managers and road operators. Who are they? These are people who sit in a control room monitoring how the transport system is working. For example, we have 100 smart cities. All these 100 smart cities have a command and control center. Feeds from CCTV cameras and data from all the sensors that are deployed on the road network come to the control room. And these people are responsible for keeping an eye on how the traffic or the traffic is doing, the road network is doing, and the public transport, the buses are doing. And they are supposed to take intervention actions if things go wrong, or do things to improve the efficiency in real time. So this is typically how ITS system is used. That is one kind of stakeholder. So, and typically traffic police, they sit in the control room along with people who are called traffic managers. The second category of stakeholders are the traveling public. People need to know how to get from A to B. You have journey planners, for example, and if there's a disruption, people need to know. So these are two high-level stakeholders. And the ITS system is for managing the whole transport ecosystem, mobility ecosystem, efficiently and safely. In this particular lecture, I'm going to be focusing on safety aspect, and I'm going to skip over the efficiency aspect. The typical objectives when you spend a lot of money and install technology on your road network are obviously improving efficiency and saving lives, improved safety, and enforcement of traffic rules so that people behave in a manner that is, that is more in line with safe practices. People don't overspeed, for example. So what are the typical components? When I say install technology on the road, what are the different components? The ITS component that has been around installed on our roads, the most common one is traffic signals. I think going back to 1982 ASIAD, we started seeing widespread deployment of traffic signals across the country. Then we have variable message signs. These are LED boards. If you have traveled in national highways, you can see an LED board with a message. So the operator can flash a message that is pertinent to someone who's traveling on a stretch of road at some point in time using technology. That's VMS. Lane control signs are essentially small VMSs, but those are installed on a gantry on top of each lane. For example, if there's an accident, if you don't want people to travel on one lane, you can actually close it by showing an X, for example, or says closed. If you want people to travel slowly, you can control the speed limit temporarily per lane. So anything that you want people to do depending on which lane they are on. For example, in India, we have watering trucks that they go very slowly along the median, watering the plants. So when this happens, you can actually say there is a slow-moving vehicle ahead on the last lane so that people can move. And lane control signs are typically installed more regularly compared to variable message signs, which are installed at strategic locations only. Then we have things like traffic detectors that can measure traffic. How many vehicles are traveling at over a particular point on the road network? What is the speed? What is the classification of, what is the spread of vehicles? How many cars, how many lorries, how many buses? So the ATCCs, they are called, or traffic detectors. They can detect vehicles, individual vehicles, and provide additional information about them. And this can be aggregated to, for example, 5-minute flows, 5-minute average speeds, etc. And detectors can use a wide variety of technologies, going back to inductive loop detectors that are buried inside the road surface, to radars, to cameras. But all of them output similar-ish data. So the output looks more or less the same, regardless of the physical principles used to detect vehicles. Then we have emergency call boxes that is fast becoming obsolete, but still that is in the NHA specifications till recent past. So if you are stuck on a road, if you don't have mobile signal, you can actually go and call. And the person sitting in the control room will pick it up and send help. That's the idea. Now with good mobile coverage, I don't think ECBs are actually needed except in very special cases, for example, inside tunnels that are long. But still you find them on national highways. For example, if you're traveling from Angamali to Thrissur, I'm sure that you will see a lot of functioning yellow ECBs that will be picked up in the control room. Then we have met sensors. You need to sense weather. Especially in the north of the country, fog is a problem. And if you detect heavy rains, you may want to tell people to be cautious. People know it, but reinforcement doesn't hurt. So sensing weather and telling people, cautioning people to drive safely is something that happens regularly. And the MET sensors needn't be a physical sensor. Now we have APIs like Open Weather Map, where you can get weather information for a particular area through an API, and you can use it in the exactly same manner. Then we have AID cameras. This is in the latest NHA specification. These are essentially cameras looking at a specific point on the road network, and it is attached to an industrial computer installed on site, and it does video processing, and it detects things that go wrong. So I will come to that in one of the later slides. Vehicle actuated speed signs are things that flash if you're overspeeding, saying that speed limit is, let's say, 60, you're driving at 90. Again, I will talk about this in a bit more detail in one of the later slides. Then we have a category of sensors that identify individual vehicles. They are sometimes called individual vehicle detectors, IVDs. What they do is they pick up some characteristics about individual vehicles that you can use to distinguish it from other vehicles. For example, an automatic number plate recognition camera that can read the registration number so that you can distinguish between different vehicles. Most of the vehicles nowadays have fast tags. They are RFID tags. So if you have an RFID reader, you can distinguish individual vehicles. A lot of us have phones with Bluetooth and Wi-Fi turned on. So there are sensors that can sniff devices with active Bluetooth and Wi-Fi. And these give a unique MAC address that identifies a vehicle. And if you get this information, what you can do is you can use it to, for example, estimate the travel time between two different points. Suppose you have two RFID readers at point A and point B. You can get average travel time between those points. And if the travel time increases, you can deduce that there's something wrong, even if you don't have anything in between. Right? Or if you have lots of ANPR cameras in a city, you can actually get a sample of the OD that you can use for modeling. Next is CCTV cameras that are quite common. I mean, CCTV cameras are installed in almost all cities, and they're monitored from either the police control room or the traffic control room. The reason why CCTV cameras are very important is because none of these sensors, technologies are 100% foolproof. Even in a city like London, in the traffic control room, they have a scheme where they have a CCTV grid that keeps rolling so that within 5 minutes, they have actually seen all the CCTV feeds a person has seen. So that even if there's something wrong with the speed traffic and no sensor has picked it up, a human can spot it. And CCTV is an integral part of all ITS systems, despite advances in sensing technology that we have seen in the recent past. PA systems are typically installed in cities, not in highways, especially at junctions, to caution drivers about typically erratic behavior, or to provide information about, for example, an event, congestion, etc., or flooding, if there's, which is quite common nowadays in most cities. And lastly, there are ITS components that reside either as a software or hardware inside individual vehicles. For example, if you're operating a bus management system, you need to know where your buses are. So GPS or GNSS device, to be more generic, will provide real-time information or live location information every 10 seconds typically. That's the AIS 140 Indian standard. And if you have a mobile app, you can also push information the other way. You can tell people that route A is congested, take route B, or don't start at 6 in the evening, it's very congested, try to start early or late, things of that sort. So now I talked about different ITS components, so I gave a picture so that you get a feel for how these devices are installed typically. So this is a very good photo that I found on the internet on a piece of highway, or a stretch of highway, M42, I believe, in the UK. As you can see, is there a pointer here? Yeah. You have CCTV cameras. A lot of countries have 100% coverage of CCTV cameras on highways, including some stretches of highways in India. These are lane control signs. We have lane control signs, I think, in Noida, Greater Noida Expressway. I think the new expressways that are coming up in the country have lane control signs, so that you can give fine-grained information based on which lane you are in, and including the shoulder, if people are using a shoulder. In this particular case, you have loops buried on the road surface, which are detectors, but detectors can be camera-based or radar-based. You have a variable message sign right here. You can tell people, you can give them specific information. And you have an emergency call box here. So this is, and you can see similar-ish deployment of ITS components on national highways. And I encourage you to look out for them when you travel on highways next. Now, data from all these components come to the control room over typically communication network, which can be a fiber-based network, or it can be mobile data, 3G, 4G network. And what people do is, people who sit there, they essentially, their job is to monitor, act if they need to do something, and act can be done using a combination of people and systems. Some of the actions can be automated. For example, if the speed drops below a certain threshold at a particular detector over a 10-minute period, you can fire a rule to post a VMS message saying traffic congestion ahead, for example. Or people can manually take action. Regardless of what happens, people assess how the system is performing, and they manually monitor in addition to systems monitoring it, and this loop continues. This is typically what happens at a high level. There are various, obviously, different flavors of how this loop would look in any given city. But at a high level, this is the scheme in which, using which the data from all these devices are used into a high-level framework. And that framework is typically assembled into what people call as solutions, which deliver specific things. For example, in a city, it's an area traffic control system, which is essentially intelligent traffic lights that adapt timings based on data from sensors. So that is a solution, but you basically follow the loop that you saw earlier. Highway traffic management system, which is now called advanced traffic management system, where we deploy ITS on highways based on the specification from national highways. Then we have enforcement systems, for example. You want to catch people jumping red lights. It's an RLVD system. Transit, you may have an ITS system to monitor your buses and see how they are operating compared to the schedule that they are supposed to operate on, and take intervention actions to ensure that the bus service is operating as close to the schedule as possible. An example is Trivandrum Smart City, which is currently rolling out a public transport management system for the KSRTC buses in the city. You can have enforcement systems like speed violation or even ramp metering. You can, if your highway is prone to congestion, you can control how many vehicles are entering, at the rate at which vehicles are entering the highway. And you can also use ramp meters to alert drivers who are trying to enter the highway at a high speed if there are a lot of vehicles on the highway, and vice versa. So essentially, the ITS system is deployed with a specific objective in mind, and often they are packaged into solutions. With this background, I am going to talk about specific technologies that are available at our disposal to improve road safety. So I'm going to go over those technologies one by one. You can categorize these technologies, group them into three at a high level. One is technologies that will make roads safer. So they do something that will help you to reduce accident risk. That's one way to put it. Second is active components that provide warnings to road users. And third is enforcement. So these are three different categories. So we'll start with active components. You may have heard about pelican crossings and puffin crossings. Puffin crossings are essentially safe ped crossings. What these do is, especially these puffin crossings or active pedestrian crossings are deployed on roads where vehicles travel reasonably fast, typically not on urban roads where there's a pedestrian crossing. So you have detectors that look for pedestrians on the road, on the curbside, people who are waiting to cross. And the detectors also look for pedestrians who are in the middle of the road, who are actively crossing. And the way the system works is when someone pushes the button in a pelican crossing that is more common, pedestrians get green for a fixed duration, and after that, vehicles get green. which is fine, except if there is a disabled person, a person who's walking slowly for whatever reason, may not be able to clear the road and vehicles get green. And that creates a panic situation for the road user, the pedestrian, and puts that person in an unsafe position because vehicles have the right of way and you're in the middle of the road. And drivers can be aggressive. So what a safe pedestrian crossing or a puffin crossing does is, when it detects that at the end of the pedestrian stage, people are still crossing, it cuts off pedestrians by giving them giving them red. So more people will not step onto the road. However, the vehicles will not get green. The system waits for the people to clear the road before vehicles get green signal, which is far safer compared to vehicles getting green after a fixed duration. It also does something more clever. A lot of times when the traffic is less, someone will go and press the button and there's a gap in traffic and someone will cross, which is perfectly legal. Then after that, the vehicles get stopped for no one, and it's waste, fuel, pollution, all that. The system detects that scenario as well, and it actually skips the pedestrian phase. So vehicles continue to operate because whoever wants to cross has already crossed. So this is a common technology that's used for road safety, and these are typically deployed in, for example, state highways, like in MC Road, for example, is a typical, it's a nice example of a road stretch where such crossings would make a difference. Secondly, CCTV cameras. You all know what they are, so I'm not going to waste time. Just some trivia. Some of these CCTV cameras can see up to 2 kilometers. They're all weather, they have wipers, they even have cleaning liquids that you need to fill out. So these are not just cameras, these are ruggedized cameras specially designed for use on highways. So even if there's snow or rain, it gets cleaned, and from the control room you can view it. A lot of countries have 100% CCTV coverage. For example, all the active motorways in the UK have 100% CCTV coverage. All the highways in Qatar have 100% CCTV coverage as per their national standards. And some of the highway stretches in India, even though that is not needed, some of the road operators are attempting to do it. For example, Kanyakumari to Madurai, NH44, the road operators Cube and Cube Highways, and they are in the process of installing CCTV cameras so that they can monitor the entire stretch and seeing whether it makes a difference in terms of safety. The second technology that I want to talk about that can potentially improve safety on highways is called DAS, Distributed Acoustic Sensing. The way this works is, on all national highway stretches, we have fiber optic cables that are needed for communication. So you have a fiber running all along the road. What DAS does is it essentially sends a complex signal along the fiber, and its reflection or backscatter is read by a piece of electronic kit. And because the signal is complex with different frequencies, the backscatter contains information about the vibrations. So what happens is when a vehicle goes along the road, it creates ground vibrations. So the fiber optic cable also will vibrate, and the backscatter will carry information about those vibrations because there are subtle changes in frequencies. And that is picked up and processed to create essentially what you're seeing as a time-space diagram. So if you have a transport background, you know what a time-space diagram is. What you're seeing here is a time-space diagram. So you are essentially seeing vehicles traveling along the highway, and these typically have a resolution of 10 meters. This technology is deployed on some of the highways in New Zealand and UK, and it is deployed on one highway stretch, or currently in the process of getting deployed in one highway stretch in India from Muzaffarpur to somewhere in Bihar, I forgot. One drawback of this technology is when there's a lot of pedestrian activity, it creates a lot of noise that makes the technology slightly less accurate. So we are yet to see whether it will give as clean an information as what one gets from New Zealand or UK. The good thing about this technology is typically what we do on highways is we collect information about accidents. We determine where black spots are. And then you try to think of what mitigation actions you can make. But that is after the fact. An accident has already happened. Someone has already taken to hospital for whatever reason. Now, there could be a lot of near misses, near accidents that no one is noticing because someone averted an accident, and this could be a systemic problem. You can get signatures of such activities from the information you get from DAS, and you can take mitigation action even before the first accident has occurred at a potential black spot. So from a safety perspective, this technology has huge promises. And even things like in some places when cattle or people cross a lot, you know that that happens frequently, and you can possibly put a VMS or a warning sign. So the information that you get from these sensors can be actually used to implement proactive safety measures as opposed to being reactive, being on the back foot. Another technology is override detection system. So people flout rules all the time, especially lorry drivers. We all know that if you drive on the road. There are a lot of bridges where the clearance is 5.56 meters. And if you have important infrastructure that you don't want damaged, you can essentially put an overheight warning system. And these kind of occurrences are common. The first photo was from Qatar. This photo is from London. So a double-decker bus actually drove into a low bridge. So overhead detection systems essentially have a broken beam system. You essentially have an infrared beam. And if it's broken, you know that a vehicle that is taller than the limit is traveling towards something. So you can actually flash a message. You can sound a warning if you have a PA system. Or you can do something more elaborate. For example, there's a tunnel under Thames on M25, which is built in the late 1800s or early 1900s. What they have on M25, which is a ring road around London, is essentially barriers that you see. Sorry about that. Barriers that actually close downstream when overhead vehicles are detected. And there is a VMS sign that tells the overhead vehicle to actually get out. So there is a barrier on the shoulder, so that is opened, and that vehicle has to get out, and then all the barriers are opened. So, and here the implications of a vehicle damaging a tunnel under Thames is huge, especially when the infrastructure is old. That is why the countermeasure is far more elaborate. So typically OVDS systems range from something that detects that a vehicle is overheight and flashes a warning to something that stops all the traffic and ensures that the offending vehicle is out of the traffic stream. So there's a range of downstream measures you can take as a part of the OVDS system. Variable message signs, these are important because look at this photo. You have a nice car, it's a nice day, and you're enjoying the drive. It's a nice curve. But suppose there's a traffic jam downstream. The chances are that you're going to have a rear-end collision if you're not paying attention. But with a strategically located VMS flashing a message, most of the people would slow down and avoid a rear-end collision. But for installing a VMS message at that location, you need to do ITS design. And how do you do that? I will come to that in a moment. So these are some of the examples of VMS. Another warning measure that is mandated by NHA on national highways is VASD. These are called vehicle actuated speed devices. These typically have a radar and something that flashes. That may be informative, that may show what the current speed limit is, or it may say that you're over speeding, or it may show your speed. It say that your speed is let's say 96, with a static speed sign. These can be deployed near schools, typically, near hospitals, or on national highway stretches where you don't want people to speed. But there is no enforcement. If you all you're seeing is you're getting a warning, and it's appealing to your good sense to slow down, but you won't get a challan. Then the next component is automatic incident detection. This is again something I talked about. Camera plus video processing. It can detect a number of safety-related incidents such as wrong way driving, U-turn, pedestrians crossing, stopped vehicles. Sometimes vehicles stop not on the shoulder but on the last lane. And if you have an ITS system, you can flash a warning if you have a VMS or if you have an activate device. Or at a minimum, people in the control room know that someone has parked blocking a lane, which is illegal, and you can send the patrol vehicle and tell them to get out of the way. Or maybe they need help. This is also mandated by NHA on national highways, and some of these can be or should be installed on state highways with a history of accidents. Then there's enforcement. You can appeal to the good sense of people to slow down, for example. That may not work always. So you can essentially do, there are two types of speed enforcements: spot speed enforcement and average speed enforcement. Spot speed is you essentially have a radar which is calibrated that measures the speed of vehicles at a particular point. And if you're speeding, you will, and there is an ANPR camera, so it reads the number plate and you get a challan, you get a ticket, which is fine. But if you know where the cameras are, you will slow down at the location of the camera, and then again speed. That's what I would do. So in order to catch people, to mitigate that drawback, there are average speed enforcement systems where there are two different ANPR cameras, and the travel time of the particular vehicle is calculated based on the difference in timestamps when a particular individual vehicle was detected at the two locations. Then you cannot speed in between, because if you do, what it does is it does average speed. And average speed enforcement systems are starting to become common in India. So far, most of our speed enforcement systems are spot speed. And in some of the closed toll systems, when there are two toll booths, if you have a fast tag, they compare the timestamps and you get tickets, because that's irrefutable evidence that you were at Toll Plaza 1 at this time and Toll Plaza 2 at time 2, and you know the distance. So there is evidence that your average speed was higher than the speed limit. Another enforcement system is RLVD. So if you jump a red light, you get caught, essentially. So you have some sort of trigger loops that monitors vehicles crossing the stop line, and you have technology to determine the state of the traffic light. Is it red or not on a particular road? And when the light is red, and if it detects a vehicle, usually a photo is taken for evidence with ANPR, and a 5-second video or a 10-second video is taken for evidence for court, and you get a challan. And these are quite common in most smart cities, because that's one of their revenue streams. And that's how you get a challan. This system, CDAC system, that is deployed in Trivandrum, this photo. And this goes to NIC typically, Vahan database, and you get a ticket. So we have one nation, one challan system now. The next is for road safety is box junction enforcement. What's a box junction? If you have been to Hyderabad or Pune, you may see yellow rectangle drawn in the middle of junctions. The idea is that you're not supposed to stop inside the box. Even if you have green, you enter the box only if you're sure that you can actually exit it. So this prevents gridlocks from happening. And when you have an arterial with a lot of traffic and minor road with less traffic, what can happen is vehicles can get stuck in the middle of the junction, and the crossroad with less traffic will see vehicular movement at a higher speed. So if vehicles get stuck, that will cause a safety issue. So box junction enforcement cameras detect exactly this, vehicles that are stationary in the box with ANPR to send a challan. And last is ramp metering advisory. So this is a nice ramp, not where you're merging onto a motorway, an expressway. A lot of the entry ramps are well engineered like this, but this is an example where you have also traffic lights on the ramp, right, at the entry point. The idea of this is that, A, if the highway is congested, you can control the rate at which vehicles enter the highway. So one vehicle every 3 seconds or 4 seconds, you can actually control it. Secondly, you can, if the traffic on the highway is low, when it detects a vehicle coming at high speed on the highway, you can actually flash a warning to the vehicle entering the highway saying that there's a vehicle, so that the vehicle from the ramp enters the highway with cautiously. This is especially useful at times of low traffic, like in the middle of the night. You will take it for granted that there is no traffic and you may enter, and that causes accidents. So ramp meter can work both for reducing congestion and to provide safety warning, depending on how you deploy it. So these are all the components. Now I will briefly wrap up. I don't know how I'm doing with respect to time. 5 minutes, yeah. So I will talk about how do you determine what to deploy, and what is the design process that one goes through. It's good that you have a lot of tools that you can deploy to improve safety. So what's the decision-making process? I'm going to briefly talk about that and conclude. So a typical project life cycle is design, build, and operate. When it comes to ITS, we have a more specialized terminology. We start with what's called concept of operations, then high-level and detailed designs, installation, and operations. I'm going to talk about the first and last because those are the most important things. Concept of operations determine what to deploy, and operations determine how you use it. I'm going to skip the middle steps. So concept of operations is when you have a transport system. It may be a stretch of highway, it could be an urban road network, it could be a public transport system. You sit down and think, how am I going to operate the system from a traffic perspective, from a mobility perspective? What are the challenges that I'm going to face in terms of both operational efficiency and safety? Then think about how ITS can help. ITS may not be able to solve all their problems. It can solve only some of the problems under certain contexts. So be very clear about what are the problems that you want to solve using technology. And then determine what sort of ITS components or systems you need to deploy in order to achieve those objectives. And you need to go through this process in a logical manner. And you can do that only if you have an operational knowledge of that particular bit of the transport system. So you start with the end in mind. That's what and this is an example of the ConOps that we did for Mumbai-Pune Expressway years ago. When we talked to the operators, these were the challenges that they essentially listed. So 3 of those issues were related to safety. So in terms of recommendation of what we need to deploy, we took these into account and determined that we should, for example, install AID. We should install ECB because there are tunnels, and if something untoward happens inside a tunnel, you need to provide ECBs. Fog is a problem, so we said MET. So this is an example. So if you want to deploy ITS for improving safety, you need to essentially go through this stretch from A to B. What are the operational challenges in that particular stretch? And which of those challenges you want to actually solve using technology? And then decide what to install. Then you decide the details. That's what you do in all these designs. And then when you come to operations, all the data comes back to the control room. 2 important operational aspects in the control room that will improve safety. One is incident management, golden hour and all that. You need to know an accident has occurred as soon as possible so that you can act and you save precious time. And when you act, you need to act with clarity. You should not be figuring out what to do. So you define standard operating procedures. So AID cameras and ECBs will give you information as soon as possible. Standard operating procedures will avoid confusion, and regardless of who is present in the control room when something happens, they follow these steps without thinking, and hence the action is fast. And ITS software typically have SOPs built in. And lastly, you capture accident data so that over time you have a good database of what went wrong on your system over a period of time. Once you do that, you analyze once every 6 months, every 1 year. And you can do two types of analysis. One is black spot analysis. I have a cluster of accidents here, here, and there. So what is wrong in those locations? You go, you investigate, and take corrective measures. That is reactive. You can also do accident risk modeling. What you can do is you can divide your highway into multiple links or stretches and take characteristics like average speed, design speed. If you have detectors, you will know the average speed. Vehicle mix. You can get vehicle speed variability because detectors measure the speed of individual vehicles. So you can get the speed distribution. So speed distribution can be wide or narrow. And you have the number of accidents, 0, 1, 2, 3, 4, on each stretch. And you can essentially build a statistical machine learning model between the number of accidents and the characteristics that you have, both dynamic and static. The advantage of this is you identify highway stretches where, again, accidents have not occurred yet. But based on your model, they have a high propensity or probability of accidents occurring based on data you have seen. And then again, you can go and investigate and hopefully implement measures that will prevent the accident from occurring. So this is what you do using the data collected. And depending on the ITS software deployed, you can either do some of this, or you can download the data so that you can take it offline and build your own models. And this typically happens as well. And with that, I conclude my speech. Thank you.
Thank you, sir. As a token of appreciation, we would like to present a memento to Dr. Rajesh Krishnan. I kindly invite Sri Bhavatrajan, IIT Palakkad faculty, to present the memento. We will have a question and answer session after the keynote address of Professor Boeing Singh. So let's have a second keynote session on the topic Project Delivery by Professor L. Boeing Singh from IIT Guwahati. Professor L. Boeing Singh, Professor of Department of Civil Engineering, IIT Guwahati, Head of Department, School of Business, IIT Guwahati, has 7-year experience in corporate and 13 years of academic experience, and his area of interest is PPs, construction quality, etc., and associated editor for 2 journals. Welcome, sir.
Probably more. Don't worry, I'll try to finish before that. I'll try the first. Okay. Good afternoon. I hope, I think, I'm the last speaker. I would try to limit my talk as much as possible so that we can have a longer Q&A session. I was going through the topic and then going through the kind of keynote address and the thematic address which has been made till now. So mine is going to be a little bit different from what you might have heard till now. I basically work in the area of 3Ps, public-private partnership, and we try to look into the sustainability aspect of a particular delivery mechanism, which is completely a business model based kind of a procurement model. So if we can make 3P sustainable, then I think a typical EPC delivery and design build project delivery can be made sustainable. So that's the logic we have. And the lectures, this presentation focuses mostly on the work which has been done by my students till now on how to make PPP more sustainable, take into account the climate change impact and all those things, what kind of changes we need to do, and what interventions we're supposed to do. So taking the, with this as a background, I hope all of you will appreciate the fact that in today's world, I think we have been talking a lot about sustainable development goals and all those things. But if you take one step back and then try to see what is meant by sustainable development, one of the famous, a lot of people, a lot of academicians have tried to give their own version of sustainable development. It depends on from where you belong to. So maybe from a perspective of a business entrepreneurship, sustainability will be different, but from the perspective of an environmentalist, the sustainability is going to be different. From the perspective of a social scientist, sustainability is going to be different. There is a reason for that difference, why why different sections of this particular society treat sustainability with a different concept. So one of the reasons I think is that it has centered on two basic principles, which is what we call the intergenerational equity and intragenerational equity, which is based on three basic pillars, which we call it society, economy, and environment. So if you belong to that perspective, you tend to look at that from that perspective. So if we start looking at sustainable development, I think the international recognition takes place somewhere in 1972. Then it started moving on to Birkeland commissions. They come up with one of the famous definition of sustainable development. Then we have Rio Summit, then Rio Plus 20 Summit and all those things. Then finally, even if we look into the Indian context, we used to have planning commissions and we used to have the 5-year plans. If you remember the last 5-year plan, the 12 5-year plans was one of the 5-year plans which used to have a title. None of the 5-year plans has a specific title. That was the only 5-year plan which had a title by the name Inclusive and Sustainable Development. So we started talking about sustainability from taking the forefront from the 12 5-year plan, which was the 12 5-year plan was from, I think, 2012 to 2017. So there we started talking about development, and development has to be sustainable. So the word sustainability goes hands in hand with the resilience, climate change, and all those things. If you start looking at these 17 goals, these goals are quite interdependent with one another. Say, for example, if I say the goal number, for example, the goal number 3, which is good health and well-being. The goal of a sustainable development has to be, I should promote good health and well-being. For that to happen, I need a better quality infrastructure. I need to have clean and affordable energy. I need to have proper sanitations and all that. So all of them are interdependent with one another. So earlier, focus on sustainable development talks about achieving this goal in a very discrete manner. But now I think achieving one goal is not possible on its own. We need to touch upon a lot of other interrelated areas, interrelated goals to be achieved. So that's why they come out with this SDG 2030, where we have 17 goals in that. In that goals, I think we have our own specific targets. Okay, one of the target, which is what we call the target 9.1. This is one of the target which talks about a lot of things which has a lot of relevance for the civil engineers. It says that we need to build sustainable and resilient infrastructure. The focus of building sustainable and resilient infrastructure is that I want to make sure that every section of the society get access to the basic necessity infrastructure facility. And as part of this particular philosophy of intra-generational equity, where every section of the society should have access to the same set of facility, I start talking about bringing in small and medium-priced enterprises, trying to bring in local entrepreneur, trying to use domestic technology and all those things. So these are some of the focus which has come in, and this focus has really taken the country by surprise, and whatever we are doing has some way or the other way got to do something with this. So with this as a background, I think you can see that there is another goal which goes hands in hand with the goal number 9, which is the goal number 12, where we talk about responsible consumptions, which is one thing, and production. So as part of that, it says that we need to make our procurement sustainable. If you remember, I think all of you will agree with the fact that if you look into the stock of infrastructure being created by your state or by the country, maybe around 70 to 80% of this stock of the infrastructure is being created using public money. It's all public finance, what we call it. Okay. Though we are trying to increase the portion of the private capital, but the process by which we procure that services, even if I take the services of a construction company to build something, but it's done through public procurement. Okay. So that public procurement has a big role to play in ensuring that the development which is taking place is sustainable in nature or not. So I think all of you will appreciate the fact that in your particular department, when you procure certain items, you must be having a process in place. The first process may be saying that they should meet certain pre-qualified criteria. The pre-qualification norms must be there. In that pre-qualification norms, I'm sure the focus must be on the technical qualification. How many crores worth of project must have been done to become eligible for that, number one. Number two, what should be the turnover? What kind of a organizational resource they are supposed to have? Those must be the focus. But I'm sure none of the organizations really think of asking the private sector to give their, what do you call it, the proposal or whatever solutions they are giving in terms of to what extent they can promote sustainability. All the private sectors, if you look into it, they try to limit their roles toward the contribution in making the development sustainable. Most of the cases limit themselves to taking care of the CSR programs only. Okay, so if they become a part of that, that is what they normally do it. But the public organizations have a big role to play in making our procurement sustainable. And that's where we come with this goal number 9, goal number 12, where goal number 12.7, which is the target 12.7, says that as far as all our procurement, it has to be sustainable. So let us take a stock of how it is across the world. So if you look into some of these all developed countries and OECD countries, they have a sustainable public procurement system in place. Say, for example, if I look into it, if you look into your technical spec, which you give it out as part of the tender document, how many of the organizations says that whatever electrical appliances which are using it has to be environmental friendly? We never said that. When we build some civil construction, to what extent are we saying that the proportion of aggregate which is supposed to use should be recycled aggregate? We haven't said that till now, okay? But sometimes in the future, that is the way we are supposed to go forward. So the procurement process has a big role to play in making our system sustainable, because that's the only way through which we are enforcing the private sector or the contractors which are going to come forward and build a facility to incorporate the sustainability concepts, okay? So based on this, I think some survey has been done. The survey talks about in what ways we can bring sustainability in the procurement process. The procurement process is very simple. For example, if you want to buy a mobile, you first have to identify what is the need for a mobile. Why do you need a laptop? Okay. Then you go out, then you identify your needs. In the needs, you come out, okay, I need a mobile or I need a laptop with certain specifications. What? Why I'm looking at the specifications? Maybe I may have to do some image processing. I may have to do some, say, for example, sound processing or something like that. Or I may have to run some mathematical programming. So that will dictate the kind of specs I need to have. So after that, I go out to the field, I go out to the market and see what are the specs, what are the kind of laptops which are having those kind of specs. I go out there and do that. After that, I do have a budgetary constraint. Then I shortlist a couple of models, okay? Then I decide which model should I buy, and then I buy it. Similar to that, if you look into a typical procurement for any infrastructure project, what you do all the same thing. You identify your needs, you tailor the specifications, you identify what kind of contracts you are going to use it, then you do a pre-qualification round and you set the pre-qualification limits and all those things. Then you come back and see that the private sector or whatever contractor will come and participate, and then they'll submit a bid, evaluate the bids, and then award the contract, then you administer the contract, and then you close the contract. That is the typical process. So where we can make this process sustainable, that's how it comes. Say, for example, some of the areas where we can do is that we can include criteria other than technical and financial for evaluation of the proposal. We can evaluate. Say, for example, one good example is that if you might have heard about this Taloja landfill, regional landfill was there. So if you look into any of the municipal solid waste, the technology to be used for treating the waste is being decided at the beginning of it. At the DPR stage, you start dictating what kind of technology is to be used, okay? But is it the right way? There might be official reason for that, bureaucratic reason for that, maybe administrative and institutional reasons for that to jumping on into a particular technology. But there are certain areas where the public sector is having an asymmetric information compared with the private sector, where the private sector may be in a better position to decide which technology is better for a particular problem, okay? So what happens is that you should give that flexibility to private sector to come up with a technology. That is well and good, but the problem lies with the other side. On the other side of the table, you should be able to compare one technology with another technology and then try to compare the value for money which is going to be given by both the technology. So if you don't have that expertise, you always stick with one technology where you can do a comparison, okay? So there, I think, as a result, what happens is that even the public sector also needs to augment his competency. Private sector keeps on augmenting his competency because they have to be in the business. If the competitors get a better technology and they will get more market share, whereas the public sector does not have that kind of a challenge, okay? So this is one challenge, this is one area where the private sector really needs to buckle up and then try to adopt new technologies, new procurement policies, new procurement practices to make the process more sustainable, because they can play a very big role in this. So this is a survey which has been done on what kind of strategies we can do it. One of the strategies which has been identified is that when I frame the specifications, I should frame the specification in such a way that the private sector is incentivized to come up with sustainable solutions. I should have sustainability parameters as part of the evaluation criteria. Okay, so these are some of the things which has been come. Coming back to the Indian case, we are still far ahead. We don't have a sustainable procurement plant. Okay, but if you look into the Ministry of Finance, Department of Expenditure, we are talking about having a sustainable procurement plant. Okay, so whatever planning you do, whatever kind of materials you are going to use for your project, what kind of aggregates, what kind of cement, because wherever you go nowadays, we say that we have to use fly ash-based cement. This could be one example of that. We talk about recycle aggregates, okay. A lot of places have issues with the natural scent. We talk about what do you call it, stone crusted dust as one of the replacement for the natural aggregates and all those things. So this is what has coming up. For example, in Surat, there is a big plant which recycle the construction and demolition waste, which is becoming a big market. Okay. So if you are able to highlight that this particular project has to be done that way, then it's going to go in a big way in making a environment sustainable, in preserving your scarce natural resources. And at the same time, when I talk about natural resources, let us also think about the future generation. The generations maybe 3-4 generations down the line might not be having access to the same kind of resources which you are having now. Okay. So the most important thing as far as sustainable development is, that's the thing. Let us preserve something for the future generation. Let them also enjoy it. Okay. So what we are supposed to do is the focus of that, and we have a big role to play in that. So with this, if I look into it, we need a lot of money. Huge amount of investment is required. We always say that there is a forward and a backward linkage between infrastructure investment and the economy. I think all of you will appreciate that the first scheme which was done by the government after COVID was to incentivize the central government employee to buy things which attract a GST of more than 18%. In certain areas, the purpose is that you are trying to kickstart certain sectors of the economy. And in that, infrastructure is one of the sectors which has the highest potential to kickstart an economy. We have something called a multiplier effect in infrastructure. Say, for example, you're building a 1 crore project. In that 1 crore project, let us assume that 50% of the cost is towards the payment toward the laborers, and the remaining 50% is towards the cost of the material which are going to use in that contract. So 50% means out of 1 crore, 50% means 50 lakhs. 50 lakhs will be paid on the laborers. So if you have laborers from your same locality, that 50 lakhs will be the income for the laborers in the vicinity of the particular project. So that particular laborer will have that 50 lakhs, and that 50 lakhs, which has been obtained as an income by the laborers, will be again spent on some other avenues. Like they will send the kids to a better school, maybe spent on food, maybe spent on entertainment, maybe spent on healthcare, maybe spent on schooling and all. So what happens is that the money which you pump into a particular place keeps on having something called a cascading effect. Okay. So as a result, what happens with that 1 crore which I have invested there, it leads to the growth of the economy in and around that particular project. Okay. So infrastructure has that. So wherever when you come across any problem where the economy is not, when it's not bullish and when it's bearish, we always say that let us make investment in infrastructure. Okay. So that's why I think we know we have our own targets and all those things. Coming back to India, we can see that the quality of infrastructure in India is still comparatively lower when we compare with other countries, Asian countries and other part of the other countries, except a couple of sectors where we still have a lower quality index compared with others. So as a result, government is thinking about new things. If we start looking into it, the 90s, I think we started with economic liberalization, then we started opening the highways and opening the power and all those things. So if you look into this, power and highways were economic infrastructure, we call it, which is more receptive to private sector investment. But if we start going to the social infrastructure like, say, municipal solid waste, water supply schemes, and all those things, the level of reception from the private sector is still not to the level what we have achieved in the case of highways and the powers. Because these are socially sustainable projects and we do have issues. But the trend has changed. Waste is being considered as some value. So if you look into some of the municipal solid waste projects, some of the municipal solid waste projects are break-even. They're earning profits. It is no more like it used to be before. And there are some wastewater projects in Maharashtra which are turning into profits also, because the wastewater which they collect, they convert them to clean water and then supply to some of the industries where very clean water is required. And this sludge which they collect from there is converted into fertilizers and sell it to somewhere else. Okay, so scope is there, it's coming up, but the kind of lesson which we have learned from the highways and the kind of lesson which we have learned from the power project, we still have yet to achieve certain kind of a success story in case of that sector. So with this, with two backgrounds, one was the sustainable development, another one was on environment, investment in infra. We always know that there is a gap. If we want to have a sustainable growth, we need to provide the basic necessities. 24/7 water supply is still a dream in a lot of the cities. Okay, giving uninterrupted power to every part of the country is still a dream. That means if you want to become a superpower, we need to have all this in place. So that means we need huge amount of investment required, and the needs are competing in nature. So one way of bridging the gap is to bring money from some other sources other than the tax which are being collected. The tax collection is mostly used towards the programs which are socially targeted ones. Educations and midday meals, kind of that, okay. Those are the programs where if we start looking into the funding which we require for creating these physical assets, we're still way behind. So 3 Ps are one way of it. One good example is that the entry of private sector does not always means that we are going to have a better system. We have to control we have to have a proper regulatory mechanism through which we control the behavior of the private sector, what you intend to get out of it, number one. Number two, you will not be able to control the behavior of a private sector until unless you are as competent as the private sector. Okay, so if there is a gap, knowledge asymmetry between the private sector and the public sector, the government agencies, you will never be able to understand what he wants to do or what you want to get out of him. Okay, there are benefits, but still there are a lot of challenges in that. So with this, I think if you just go through the newspaper clippings, I think we have been talking about reviving 3 Ps, reviving the private investment and all those things. So with this as a background, we started looking into what kind of schemes are being adopted all over the world to see how infrastructure are to be created in a very sustainable manner. So we have a basic two kind of approach. I think all of you must have heard about this indicator-based system, okay, where we identify the indicators, we aggregate the indicators and come up with the index, like say Human Development Index. Okay, we have, that's a one kind of thing, which is basically 3 verticals we have, and those verticals are competing with one another. But when we talk about sustainable development, we have certain goals, certain targets, which are competing with one another, which are correlated with one another. There is a lot of interdependency between one another, which could not be captured by a single index. So that is the reason why we started coming up with this principle-based approach. If you go back and look into all these 17 goals, the 17 goals are basically reflections of this reflection of these principles. When I say that I should be having clean water and air, or when I say that I need to give well-being should be good, that there should not be poor, affordability should be there and all those things. It's not a single entity which is supposed to capture. You are capturing a couple of things. So these are the two methods which we normally use. So the first method, which we call a triple bottom line approach, or what you call a bottom-up approach, has its own limitations, where it's not able to capture the relationship between one indicator with another indicator. So we started looking into this principle-based approach and apply this in the context of infrastructure. So when we look at sustainable development from an infrastructure perspective, what it means, I try to look into involvement of all sections of the society when I plan an infrastructure project. In UK, when you plan an infrastructure project, there is a public consultation process where every section of the society, anybody can go there and express his views about whether they like this infrastructure or not. But in our case also, we have, as part of the EIA, or what I call SIA, we do have public consultations, but the extent of public consultation is not that as exhaustive as it requires to be. Okay, so we need to have that. We need to think about quality of life. We have to make it affordable. 3Ps need not always be expensive. Okay, having a toll road should not always means that it has to be expensive. Entire revenue has to be collected from the toll. It should not be the case. Value for money exercise has to be done. In India, though we already have close to, say, for example, 20, 30 years of 3P program, we still don't have a dedicated public sector comparator. We assume that when we create an infrastructure, we assume that it brings value to the society. We should be able to compare one procurement model with another. If I am procuring the same thing using design build contract, and if I am procuring the same through, say, through DBO, BOT, I should be able to compare which one gives more value to the society. I don't have that. Project implementation has to be efficient. Institutional capacity has to be there. Efficient resource utilization and all those things has to be there. So with this as a basis, we start looking into the procurement process which was being adopted by the government of India. So where we have this typical process of identifications, then we have this project development, your preparation of your DPR, then we come up with the NITs, bidding documents, invite the private sector to bid, and then evaluate the bids, and then we come up to the stage of awarding a contract, and then contract administrations. So a couple of issues which we have highlighted here. From the perspective of sustainable development, there we can see that the private sector doesn't have any incentive to bring some innovative solutions. Having said this, I think the whole genesis of 3Ps have started with the concept that we want to bring private sector because the private sector can bring some innovative solution. That was the genesis of 3Ps. But nowhere in the procurement process we promote that. Okay, as a result, we don't have innovations. But let us take the case of the mobile industry, mobile phones. I think all of you must have gone through the mobile phones from Nokia, which was the very heavy one, to the now smartphones. Okay. Who is driving that? Nobody is driving that. The government is not driving that. The government only changed the kind of what kind of technology you're supposed to do. You're supposed from GSM to WLL to CDMA, then 3Gs, then 5Gs and all that. But the mobile technology, the mobile phones, who has innovated? Not the government. It has been innovated by the private sector. Once they know that a market has been created, new players comes into picture there and then come up with a new technology, a new model, new product. Okay. The innovations, the fertile ground for innovation to take place has been provided by the government with the policy that I am going to promote 5G or WiMAX. That's the only thing the government has done. But the actual process of building the mobile phones to cater to use that technology has been done by the private sector. That is what we intend to do when we say that let us bring 3Ps. We expect private sector to come up with the technology. Okay. But most of the cases what happens is that the technology is already being detected. It's already being decided at the beginning. Okay. So that we need to have a relook into that. Let the private sector to a certain extent decide what technology they want to use. Only then I think we can talk about innovations, we can talk about to what extent it brings sustainability into the picture and all those things. So a couple of issues has been identified. We use a system dynamic analysis to identify how to solve some of the challenges. And we have identified around 11 areas where we can intervene and make the procurement process more sustainable, starting from EIA all the way to stakeholder participation in the whole process, value for money analysis, and all those things. Okay. So here I think we can see that in the EIA, we says that instead of using the typical EIA, we should be using strategic management program. Okay, strategic management assessment. Climate change has to be one of the considerations when we look into your assessment process. Okay, so a couple of the strategies has been identified. Okay, which is a part of this particular study which has come out. So one of the things, if I look into this, the bidding cost, it says that most of the time we talk about contract between the public and the private sector. One of the ways of bringing down the cost is to build trust, and we can think about having relational contracting, which is going to be paradigm shift in the way the government is supposed to procure projects. Okay, that is a big way where we have seen successful stories in countries like US and UK on having a trust-based kind of a contract. Okay, this can go a long way in bringing down the cost of this particular project. Okay, there are certain projects, there are certain areas where we can have those kind of things. So we apply this in the context of an MSW project. Why we have used MSW project is that MSW project is one of the projects which is a kind of a conglomerate of couple of projects. So basically, if you look into solid waste, I think all of you are familiar with solid waste. Whatever solid waste is being generated in the house goes to a particular collection center, they transport it and they take it. If you don't have a segregation in your house, they take it to a particular segregation site, they will segregate dry waste, biodegradable, metal, inert, and all those things. And if you have a composting plant, all the biodegradable waste will be taken to the composting plant, convert to compost. Or if you have a huge component of, say, combustible items, if the solid waste is from a high-income group area, then you will find a lot of combustible items which will be converted to a refuse-derived fuel, which can be used in an incinerator and then convert and put in the waste-to-energy plant. So you have a couple of technologies, all the way from landfill to your pyrolysis and all those things. Okay. At the same time, you're talking about different segments in your value chain. Each of this value chain means collection, your segregations, your processing, and your particular landfill. Each of them could also be converted to a particular project itself. Say, for example, in the case of Guwahati, collection is done by the NGOs, whereas transportation is done by the Guwahati Municipal Corporation, and it goes to a particular site where they segregate it, and the biodegradable goes to a composting plant. Or most of the cases, what they do is they put in a dumping ground, which is not even a landfill site. So each of them could be structured in a different way, where you can bring private sector to do each of this segment. So that means what? If I start looking into a project to integrate everything and dish it out to a private sector, the private sector is supposed to do all the segments of this value chain. Or in some of the cases, the success stories in India has been focused only on giving this private sector participation only in one value of this value chain. Okay. So there what we have seen is that this is one of the areas which have potential to touch upon at least 7 out of the 17 sustainable development goals, where we talk about, if we talk about, say, if you don't treat your solid waste properly, it is going to, what do you call it? The leachate will get into your groundwater and is going to pollute your groundwater, number one. Whatever air surrounding the landfill site will get polluted. Okay. There will be livelihood changes, challenges will be there. All those things, health and everything will have a problem. Surat was an example where the solid waste was not being treated properly. So this is one area where we look into it, and we have identified certain challenges in that. And how they have performed from the perspective of sustainable development is the focus of this. Say, for example, in terms of these couple of the ideas which we have taken was that when they select this private sector, or when they selected this technology, say this particular project was at that particular point of time where we talk about carbon credits. Okay, this project was taken up in those days where we tried to CDM and all those things, carbon credits and all those tradings were being done. So we don't have any kind of a clause which says that carbon emission has to be curtailed. Okay, if you have a specific clause which says that you have to create additional funds out of this, that could have been a good thing for that. Okay. The environmental requirements were being spelled out later on. It was never spelled at the beginning. The technology was spelled out at the DPR stage. The private sector should be given the freedom to select the technology at the stage of when they characterize the waste. Okay, so that should be the case. Okay. So in addition to this, I think the technology innovation was never there. They never given the flexibility to private sector to choose what kind of technology to be used. Involvement of the stakeholders were limited only to a couple of CVOs, community-based organizations. Citizen charters were created, but the participation of people were really not to the extent which is required. The financial mechanism, if you look into it, you have to have a very flexible payment system. If the private sector is not meeting your sustainable goals, you should be able to reduce the payments. At the same time, if the private sector is achieving a sustainable goal, the payment mechanisms should be able to reflect that also. Okay, so that means I'm talking about a very flexible contract. Okay, so this was not there in this case. The value capture was not being done. This was an area where we are supposed to look into it. Then some of the, they never had any standards, they never have any targets, okay. Recycling targets were not there, okay. What kind of a performance-based payments which are supposed to be done, it was never there. So with this, the key conclusions which have come from here is that in order to promote sustainable development, we can have interventions at different level. Interventions at the specifications, interventions at the bidder selections, interventions at informal level like adopting for a new kind of contracts and all those things. Giving them an opportunity to look for alternate finance, okay, giving them incentive to go for more climate-friendly kind of a product, okay. Create a pipelines for low carbon 3P project, and this is a buzzword which is coming up nowadays. Nowadays, we don't talk about 3P project, we talk about climate smart 3Ps, which is a new buzzword which has come up. Your 3P project has to be smart, okay. We talk about smart city, at the same time we talk about a 3P participation in that, where the design specification has to meet the two basic principles of 3Ps, inter and intra-generation equity. You should formulate specific key performance indicators so that the ability to mitigate the climate changes and then make your infrastructure climate resilient should be a part of it. Payment mechanism has to be, what we call it, more flexible in nature. And you should have proper flexibility built into a contract with negotiation clause and all those things. So with this, I have come to the end of my presentations. Thank you.
Thank you, sir. As a token of appreciation, we would like to present a memento to Professor Boeing Singh. I kindly invite Dr. Veena from IIT Palakkad to present the memento. Thank you, ma'am. Thank you, sir.
Yeah.
Next, we will have a paper presentations. And the details of the paper presentation is just displayed outside the hall. And the paper presentation, you can go to the concerned halls. The resilient payment technology will continue in the Symphony Hall.
Recording stopped.
Next, we will have an online keynote session by Professor Dharamveer Singh from IIT Bombay on the topic Resilient Payment Technology. Welcome, sir.
Thank you.
Professor Dharamveer Singh, Associate Professor from Department of Civil Engineering, IIT Bombay, had did his BE from MBM College, Engineering College, Jodhpur, MTech from IIT Kharagpur, PhD from University of Oklahoma, Norman, USA. Worked in various positions such as visiting Senior Research Associate, lecturer in Birla Institute of Technology, and received several honors. Welcome, sir.
Good evening. Can I share my presentation?
Yes, sir.
May I know how many participants are attending this?
Sir, it's about physically 40 to 50.
Okay. I hope you can see the presentation.
Yes, sir.
Okay. And I have 30 minutes presentation time, right?
Yes, sir.
Okay, so it starts now, 4:05. Okay, so first of all, good evening to all of you for attending this presentation. And I could not make it to come there in person, but it is a great pleasure to give this particular presentation online. And the topic which was given to me was something on resilient payment infrastructures. So I thought maybe the recycling technology is going to fit in very well in this particular theme. So is it audible? I hope it's fine so far. Okay. So first of all, I would like to give this disclaimer that this particular presentation is given. There is no intention to promote any kind of product or machineries. So you may see some photographs in these particular presentations, and they are taken from the open literature or from the industry experts, not to promote some kind of machinery or some product, but to give some kind of educational background and technology concepts to all the participants. You know, the sustainability, in fact, in the payment engineering, we have been talking about sustainability almost more than maybe 10 to 15 years. But we assume that sustainability means, like constructing good roads. But if you see the concept of this particular theme, it composes of different kind of things together, not only the durability, but in terms of the environment and other benefits which comes along that. So if you see the concrete payment here, and which is going to have a lot of energy requirement, if you see the binder here, the production of cement. So that is the crucial part which comes up into this particular the type of the payment. If you see the bituminous payment, which comes here, slightly lesser than the concrete payment. If you see the recycling, which comes further down, if you see the cement stabilized layer, which goes further down, and of course the GSB, WMM, or granular material, which is going to have low requirement for the energy. So the recycling fits in very well in this particular theme. Just if you think about the sustainable development of the payments, and at the same time, if you think about the resilient infrastructure, we need to also think about that how the payment infrastructure is going to respond and recover, how it is going to respond, at the same time how it is going to recover to the original functionality, maybe good structural as well as functional performance after certain kind of events. For example, you may say the high rainfall is there, high temperatures are there, or maybe in extreme cases you may have some kind of high intensity earthquake and all. So these are the two things which is getting a lot of attention in terms of how do we design, how do we construct, what technology has to be put up. So this particular presentation is going to give only very like simple aspect about the recycling. We are not able to cover everything in this particular presentation. If you see the challenges in the road sector nowadays, and these are quite obvious challenges, we all know about that. The materials are not really going to last forever. In fact, many of the places, good quality material is also not available. You may have the premature failures of roads sometimes. There can be many reasons for that. Environmental issues that we are talking about, though we talk about a lot of emissions, pollutions, but you will hardly find that people are talking about the hot mix plant or like concrete mix plant and something like that in this particular aspect. And if you visit any of the plant, you may see the kind of emissions which is really going to be concerned. Within the city, you may have many other challenges. Sometimes getting the machineries and getting the mixes, the location, construction, quality control, a lot of issues are there. Traffic overloading is concerned, and many of the places we have seen that the design VDF is adopted 5 or 6, but in reality, the VDF or the loading goes beyond that. And of course, you have the rainfall, temperature, and climate change, which is happening nowadays. One of the major concerns, if you see, the high cost. And there is a lot of initiative taken in this particular direction to bring it down. But you cannot bring it down just by adopting whatever the technology you want. It has to be at the same time the durable, cost-effective, long life should be there. Life cycle costs need to be considered in this particular aspect. Waste management is again getting a lot of attention. When I say the waste management, it doesn't mean that any of the waste, whatever you see, it can be dumped into the payment. It has to be quantified, it has to be characterized in the engineering sense. And based on that, you can only understand that whether this particular material is going to go into the payment systems or not. Construction time, of course, that is the very high pressure sometimes to do the construction within the time or maybe before the time. And that sometimes gives a lot of challenges to the practitioners in terms of maintaining the consistent quality throughout the project. Sustainable payments, this is again, we have been talking, but how do we really achieve the sustainable payment? Whether just considering recycling is going to make it sustainable, or considering some kind of waste material is going to make it sustainable? Maybe not actually. You need to consider this is a like combination of various parameters which is going to come up. Quality control, investment plan and policy, these are another area that you can think about. If you see many of the places you are going to see the existing damaged road, which is looks to be like that, or maybe better than that, or bad than, worse than this particular condition. You may also find sometimes the RAP is stockpiled on the plant, and this is the mill material which has come up and which has been stockpiled. How do we use that? What do we do? All these kind of things we are going to talk about. If you see the benefit of recycling, which is definitely like about all these kind of benefits of the recycling. You can cut down the cost of material, you can cut down the energy conservation, you can improve the riding quality, faster construction, you can eliminate all kind of distresses that you see on the payment, or on carbon credits and all kind of things. These all are known facts. So this is not like I'm just telling you and then only you come to know about this kind of benefits. These are already known. What is not known to the industry, that how do we really use the technology in a sensible way which gives the benefit. And if you see the classification of the recycling, And broadly, you can quickly classify in terms of the cold recycling, in terms of the hot recycling. And this is the broad classification of recycling. Within that, you can do further classification, which we are going to see later on. And if you see the cold recycling, please pay the attention. I'm writing here wrap only. I'm not talking about any other layer. I'm just talking about the bituminous layer, which is there. And if you are talking about the cold recycling, using the emulsion or using the foam bitumen, but remember, we are only talking about the bituminous layer. Maybe you can say maybe 5 inches or 6 inches or something like that, the top layer of bituminous layer, which is we are going to mill it. You can do in situ, you can do in plant also. When you do in situ, you can call it cold in place recycling. When you do in the plant, you can call it cold central plant recycling. And both of these kind of technologies are now picking up in India. In fact, we have been doing this kind of, these two technologies are quite popular. You will see a lot of work in this particular direction, but this particular CCPR is also now in the practice. Another thing which I sometimes find people get confused, that cold recycling and FDR. So remember, the FDR is also part of the cold recycling, but when you say that, at the same time, you are considering two things together. One is the bituminous layer. At the same time, you are also considering aggregate layer, or maybe in the extreme cases, you may go up to the subgrade. Possible. It depends upon project to project. And if you do that, you have the bituminous layer, you have the aggregate layer, or in extreme cases, you have the some subgrade layer. I mean, the material is coming up. You can do that. You have the emulsion foam, you have cementitious additives, which can be anything. It can be cement, it can be fly ash, it can be combination of lime, cement, fly ash, it can be additive, liquid additives, whatever it is actually. This particular techniques where you are going to use wrap plus aggregate plus other layers, which is going to call it FDR. And this is also part of the cold recycling, but yes, the kind of characterization, the methods are slightly different. This is very important slide if you understand the cold in place recycling, that how do we do in place recycling. You may find it single unit train, you may find 2 unit train, you may find multi-unit train. Right now in India, we have been doing only single unit train actually. And when I say the single unit train, it means you have one piece of equipment which is going to mill, recycle, everything. Of course, there are other kind of equipment components are also there. You have the water tanker, rollers and all. But mainly when I say the single unit train, this is what it is. You don't have any screening, you don't have any crushing, you don't have any kind of paver, nothing. It is just one unit which is going to mill, which is going to mix everything together and then go ahead. Certain constraints are there, certain limitations are there. You may not have the consistent gradations, you may not have the consistent quality sometimes, and also the quality of the paving may not be as good as you do using paver. Another comes the 2 unit train, where everything is same, but you are going to have the paver now actually. So machine is there, and behind that you have the paver, and then paver is going to pave things together. And that gives quite good consistency in terms of the thickness, the quality, and all kind of things. However, at the same time, there is no crushing unit, there is no screening unit, so gradation may be inconsistent, and consistency may not be there as compared to the multi-unit train. If you see the multi-unit train, which has almost everything in that, you have the milling unit, you have the crushing unit, you have the screening unit, you have the pug mill, which is going to mix there itself, and then you have the paver. So ultimately, you are doing everything: milling, screening, crushing, and then making sure the gradations are consistent because you have the screening there, and then you go ahead with the use of the paver. This particular slide shows you a single unit train. So where you have this particular unit, and this unit does everything. When I say everything, it means this is milling, adding some kind of additives, and after that you have the compactions, and then you get it done. If you go with the multi-unit train, the 2 unit train, See here, this particular machine is there. And if you see, this particular paver is also there actually. So this machine is going to mill, and then mill material is going to kind of mix together, and then this is going to come to the paver. And paver is going to pave it. So you may have very good consistency in terms of the thickness, in terms of the quality along the length, width, and all. And if you go to the multi-unit train, and multi-unit train looks like you have the screening unit, milling is there, you have crushing, screening, everything is there, and after that you have this particular unit, and also the paver is also attached sometimes to have the consistent paving practices. Another kind of unit is also there. The principles going to be same. And if you see the cold center plant recycling, and this is also quite important now. Cold center plant recycling, what do? You have the conventional plant or you have the standalone plant. When I say the conventional plant, it means whatever plant sometimes you use for DLC and WMM, you can retrofit them. You have some silos for fillers, let's say maybe lime, cement, or whatever, and you have the pug mills, and you can adjust it, like you can convert it. Sometimes you have the standalone plant, which is kind of some company supplies, and you can use those plants also. For example, this is what it is. If you have CCPR, this is dedicated plant is there, and this plant is used. If you can see this particular plant, this is the wrap is there, and wrap goes in here, and then pug mill is there, and after that the cold mix comes from here actually. This is a dedicated plant. You can also have the similarly the conventional plant. You can retrofit them and then you can use it. Now, one important thing which you need to understand that how do we use these cold recycling techniques in the combinations? And this kind of combinations becomes quite cost effective, and sometimes it becomes to bring better quality in terms of what kind of approaches that we're using. For example, you may have combination of CCPR and you may have combination of CIPR. How do we do sometimes? Let's say this is a project here which is going to be taken up. You just mill this particular top layer, because sometimes what happens, this CIPR cannot take more than maybe, let's say, like typically you are going to see in the industry, people go maybe more than 150 or 200 or so. But you take it out and then put it in the plant, and then remaining layer, whatever is there on the bottom, you use this particular CIPR and then bring this back here, and then have the very consistent and good quality layer on top of that. And then of course, on top of this, you are going to put another bituminous layer around it. You may also have the combination of FDR and CCPR. You may have combination of FDR and CCPR. How it works, you have the payment system here. And if you see, this particular layer is quite good layer, which is bituminous layer, and which has to be taken out. You mill it, stockpile that in the plant, and this particular layer can be done using FDR. And then you can improve the base layer and subgrade layer. You can make a very strong layer on the bottom, and then bring back this particular CCPR from the plant, and then lay down this particular layer. So this is how the combination of the recycling can be taken up. Depending upon the project to project, you have to assess that what kind of techniques, what kind of combination can be put up. Another very interesting thing that you can do, that you can think about, is cold recycling techniques plus some kind of other technology can come up. For example, you have cold in place recycling, cold central plant recycling, then you have FDR. Along these three techniques, you can use microsurfacing, surface dressing, thin bituminous layer, cap seal, all this kind of layer can be used depending upon the traffic, load, climate, or depending upon the requirement of the project. And this is one of the case studies that I will go very quickly, where the CIPR was done. And if you see, this is the condition of the road. And this particular road supposed to be milled. And in this particular road, the CIPR was used, which is cold in place recycling, using emulsion. And initially, the fresh aggregate was spread. The reason for spreading the fresh aggregate sometimes to get the gradation within the limit, and also sometimes to improve some kind of mechanical strength of the particular milled material. And you also spreading some kind of filler. Usually it can be cement, it can be lime, but you cannot go very high doses of this cement and lime, because that may create some kind of issues in terms of the quality of the mix that you are going to produce. It may make it very stiff. Once you have this, and if you see this particular train, this is a single unit train that we talked about, single unit. And when the single unit, this particular, and this is the emulsion truck here, you have the water truck here, and this particular unit, and at this particular place, you have everything mixing up together. And after that, you have the grader to make sure you maintain the profile. And then after that, you have the heavy rollers. The rolling using heavy roller is very important because this is the kind of cold mix. And the cold mix has very high air void. Sometimes if you don't compact it, the air void may go as high as maybe 18 to 20%. So you definitely require very high rolling. In fact, sometimes the PTR is also used for making sure that the kind of the rolling is consistent. I mean, quality is consistent. Once you see this particular finished surface, this is how it look like. And you cannot leave it like that. As I told you, this particular layer has very high air voids. You need to cover it up. And when I say the cover it up, you can use microsurfacing, slurry seal, thin overlay, surface dressing, cap seal, bituminous layer, DBM, BC, depending upon what is your requirement actually project to project. And this is how things look like. Now, FDR is another cold recycling technique which is coming up. And in this particular thing, as I told you, the wrap layer, which is the bituminous layer, plus the aggregate or other layers are getting combined together. And if you see this particular process here, this is the bituminous layer here, this is the granular layer, this is subgrade layer. And this particular thing, this bituminous plus granular layer has been stabilized. Now, this particular stabilized layer is produced using excuse me, FDR. On top of that, you have the new surface layer. You cannot leave FDR as it is because, again, it is going to have very high air void, and also sometimes it is not going to survive the kind of the rain or the moisture. You need to cover it up. Depending upon the traffic, depending upon the project, maybe the microsurfacing may work, maybe the surface dressing may work, 1 layer, 2 layer, maybe some other technique can also work. That depends upon project to project. And if you see the kind of additive that has been used, in fact, that depends upon what kind of aggregate you have. Remember, what do we have here? We have the bituminous layer plus the aggregate layer, and sometimes some part of subgrade may also come up. As a whole, we need to characterize that what kind of material that you have, whether it is classifying in DW or maybe SM or whatever it is. And then based on that, you may use emulsion, you may use foam, you may use cement, you may use lime. We have not seen that FDR is used, very widely used using emulsion and foam bitumen, because you have huge volume of aggregate and other kind of layers in that. So usually cement or any other additives is widely used for this particular purpose. And these are the photographs taken from one of the projects where the FDR is going on. Another thing is the hot recycling. Now, hot recycling can also be characterized in two. One, you have hot in plant recycling and hot in place recycling. Now, if you further characterize that, the hot in plant recycling and hot in place recycling. In hot in plant recycling, you can go up to 10 to 50, even more sometimes. However, remember that the type of the plant is very, very critical. Whatever the plant I have seen so far, you may try maximum 30%. Some people are trying different kind of combinations and trying to claim that they have gone up to 50%. But remember, the approaches they are using may not be logical sometimes. And we have seen sometimes people are using hot wrap and cold wrap, and in combination, they are saying they're using 50% wrap. You require a specialized plant sometimes. If you're going for 60% wrap, the ordinary plant is not going to work out. Whether it is batch mix plant, whether it is whatever the current plant that you have, double barrel drum or whatever it is not going to work out. You require parallel drum plants, which is I have not seen so far actually in India. And if you go for the hot in situ recycling, where you can definitely use 100% wrap, however, the limitations sometimes are the thickness. You cannot go more than 50 mm. The reason is because we need to heat everything in situ. You need to heat everything Of course, you can use combination of hot in place recycling and cold in place recycling. It all depends upon the project to project. How do we design the kind of system where we can adopt multiple technologies together. This is how the RAP comes up, and this is how RAP is stockpiled in the plan. This is the huge volume of RAP. One of the projects we have seen almost 90,000 tons of the RAP was stored actually, and contractor has no clue what to do with that actually. Now, the first step, which is very, very critical if you're really planning to use RAP in any of the project, whether it is cold recycling, whether it is hot recycling, whatever it is actually, make sure it is processed actually. And when I say the process, you do the fractionalization. You can have different sizes here, maybe size A, size B. And once you have different sizes of this RAP, then you have the better control on the gradation. And combine it together, and this is how you are going to get the very consistent quality, whether it is hot recycling, cold recycling, whatever it is actually. And this process is very important in CCPR, called central plant recycling, and also the hot in plant recycling. This is how things look like. You have, by the way, here we are using the RAP as a cold RAP. When I say the cold RAP, and when I say the hot RAP, essentially we are not using hot RAP actually. When I say the hot RAP, it means you have separate drum for heating the RAP, and then mixing with a rejuvenator and then coming up. Cold RAP, what happens actually, this particular RAP is going to come here, and RAP goes on the top. It comes, weighing is here, and after the weighing, this is the hot mix is coming here, aggregates are coming. Now, if you remember here, the RAP is coming here, and your aggregates are here, and with between you are mixing up. You have no control on the gradation actually here. There is no control on the gradation of the RAP. Whatever RAP you have on the stockpile, and therefore you have to have very good control and consistency in terms of the quality that you are going to use. The gradation is very important. The consistency is very important. Otherwise, you are going to put something here, and there is no gradation, there is no sieve size, or there is no sieving mechanism that you can sieve this particular RAP and then use it, because this is challenging sometimes. And another thing is hot in place recycling. And hot in place recycling, if you can see, one of the projects were done in Ranchi. This kind of units are there, this kind of plates are there, which is going to heat this particular pavement, and then you scarify it, and you see another heater here. And the only limitation, as I told you, that you cannot heat more than 40 to 50 mm, because a lot of logistic issues are there. And you see this particular propane tank, which is having some kind of gas here, propane gas. This another challenging area, that what kind of fuel has to be used for heating, and then huge volume of fuel is required, and sometimes some accident also happens in the type of the fuel that you're using. And this is how things works out. There are certain other technology. Remember, there are certain other technology that you can also think about. For example, what kind of binder has to be selected depending upon the area, what kind of mix has to be used, what kind of technology, like for example, SMA is there. We already talked about the cold recycling. Then you have the maintenance and preservation techniques. Then you have ultra thin overlay. Then you have warm mixes, full depth reclamations. And also you have intelligent compactions, hot in place, hot in plant, waste material, white topping, short panel, 2D technology. These are all technologies are there, which is lying into this, the domain that you can pick up always actually. Yeah. But remember, this is what I tell you, whatever technology you want, whether it is recycling, waste material, whatever it is actually, first you need to understand. Then you require the technical support or technical understanding. Then training is required. Then quality control mechanism has to be there. Then you accept the policy. Data and performance feedback is very, very critical. You cannot lay it and forget actually. It's better to collect the data, understand that, tweak it, refine it, lay it further actually. Therefore, if you follow all these steps, then you are going to go to the successful implementation of the technology, whatever you adopt actually. But remember, we are talking about the technologies, but the paving practices plays very, very critical role. How you are going to pave the pavement. whether it is recycling, whether it is hot mix and cold mix or waste plastic or whatever it is, the paving practices are going to play very, very critical roles. So technology is not going to help you if you don't have this kind of motivation with you. And with that, my time is up, 30 minutes. And if you have any questions, I'd be happy to answer.
As P18 and part 2, we are supposed to do some sort of a crack relief layer. But is pre-cracking a sort of a solution which we can adopt? For example, if you are going for an overlay, maybe less than 50 or something.
Right.
Is it
So
but
that's very good point actually. So the pre-cracking concept is there. In fact, in Africa and some part of US, I have seen that pre-cracking can help to mitigate that kind of shrinkage crack which comes on stabilized layer. But remember, if you are going for high strength of CTBF or FDR, then only this concern is going to come up. So therefore, I think sometimes I have seen people are saying that we have done FDR, our CTB is going 10 MPa, 7 MPa, 8 MPa. I don't think we definitely require that much high kind of strength. If you see the international literature, sometimes they go even, like close to 4 or maybe even 3 MPa or 4 MPa. But yes, you're right. I think this technology can be used, but however, we need to see how the pre-cracking is to be done. It should not happen that damage is done right there only after putting high vibration on top of the CTB actually. Otherwise, you have to use some kind of crack relief layer, maybe SAMI or geosynthetics or glass grids or some kind of like surface dressings and all actually. So I have not seen actually, by the way, who is doing that, but it is possible, but we need to monitor that actually.
Thank you, sir. Thank you, sir. So next we will have a doubt clearance session regarding the keynote session by Dr. Rajesh Krishnan, Transport System. So if you have any doubts, sir.
This is to Indian transport system, Rajesh Krishnan. Sir, the tragic death of Cyrus Mystery could have been averted if there was a car-to-car communication like in the West. IOC, Internet of Car, on the lines of IoT. And also if there was
Recording in progress.
Also, if there was an installation of car black box, it is in the pipeline. If there is a car black box, the actual causes of Mystery's life could have been solved earlier. So this is on your talk line I am speaking. You also mentioned about such data sharing after accidents on the lines of autopsy. Autopsy in postmortem reports, we are collecting data to save future patients. So on that lines, traffic deaths can be analyzed and taking all big data from car black box data. That is on the pipeline. Sir, I am asking about a hypothetical situation of autonomous car traffic jam. What would be in the paradigm of Indian smart transport system, what would be the situation when a traffic jam happens merely by autonomous driverless car? What would be it end up? This is a hypothetical question.
Autonomous vehicles as that are currently being tested essentially can sense the environment around them.
Okay.
They have a number of different sensor types, cameras, LiDAR, radar, and it essentially has an analogous car following model. Based on it wants to proceed, it detects the vicinity, the immediate neighborhood of what is there, and either proceeds or it does not proceed.
At the basis of trolley problem, trolley. If a kid comes before a autonomous car, it saves the kid rather than a senior person.
I don't think autonomous cars are that intelligent at the moment. What the autonomous vehicles that are available or being tested right now would do is, it will detect that there is something in front of it and it will stop.
Okay.
So if it ends up in a traffic jam, it will merely stop. I don't think it would proceed.
Okay.
Having said that, in the research realm, in academia, one of the areas that people are exploring is how can you optimally route vehicles when the system, the traffic signal system, can communicate with autonomous vehicles. Currently, the route choice and even departure time choice is something that the system cannot control.
Sir, in the Cyrus mystery case, if there was a car-to-car communication, the other driver in the other car could have raised an alarm because somebody is dozing or under booze. This accident could have saved if there is a proper car-to-car communication.
Sure. I mean, even not even that. That is a bit futuristic. There is a technology called virtual VMS, which is used widely in Australia because a lot of areas of Australia are sparsely populated and it's very costly to install VMSs. So this essentially is either an integration with the dashboard LED display or a mobile app. And what it does is, based on that system, regularly updates the present location of the vehicle. And what happens if you set up a VMS message? For example, be careful, there's a bridge ahead or a narrow bridge ahead. That will automatically pop up with a ping. And then the driver will be alert. So virtual VMS technology is available today, used in Australia and a few other countries. Even that technology could probably have saved the life because it would have given an alert before the bridge. So that is...
anyway, it was a tragic demise.
That is correct. And it also, I mean, and this technology is not very costly to implement because there is no physical infrastructure. It's just a mobile app that people need to register with the service that the government can provide. And these are some of the low-hanging fruits that we should actually consider as a country to first pilot and then roll out more widely.
Okay, sir. A question to the Guwahati, Bayan Singh has gone.
Thank you, sir. Next, we can start our paper presentation session. So panel, please note the paper ID 8356, topic previous concrete payments, a resilient strategy for urban stormwater management by Spurti B.M., Bernali Debnath, Priyanka Gautam, Agash Kopa, and Anush Chandrapa. So the paper is presented by Dr. Anush Chandrapa.
Yes, I'm audible to you all?
Yes, sir.
Yeah, ready. Let me just share the screen. So I hope you can see the screen in full screen mode. Okay. Yeah. It's visible now in full screen mode. Okay. So good evening all. So basically in this paper, we'll try to discuss how do we design the pervious concrete pavement considering hydrological aspect. So generally, if you see the pervious concrete, we go with the low volume roads. Now this low volume roads, we don't need a structural design basically because it's just a traffic, as we discussed in the morning, traffic of car, bike and cycles. So the main impact here is the hydrological design. Whatever rainfall occurs on the pavement, that rainfall should be easily percolated into the system. That's what we'll demonstrate here with few examples and methodology. This paper was done in collaboration with Priyanka and Akash, who are postdoctoral in IIT Bombay and in Belgium, respectively. So in the morning, we discussed that as we urbanizing, we are trying to make the whole urban area impervious. So finally, we end up in a situation where, as you see in the photograph, that it's a recent colony in Bangalore, one of the very posh colony, where due to incessant rainfall, very heavy rainfall, the whole area got flooded within no time. The people have to use tractors or even boats. Even in fact, the Ola had a boat there to ship people safely to other places. This kind of situations will now occur very often due to incessant urbanization. So the urban design should be made resilient considering various payment technologies, what we discussed in the morning keynote lecture. Now, these technologies, what we decide, are basically they're called as low impact development technologies, because when we implement these technologies, right, let's say pervious concrete or any other technology, they won't bring a significant change in the environment or the urban climate. That way we call it low impact technologies, right? So the problem statement is that what happens if we keep laying impervious pavement? So till what extent we can keep laying it impervious? It's a completely the ground gets sealed. Then where does the water has to go? What about water recharge? And does the next generations will be able to drink water to the ground? These all questions come into mind because these are actually high impact development technologies. They cause significant impact on the environment. So basically, in this paper, we try to understand the impact of impervious parking lot on stormwater runoff and water recharge, and provide some design for selected metro cities in India to implement the pervious concrete in future. That means we'll give a methodology to design the pervious concrete hydrologically for a given city. So basically, why pervious concrete? There are several other porous materials like porous asphalt is there, we have permeable block, etc. But the study has found that the pervious concrete provides excellent performance compared to other porous materials, as shown by the following studies. So generally, the pervious concrete has a pervious concrete slab, which is a gateway for the rainwater, and then it has a storm reservoir layer. So this reservoir layer acts as a temporary storage for the rainwater, because the difference in the permeability between the soil and the pervious concrete is very high. So slowly the water stores in the reservoir layer and percolates through the subgrade. That's where the reservoir layer plays a very major function. The methodology basically includes, we selected some metro cities, and within the metro cities, we took some major parking lots, such that the parking lots were impermeable and open to sky, and determining the area of parking lots through Google Map. And we procured data of IMD for at least 10 years, the past 10 years, to develop IDF curve, that is intensity, duration, frequency curves, which are basically used to design any hydrological structure. Then selection of design rainfall intensity for a pervious concrete, calculating what runoff would be generated with this impervious surface for a given design rainfall. With that, we determine the porosity of reservoir layer experimentally, and then design the pervious concrete for a given rainfall requirements. And finally, we recommend few construction practice, right, where we can improve the water recharge to pervious concrete. This one basically, we take around 6 metro cities, including Kolkata, Mumbai, Hyderabad, Bangalore, Delhi, Chennai. So these are selected because they're very highly urbanized, and in the recent past 5 or 6 years, they have seen significant flooding whenever rainfall occurs. We took around 15 to 12 parking lots in various cities. We can see here the kind of parking lot that is selected. They're mostly impervious, either asphalt concrete or cement concrete, and they're open to sky. That means there is no shelter. Whatever rainfall occurs in those pavement, it's basically a runoff, right? We use a distance function Google Map to calculate the area. This is a total area what we are able to achieve, or we got from the Google Maps. So obviously each city is having different because they're independent of each other. Then we developed IDF curve. In fact, Priyanka and Akash helped us to develop the IDF curve because they work in that particular domain. So we can see that the Mumbai obviously is having very high rainfall. If you see the return period, so 2-year means the 2-year return period. 5-year means 5-year return period. So as we go to higher return periods, the intensity will actually increase. Obviously, we know that very heavy disaster or a big disaster comes. They won't come very frequent. They take several years to form, and then they come as a disaster. So a 50-year rainfall is having very high intensity compared to 2-year rainfall. Again, for Hyderabad, we developed, then Kolkata, Delhi, Bangalore. Similarly, we came up with the IDF curve for these all 5 cities. For Chennai, we didn't do because there was some data error, so we didn't continue with Chennai city. So then, this is what the intensity we chosen. So we took around 3 different design rainfall events. One is 2-year, 2-hour return period, 5-year, 2-hour return period, then 10-year, 2-hour return period. So with this rainfall data. This is the intensity of rainfall. As we can see, with increase in the return period, certainly the intensity is increasing. For example, in 2-year rainfall, it is 25 mm. If it is 10 year, it's 142 mm. It's quite heavy rainfall, we can say, obviously. So then with that, by multiplying whatever total area we had calculated of parking lot with this particular rainfall, like say 25.09 mm, we got this is the volume of runoff generated for a given event of rainfall. If you see for 2-year rainfall, it's quite 760 mm. But if for 10-year, it's quite very big number. You can see in Mumbai, almost 42,000 meter cube for considering 10-year rainfall. So now this is a rainfall which should be stored in the pervious concrete, eventually reaching the groundwater. So to get the design, we developed a simple methodology where we take any design rainfall. It can be as per the user requirement, because the design of pervious concrete is very customizable. As per the rainfall data or the requirement, they can design taking different rainfalls. So determine design rainfall, then determine the catchment area. Now catchment area is basically our parking lot is the catchment area. So once we find the area of parking lot, we multiply with the volume of the rainfall intensity to get the volume. So that is the volume which we should design the pervious concrete thickness, so that we know the volume. So we know the area, we'll find the thickness. That's where we have A into PR and HR are basically thickness and the porosity of reservoir layer, and PP and HP are thickness of pervious concrete layer. Now, since we know the volume of water, what it has to be designed for, we know the area of parking lot. So let's say we also know the porosity of reservoir layer or pervious concrete layer. So we can calculate the thickness of reservoir layer. Now, generally in the hydrological design, we don't design thickness of pervious concrete. Now, pervious concrete generally it is 6 inch to 8 inch, maybe 150 to 200 thickness. So we don't take into account thickness of pervious concrete, because to make it design more conservative, if you take into account the thickness of the HR will decrease, the thickness of reservoir layer will decrease. So to make it more conservative, we don't take into account. So we basically it's HR is V by A into porosity of reservoir layer. And then once we determine the thickness of reservoir layer, we find detention time. Detention time is something, the time to how long the water can store in the reservoir layer. Now, ideally, as the water enters reservoir layer, it has to go to subgrade. That should be ideal condition. But that cannot happen because the permeability between subgrade and the reservoir are quite different. So it will detain or wait in the reservoir layer for some time and then percolate the subgrade. That's why we call TD. We can find TD in this equation considering the thickness of reservoir layer, porosity of reservoir layer, and considering the subgrade infiltration capacity, which is quite very low. So then what we'll do, we'll just compare what a TD and TD assume. So generally we assume a TD 24 hours. 24 hours means what? 24 hours after the whole system becomes free of water. That means whatever porosity we had, that is regained or free of water. If you assume 2 hours, within 2 hours, the water has to percolate entirely the system like that. So if it is TD less than TD assume, the thickness is safe. If not, we can recalculate the HR or thickness of reservoir layer using assumed TD. So this way we've done the calculations, right? See, for different cities. This is the porosity of the layer, the HR, what we got, that is the 42.07%. Using the, generally we can take either the IRC North grading 4 of GSV to find to act as reservoir layer, and this is the thickness of the layer what we got. So you can see as we increase the rainfall intensity, certainly thickness is increasing, and this is more or less for a 5-year rainfall data. The thickness of reservoir layer is more or less thickness of GSV, what we provide in generally highways or low volume roads. That way, we are able to get the thickness of our different rainfall intensities of the reservoir layer. So then we determine the detention time. So you can see the detention time, how it is basically vary. So for example, if you take a 2-year rainfall, it is 2 hours. So 2 hours means within 2 hours, the whole water leaves the pervious concrete layer and reservoir layer and percolates subgrade. That means the reservoir layer and pervious concrete layer is free of water. That's the meaning of 2 hours. Similarly, if you see very heavy rainfall, it takes 51 hours because the rainfall is heavy. It takes longer time to percolate subgrade. That way, more the heavier rainfall, more detention time, less rainfall, less detention. And finally, with this, we are trying to propose, okay, if you want to build a pervious concrete pavement, improve recharge groundwater and decrease the decrease detention time, we can go with this kind of technology where we can, in the subgrade, we can build stone columns at different locations where the water can easily percolate from the reservoir layer and enter subgrade at even faster rate, improving the retention time, right? So then the final conclusions basically includes, so as we know that the by improving this, by laying pervious concrete, we can actually reduce the amount of runoff and recharge groundwater. So among the IDF curves, Mumbai had the highest rainfall, what we saw in the IDF curve. And we recommend that 5-year 2-hour rainfall can be considered as a design rainfall to design pervious concrete pavements hydrologically, because this thickness what we got is more or less thickness of GSP layer, so it won't be having much cost implications. And a new methodology was proposed where we can improve the retention time or decrease retention time for a benefit of water recharge through the rainfall, right? So the conclusions, what I mean, the references what we follow, some references, and yeah, thank you.
Thank you, Dr. Anush Chandrapa. So we have a question and answer session.
Hello,
Yes.
I am Prabhakaran, Chief Engineer retired from Department of Space. I
Yes.
have a concern on the permeability over a period of time of the concrete surface. Okay.
Yes, sir.
Is there any means by which you will ensure the permeability holds good throughout the life cycle? One, permeability will be affected due to the finer particles getting carried by the rainwater and also the microplastic or so many other things. Plus, the exhaust from the vehicle that comes out, it contains grease, oil, this thing, that prevents the pores to be effective. Do you have something like declogging of the pavement?
Yes, yes. So generally, we also did studies here in IIT Bhubaneswar also, where we try to declog the materials. Generally, what happens, the current practice is that if you see Japan or USA, they generally clean the pervious concrete yearly twice using pressure washing and vacuuming. You can regain at least 90% permeability. And in the morning, we discussed about 2-layer pervious concrete. So this 2-layer pervious concrete does not allow the clogging material to go into the structure. So that way, we can ensure a good amount of permeability throughout life cycle. Yes, sir.
Recent Mumbai and Chennai flash flood because of water runoff. It is the aftermath of climate change is that unpredictable intensity of rain everywhere, even in rural as well as in metro areas. So the cloud burst is everywhere. Then what about the concrete porosity would be like? Because it is the product of a lot of erratic climate.
Yeah. So actually, when we see the urban design, so as I told in the morning also, if we can reduce the amount of impervious surface in urban area, certainly we can reduce the amount of flooding. That so we need to actually identify the pockets where we can actually provide low-impact development technologies accordingly designed, so we can reduce the amount of flooding. That way, we can actually make it more resilient.
Okay, sir. Okay, sir.
And that is how the China is making their spawn cities, or US is bringing this low-impact development technologies.
Okay, sir. Okay.
Yes, sir.
Dr. Anush?
Yes, yes.
Yeah. So I just have one query. So, you were saying that this, like whatever clogging that is happening, that can be actually taken care by pressure washing or vacuuming. So,
Yes.
is there any comparison between these two, like pressure washing as well as vacuuming?
See, generally what method is that first we pressure wash and then we vacuum. That means either we can go with compressed air to make the dust particles loosen and then we vacuum it. Right? This is one method. Sometimes people also use pressure washing and then they dry it to vacuum.
Okay.
So it's a series process. First they will wash it and then vacuum it.
Okay.
And
Because
there are-
my only concern is like we are having the stormwater. It's kind of a regeneration, and we are actually using more water in cleaning the clogging. So
Yeah, that's why if you see in the morning, we actually used dry air to clean it, compressed air. In the morning studies, what we show, preferably it's to go with compressed air, make the dust loosen, and then vacuum it. That way we can actually make it more resilient.
Yes. Okay. So maybe that would be a better option than with water, right? Yes.
Yeah,
Thank
because
you.
some studies have used pressure washing and some studies have used compressed air.
Okay.
Yeah.
Okay. Yeah. Thank you.
Okay.
Thank you, sir.
Okay, madam.
Dr. Anish, just mentioning that stone columns, I have seen some stone columns there. So is it
Yeah,
something
yes.
which is, did you do any correlation with the infiltration capacity of the subgrade, or that's the reason why you have included that, or is it just...
No, we haven't done it. We plan to do it actually, but we, due to time constraint, we couldn't do it further, but we are planning it soon.
Okay.
So we are planning to keep some, to sense the moisture, understand at what rate the water will go into the subgrade.
Because the depth of the reservoir obviously depends on all these, this is the critical factor, isn't it?
Exactly. So we want to understand if we give a stone column, how much thickness of reservoir layer we can reduce. That we are trying to bring in, because currently we don't have any kind of methodology yet in this domain. We're trying to build some small sections and understand this concept actually.
So what is your initial idea about the spacing of the stone columns? Any initial ideas?
Initially, we just planned that we can keep at a spacing of 5 meter, every 5 meter one column of 1 meter or 1 meter.
Oh God, okay.
So then 5 meter spacing.
Okay, what's the diameter?
We planned a square, in a square shape.
Oh, square shape, okay.
Yeah, square shape, and we plan to go with recycled aggregates here, not the virgin aggregate, so that we can actually make it somewhere using recycled aggregates.
A recycled aggregate that is washed.
Yeah, it is
remove the fines.
Yes, okay. Only coarse recycled aggregates.
Okay, fine.
So, but we just in the initial stages, we are about to plan it now.
Oh,
yeah.
Okay, thanks.
Again on this topic of declogging, don't you think it will end up in the reservoir and then make it non-functional?
Yeah, that's what morning we discussed. The conventional pervious concrete has shown this kind of behavior where the clogging particles can go into reservoir layer. But the 2LPC, what you have done in IIT Bhubaneswar, that will actually hold all the materials in the top itself. If you see, the figure what we show in the morning from our laboratory studies, we found that the clogging materials won't pass through the system of pervious concrete because everything is held on top.
Thank you, sir.
Yeah.
So next paper, sir, paper presentation by Sudhishna, and paper ID is 1889, and the title is Subgrade Stabilization Using Novocrate, a Step Towards Resilient Pavement.
Good evening, everyone. I'm Sudeshna Purkasta. I am from IIT Palakkad. I am an MS scholar. So today my topic for presentation is subgrade stabilization using Novocrete, a step towards resilient pavement. This work has been done by me and my guide, Dr. Veena Benudharan. So, So we all know that soil subgrade is one of the most integral part of pavement. When we talk about pavement, the most important part that comes to our mind is soil subgrade. But subgrade in its natural form is not strong enough to withstand the kind of load it is supposed to take. So we need to do some sort of soil improvement technique. So the common soil ground improvement techniques that we commonly use are soil replacement, pre-compression, vertical drains, and soil stabilization. Out of all of this, soil stabilization is the most commonly used because it is less tedious, it's economical, and it doesn't require that much time. So out of all the soil stabilizer, the most commonly used are cement, lime, and bitumen. All of these are excellent soil stabilizers, but they increase the bearing capacity a lot. They help in consolidation and everything, but the main problem that all of the soil stabilizer face is that they have environmental impacts. In fact, cement is considered as the second largest contributor of pollution. In fact, bitumen also is considered as 97% of human toxicity is contributed by bitumen. So what we need is a sustainable stabilizer. So when we talk about sustainable stabilizer, we mean a stabilizer which is recyclable, which has minimum cost, which has good workability, and the most important thing, it should have less environmental impact. It should not, there should be not any emission of GHG gases or any heavy materials like cadmium or arsenic. So the stabilizer that we have used in our project is NovoCree. It's a very new compound that we have found. It is basically made of oxide, sulfate, chloride, and silicate. So it's manufactured by a German company, and it is recyclable, and it is grayish in color, and it is found to have very less environmental impact. So the major advantages of NovoCree is that its hydration process takes only 90 days, and there is no cracking, and the bearing strength that it offers is it's found to have almost 150 kilonewton, and in pavement we require at least 20 to 40, but it's offering a great bearing capacity, and its mechanism, like it would form a crystalline structure, so which would induce interlocking, and because of the interlocking, there will be very less void, so it makes the soil subgrade impermeable, and hence there won't be any infiltration of any water even after the construction. So our project site was Abu Dhabi, and the main problem in that side was that there was very less soil aggregates, and the soil present there was Sabka soil, which has very less bearing capacity, and it's very difficult to work with that. So there were only two options left. Either we have to make the pavement thick enough to make it so that it can withhold all the traffic, or we can make the subgrade strong enough so that so that it can withhold the traffic. So we did our subgrade stabilization, and the major test that we have done to determine our engineering properties was standard Proctor test. It was done according to American standard, and standard Proctor is basically the test which we do to determine the maximum dry density and the optimum moisture content. So it was found to have, it showed very good results, almost 1.827 gram per cc. It showed maximum dry density and OMC of 12.3%. The next test that was done was UCS test. This test is basically done to check the shear strength of the soil, and it also showed it was also done according to American standards, and it also showed very good results. Almost 50 psi, it increased by 50 psi, that is almost 350 or 340 kilopascal. The next test that was done was California bearing ratio. This is the test which is very important in pavement technology. This test we do to check the resistance to penetration. So the CBR that we found after adding our stabilizer was 26%, and it increased by almost 90%. So the design of pavement was done according to ASTO, which is American Association of State Highway and Transport Officials. It is basically based on ASHO test, which was done to make long-lasting, durable, and economic pavements. So this is the empirical formula that we have used in the pavement, and in this the MR we are changing, and the traffic W18 we have taken the highest peak traffic that we estimated that it would take, and the main parameter here would be SN, which is structural number. The structural number is higher the structural number, higher would be the strength of the pavement. So the structural number that we got after stabilization was 3.42, and we have done it using we have done the test using three techniques, like with conventional method, NovoCree stabilization, and also cement stabilization. And we can see that we try to reduce the asphalt concrete since it's the most expensive part. So we can see that in NovoCree stabilization, the asphalt concrete was 7, and it showed the highest structural number, which is 3.42. these are the cross section of the pavement. So we can see that the Novocrete stabilization has the thinnest pavement layer, and we have done the cost analysis also. The cost analysis, you can see that conventional technique takes almost 80 lakhs, cement took 96 lakhs, 42,000, but Novocrete stabilization, it took only 62 lakhs, 5,100. So we can see that we got a savings of almost 28%. And so we can say that Novocrete it is a sustainable stabilizer. It not only increases the strength, but it also helps in reducing the pavement thickness. That is, it helps in making the pavement economical and long-lasting. We saw that with only 2% inclusion in Novocrete, almost 4% increase in structural number was seen, and we nearly could save 2 lakhs after using Novocrete. But still, since it is a very recent technology, not a lot of study has been done it in yet. So we are trying to do a lot of studies, like we know the constituents of Novocrete, what is there, chlorine, sulfur, oxygen, everything, but we don't know the environmental impact that is going to cause. So we need to do life cycle analysis and also ACM, because we don't know the compound it might form after reacting with soil. So, still we can say that it is a sustainable stabilization technique, and it would help practitioners to make sustainable pavements and help to make long-lasting and durable pavements. Thank you.
Thank you, Sudeshna. Any questions or clarifications?
Can we call this Novocrete as a SDG stabilizer or a green stabilizer?
Yeah, because it's a mineral stabilizer. It doesn't have any carbon compound. So still now we can consider it as a green stabilizer. But still a lot of studies are going on.
We could term as SDG stabilizer or green?
Yeah.
Green stabilizer?
Yeah.
Okay.
Just the in situ CBR, you were mentioning, the before stabilization.
Yeah.
What was the CBR of that soil?
It was less than 1%.
Okay, less than 1.
Yeah.
And regarding the UCC test that you had conducted,
UCS,
so
yeah.
what, UCS, yeah. What was the size of the specimen?
It was, we took 78 specimen, 38 diameter and 78 height.
That mm,
Yeah.
70, 38, 78. Okay, so did you do any durability test, wet dry test as per ASTM C559?
No, still we haven't done it yet, but we're planning to do curing also to check 28 days strength.
Okay, 28 days, what you are getting 500 psi, that is the this unconfined compression test.
Yeah.
That's the 500 psi that you got.
Yeah.
Okay. Another thing regarding the design, the layer coefficient you were using 0.16. So this is something which you got from the literature,
this
or
is from ASHTO. It's
0.16 for the
0.16, yeah.
0.16. And second thing, this Novocrete is sort of a proprietary product. So did
Yeah.
you compare the price with that of the cement, or did you compare the results with as a sort of a controlled specimen with using cement? And with this material, did you do any test like that, or just simply was using
we
only
have done
Novocrete?
it with, compared with, still now we have compared it only cement.
Okay, you compared with cement.
Cement.
Okay, you
Cement
made this.
conventional and Novocrete.
Okay, so for the cement conventional, what was the, so with the same proportion, what was the unconfined compressive strength you are getting?
For cement, it was, now it failed at 20 kilonewton per second, but for cement, it failed at 16.
Okay, you were talking about the failure load. Huh?
Yeah.
Anyway, okay, fine, thanks.
Thank you.
Have you studied the performance with regard to the permeability of the substrate after
No,
stabilization?
since we are not doing still hydraulic structure design or something, so we haven't done it yet. But this could also be done.
Okay.
Thank you, Sudeshna. And Professor B.L. Boeing Singh is available here, so we can have a question and answer session.
Sir, regarding the PPP, you mentioned that there is a intergenerational and intra-generational equity. What do you mean? Please, could you elaborate on that equity?
When we look into society, there is a concept called different sections of the society. Okay. And one of the important principle of sustainable development is what we call equity. Means all section of the society should be treated. That is the basic concept. So when I apply this concept to infrastructure, means say for example, if I built a water supply scheme, that water supply scheme, the service which is being provided by water supply scheme should be made available, or every section of the society should have access to that water supply scheme. Means the facility, the service from that. That is what I'm going to say intra-generational. Within the same generation, in the same society, all sections should have access to that. And when I talk about intergenerational equity, means let us say now all of us are talking about internal combustion engine going to the electric vehicles and all those things. So to an extent, the coming generations, maybe 2-3 generations down the line, will not have the pleasure of burning petrol and smelling that petrol head kind of a feels they cannot get out of it. So we are depriving the future generation from the thrill of an IC engine. So I'm doing injustice to the future generation. So if I give this facility to them, then I'm ensuring that the future generation also have access to the same facility. Then in that case, I'm maintaining intergenerational equity. So sustainable development is basically founded on those two principles. Whatever you take it, whether you apply in the context of environment, any context, I have to think about the current generation, I have to think about the future generation. So, yeah.
So going, just a continuation of this, no, I mean, the example of burning fuel might not be a good thing for, but it is a very illustrative example for understanding the concept. Yes, yeah, yeah.
Sir, regarding PPP, unlike in US, you said that in India PPP is not work properly because the innovation index is still lower. What could be the reason? The PPP paradigm in US is entirely different from that of Indian PPP.
If you look into the maturity of the PPP market, there are certain sectors of infrastructure where India is ahead of US as far as 3Ps are concerned. But there are certain sections of the infrastructure spectrum where US is ahead also. But if we start looking into, so for a 3Ps to be successful, we need a lot of ingredients. For example, if you want to have a very good chicken curry, you need the right chicken, the particular size of chicken, then freshly cut, then you have spices, everything required. Like that, if for a 3P program to be successful, you need the right set of regulatory environment, the right set of institutional requirement, institutional capacity has to be there. For example, the private sector, the public sector who has to do it should have that kind of knowledge. There should be private sector available there also. Okay. I didn't get you. There are different spectrums of that. In India, I think, say, for example, if you want to look into wastewater sector, you don't have a water sector. You don't have too many private players who can do that. But if you talk about highways, we have our own capacities built. Highways and power, if you look into, you have private players in India. National private players are there who can do that. But if you start looking about, say, for example, take the case of waste to energy, where you want to convert the municipal solid waste to power, we don't have too many players. Maybe you might have to depend on some players who are operating in Japan or some other places, because this is a technology which is being well versed and well developed in Japanese context. That would be, I think, semiconductor is a field which will be completely privately dominated field. Okay. So there I think we have a concept called public goods. So whenever you have a public goods concept, I think the government has a role to play. But in this case, whenever we talk about the semiconductor market coming into picture, that will be a privately regulated, and then the public goods concept will not going to come into there. Okay, then in that case, it's become very easy for the private sector to sneak in there, use the technology, rip the market, and get out of it. It's possible. But in public goods, when you have that particular domain in the picture there, it's difficult to come in and go out and become a fly-by-night operator. Mhm. It lacks innovation DNA. Yes, true. That's why I think if you look into this ITS presentation, whatever he is talking about, he is trying to bring innovation in in the particular highway sector. So, for example, if you remember 20 years down the line, nobody thought about paying for the toll. Somewhere we started with this Delhi Noida flyover where we have this gold card and that card, where if you have that kind of a first tech which we have it, they started there. And people still don't buy gold card in those days. Okay, people used to still be in the queue and then cross over it. But now I think whenever the government policies is coming to picture, if you want to buy a car, a first tag has to be stick onto your windshield, and only then you can take out the car, and then you can jump past the toll plaza. That is what has happened. Okay, so that is an example of innovation which has come in there. Innovation can come in any form. It need not be always with the product design. It can always be a process design also. Okay, innovation can be anywhere.
I have a question about trust-based contracts. Given I've seen various interesting one-sided clauses in a lot of government contracts that come as a part of RFP, could you please shed some light into how these look like?
In India, we have CPWD contract, we have MES contract, and all the PWD more or less follow the CPWD contract. Okay. Then we have something called FIDIC contract. FIDIC contract, I think if you start looking into the highways, NHAI project, in early days, I think some of the highway contracts were framed by consultants from UK. If you look at the first few NHAI concession agreements, they were not developed by our Indian engineers or Indian lawyers. If we start looking into the second set of concession agreements developed by the planning commissions, they were the documents developed by the Indian lawyers. Okay, lawyers, techno lawyers. Okay, as a result, I think if you read the first concession agreement and the second concession agreement, the second concession agreement is more readable because it's being framed, drafted by an engineer with a legal background. But when you have a legal document framed by a lawyer, you start with where is, where with, and all those things. You have to remove that and understand that. So coming back to your question of trust-based, we know if there is a trust deficit, there is going to be a premium. In your contract, you're going to put a premium if there is a trust deficit. Okay. 3Ps are supposed to be a form of alliance contract where we are supposed to have a trust. Okay. But still, there is no trust. Okay. And all the contracts are being framed one-sided. Okay. That it's not a fault with anybody, I'll tell you that. Because say, for example, you are the executive engineer and you are the one who is going to dish out that project on contract. And if you say that I have to make amendment to this contract, to this particular clause, if anything goes wrong, you are liable to face all the music. Even knowing this, people will not do that. This is although it's not a story on one side. The engineer knows that this contract clause is not good. But still, he doesn't want to take that pain of changing that contract document or making that contract clause amenable to the actual scenario. Because I think once you have that issue into picture there, if anything goes wrong, he will be the one who is going to face the vigilance. Okay. So even if you want to do that, scenario is completely changed. Okay. We always want to do that. Okay. But I have seen a lot of, I'm talking about even the contracts which are being used by IITs. IIT Indore, they are also constructing it. They might be using some CPWD manual, CPWD specification. Everything must be CPWD, which is always in favor of. They says that 10% of the contract, or if you appoint a third party, they says that 10% of the material has to be tested from a third party. They will not write anything from where. Okay. Why I too have to depend on a third party? If I am IIT, I'm supposed to have a construction lab. Why should I give it out to somewhere? Why cannot I do the test on my own? But the contract says that because they have followed CPWD contract. Yeah. Okay. Any other questions?
Thank you.
entry function immediately. So I kindly request everyone to proceed to the Symphony Hall. Sir, IIT Palakkad. Sir, IIT Palakkad. Dr. Rajesh Krishnan, Professor Boeing Singh, Professor Ankit Gupta to the dais. Dear all, welcome to the valedictory function. We have come to the end of the second edition of National Conference on Resilient Infrastructure 2022. This conference has been quite eventful thanks to your active participation. These 2 days, we saw many keynote presentations by eminent subject experts and paper presentations by research scholars from across the country on the theme Climate Resilient Construction Practices. It is the vision of NCRI to bring together the eminent subject experts, industrialists, and department engineers and provide a platform to freely interact with each other and share ideas and views. Topic of resilient infrastructure development, thereby encouraging research and expanding the knowledge of the whole engineering community in Kerala. We believe that we have been successful in this regard. We will be conducting more conferences in the coming years to spread the idea of resilient infrastructure. Now, I invite Dr. B.K. Bhavatradhan of IIT Palakkad to address the gathering.
Good evening, dignitaries on the dais and the gathering. When we started off NCRI, the ideas of NCRI a couple of years back, it was very a refreshing, fresh idea that came from the side of KHRI. And Thomas Jones sir first visited IIT Palakkad, and we were discussing about how what were the different avenues in which we can collaborate, and we said, why don't we do a conference where both experts from the academia as well as the industry come together. And the idea was that, open up platforms for discussion, formal and informal discussion. So you might have noticed that of course, it did not come out to be exactly as we had planned. We had roadblocks in between, so that we all understand. But the schedule, even starting from the schedule, we said, let's put, a lot of time than the conventional conferences for lunch breaks and tea breaks, so that there is enough avenue for discussion. So in an informal setting, because what you would observe is that when we open up for questions, of course there will be questions from one or two, but in general there will be silence. So I was sharing a session on transport systems also in the parallel sessions, and then the common question in all session is silence, right? So the disconnect, it's very evident that there is a disconnect between there's nothing to conceal here. There is some amount of disconnect between what researchers present and what industry practicing engineers expect from academicians. But then I believe that we have set out a wheel in rolling, so that now we know each other, we have contact numbers, and people have started calling. And then to my pleasant surprise, Thomas Jones sir was saying that we intend to start operations in transport systems and traffic engineering recently. So very soon. So the positive, the positive outcomes will be there, and it's already, the shoots are visible, I would say. And So going along, the first version of NCRI, what we would call as the zeroth version also, because it was online because of the pandemic. And then this is the first real physical version. This also could not be completely physical because we had to conduct it in a hybrid sense because of the date conflicts, etc. So eventually, going on in the future, what we would dream for is a conference where, problems arise from around the year. Problems keep coming from the ground engineers, which can be, there should be a mechanism which lets us to circulate this in the academia, find solutions, and which will be presented, problems as well as solutions presented, so that there's a give and take between academia and industry. And the platform is very, will eventually be very enriching. So, these are all, might not happen the very next round, but eventually this is things that we are aiming for. A challenge for us in the academic standpoint is that all academic conferences are very narrow. They'll focus on maybe transportation engineering, but even further transport planning or traffic engineering. So all this will be very narrow, and when you seek research papers into a pan-civil engineering conference such as this, we wouldn't get very, we wouldn't get very huge response, of course. But what we intend to do is that, as I said, one, collect problem statements around the year, and so that we have some time to circulate them within the academic community and get answers and discuss them here, one. And two, generate a peer review mechanism that is not focused on new research objectives and research statements, but rather a peer review process that focuses on real life problems, that gives weightage to real life problems and solutions, so that they can be taken up here, which are also inclined towards the resilient solutions. So this is what going forward, what we aim for. But that's future. But this version of NCRI, we thank KHRI for taking this initiative and letting us participate and collaborate in this venture. So I thank from the side of IIT Palakkad for all stakeholders who performed very well in conducting this conference, and hope we will have better versions of this conference in the years to come. Thank you all.
Thank you, sir. The involvement of IIT Palakkad in NCRI 2022 is worthy of admiration. They have assisted and supported us in every stage of this conference, right from the planning stage. So we would like to present mementos to all the faculties of IIT Palakkad as a token of our appreciation. Now I welcome our Joint Director, Sri Thomas John, to present the memento to Dr. B.K. Bhavarthan. Dr. Rakesh J. Pillai, Dr. C.V. Veena, Dr. Senthil Kumar V, Dr. Senthil Kumar V, Dr. Sutish TV. I kindly request Dr. Rakesh J. Pillai, sir, to collect the memento. Dr. Madhu Kartik M. Dr. Adira P. I request Senthil, sir. Dr. Sanjukta Chakravarti, Dr. M.V. Anil Kumar, I request Dr. Senthil Kumar sir to collect the memento. Thank you, sir. Next is the certificate distribution ceremony. I invite Professor L. Boing Singh from IIT Guwahati to present the certificates to all the delegates who have presented their papers today. As I call your names, kindly come to the stage to collect your certificates. Mr. K. Nidesh, R.N. Shilpa, Reshmi D.S., Khadija Sensi, Mohammad Rafiq. One minute. Next, I invite Dr. Rajesh Krishnan to present the certificates. Twinkle S. I invite Dr. Ankit Gupta to present the certificate. To Abhijit Ajit, we will send the certificates, those who are attended online, by post. Now, I would like to request our keynote speakers to share your valuable opinions and advices for conducting the future NCRI conference.
I would like to thank the organizer, and special thanks goes out to my junior, Senthil Kumar. He is my junior. Junior from IIT Madras. I think I would like to say that the government of Kerala and PWD Kerala is doing a wonderful job by tapping a platform where you are trying to bridge the gap between the knowledge which is there in the academic world and the challenges which is being felt by the practitioner. Only when you have such kind of medium, then only then you can take bring this to a symbiotic relationship where both the parties to this become partners and you get benefited out of it. The challenges of the state are unique, and in the process of facing the challenges, you might hit upon certain technological solutions which may be groundbreaking sometime, okay, which may make your system resilient. Not only resilient, I think, which may make your delivery cost effective also. Need not be always the most expensive solution need not be always a solution you have. So I think the next step should be to, what I've seen with conferences is that conferences are being driven by a couple of champions, okay. In your case, I think your chief engineer is a champion, he's driving it, okay. But the moment I think he get transferred from here and go somewhere, the torch has to be handed over to somebody else who carried these torch forward. Like in the case of 4x100 meters, not like a 100-meter where you run the sprint and then stop it. Okay. So the most important thing is the longevity of the conference is very important. And I hope since the EWD department and this NCRI has already have a tie-up with IIT Palakkad, so the honest lies with Senthil to take it forward. So because he being in that particular field, organizing conferences is a bread and butter of academia. I think everybody who is in academics will appreciate this fact. Okay, if you don't publish, you don't promote, you perished. Okay, so the best thing is that since you get a partner, an industry partner who is willing to take you along, I think you should take this opportunity and then make it need not be an annual affair, can be a biannual affair, but you can have it. Okay, so planning has to be done. I'm sure I think the things was done very well. I was just going through the proceeding to see the number of publications and the themes in which you are trying to focus. Most of the time, I think maybe you can identify a thrust area in a particular conference and then focus on that thrust area in that particular conference and then do that also. Okay, but the most important thing is the champions. I'm sure we have champions in the group. So the champions is supposed to take it forward. Otherwise, logistically, nice place, nice location, nice time of the year. You don't have too much rain. The weather is very good. I think it's the right time to conduct such kind of conference. And I think you should try to go this international also, because I think once the pandemic gets over and the everything open up, then you can even think of getting a lot of international participants also coming over there, which will be a very good thing, because in addition to sharing the knowledge at the national and the state level, you will be able to get knowledge sharing taking place at international level, and in the process, you are the ones who are going to get benefited out of it. Okay, logistically, you don't have any issues. You have everything there. Okay, so this is my take. I think the most important thing is everywhere you need a champion. Okay, champions are there. You have to identify the champions. Some champions who are hiding should also be willing to come forward. The next line of champions has to be created once the first line of champions get away. Okay. With this, I would like I think others have other keynote speakers, if they have some observations they can share. This is what I have from my side, because I think I've seen a lot of conferences, a lot of things which are being done for a year or two and then they stopped. But if you look at some of the example of football tournaments like Santosh Trophy, how many years it has been going on? How about the Durand Cup? I think Kerala being a football crazy state, you will appreciate this fact, right? Durand Cup, Santosh Trophy. This has been going on, okay, because somebody was there who must have pushed it at the beginning. That's how it's still, I think once the ball start rolling, I think you don't have to kick it anymore. It rolls on it on. Okay, thank you.
Thank you, sir.
First of all, I would like to thank the organizers for inviting me and for a very well-run conference. I enjoyed the time I spent this afternoon interacting with all of you and giving the talk. I have one suggestion to put forth based on what Dr. Bhavatrathan said earlier about getting feedback from the industry and probably the government about the problems and making the connection with academia. Something to ponder about is abroad, there are conferences. For example, in ITS, there's a conference called JCT Symposium that happens every year in the UK. That happened 2 weeks back or 1 week back, where a lot of paper presenters are from the industry or from the government who had a problem to solve when they talk about it. These are not academically rigorous, but these are real problems, and they did something different to solve it. And this actually gives ideas to the academics who come and listen to it. Similarly, there is a magazine called Traffic Engineering and Control that used to be somewhat academic in the 70s, and it has become a practitioner's journal, not an academic journal. Perhaps having a quarterly practitioner's journal and organizing themes in the conference based on the patterns that you see in those journals is probably a good idea, along with the peer review from both industry and academia. So each paper should be peer reviewed at least by one academic and one practitioner. And that will definitely foster exchange of ideas, both offline and online. So I thought I will mention it. Otherwise, thank you all. You have been wonderful. Thank you very much.
So, good evening, everyone. Let me first thank Dr. Veena, IIT Palakkad and KHRI for inviting me again from the far off place like Banaras to Trivandrum. Regarding suggestions, yeah, I have. I may be probably in a very nicely words Dr. Rajesh has given. I can give it in a very blunt kind of a way. I have seen few conferences, but probably this kind of the conferences now I like. Okay, I normally go to the more to the IRCs rather than going to the academic conferences, because there I get a lot of field-related issues, the field-related persons basically. Now, what can be done is, obviously you can see the difference between the inauguration ceremony and the valedictory ceremony. So if it is coming from the top, believe me, if we can hold them for a day, you will see a very good conference. You will get a lot of persons from the industry, maybe the consultants, maybe the contractors, okay? They will be here, they will be posing your problems. Because I really face this kind of a conference when I think previous UP government, the first time the Yogi government came, and then that was their baby, the conference was their baby. So the 2 day, the full day conference were there. Okay, it was like our deputy chief minister was there for the whole 2 day. His all secretaries were there, and then they have invited all the states basically. Again, not going into the politics, but majorly the states where they are having the similar governments. So their secretaries also came in that conference. They have just told that how they are dealing the PWDs in their state. So a good kind of mechanism they have started adopted in the UP, and then finally in the end, obviously that was not a research kind of a conference. So there were not any paper presentations from the students, and the research were not there. Only invited presentations from the some kind of academicians or researchers who have done something, and then those were there. And some of the research or some of the presentations were from the field, the implementing agencies engineers, basically the PWD engineers, and the consulting, the contractors were there. So it was a 2 day invited presentation, but at the end of each day there was a session, and some of the, like the last day session was chaired by the deputy chief minister along with all the secretaries, and they can come up with some really implementable policies, and which has started in the PWD in the UP. So that kind of a conference also I have seen, but obviously again that has to come from the top. So if they can adopt this as their baby, and they can be sparing some time for here, like for at least a 1 day, you will see a lot of difference in the kind of the conference which are being organized, which are being attended by the people. And probably I hope then the PWD do not need to spend a single penny. Most of the money will come from the contractor side. So again, the same point, it has to come from the top. So if we can convince them at least for a day, and then obviously it should result out in something. Okay, it should ultimately result out into some practical solutions, okay, which probably either the contractors are facing, or the implementing agencies are facing, or a coordination, probably a contract management kind of a thing, or any kind of a thing. So these were the things, like I have seen few conferences, so these are just my suggestions, although it is very, I know, means getting a valedictory session of this is probably not a good idea, but I know how much of the effort probably these organizing team has done. So I just want to clap, and probably you can all support me. Thank you. Thanks a lot for inviting me.
Thank you, sir. From the audience.
Is it audible? Is it audible? Ah, okay. I am representing the audience and those who are from the field. I am retired Chief Engineer, Department of Space, ISRO. I have worked in the civil engineering field very actively for something like 60 years. So I have faced a number of problems. I have a number of problems even to discuss with the academy. I've been doing that when I was in service. KTS Iyengar, I don't know whether somebody know, from IAC and IIT Madras. A lot of professors we were interacting. The type of structures we were doing was something unique. You may not. For Department of Space, it is not a joke. And some of the papers presented, yes, really, they are taking things forward in the research area. But my point is, see, there is no emphasis on what is being practiced today and how to improve that in a particular efficient manner. When I say this, probably I am not making myself very clear. Unless I get time, I will not be able to. Now, for instance, I did a very huge structure in Sriharikota for a Department of Space. Form finished concrete, twin column, portal frames, 30-meter crane moving, form finished at the sea coast. You can imagine the problems likely to come out. Now, to ensure that this 200-ton crane works during the life cycle, even today, after 40 years, it is absolutely not having any problem. Form finished, concrete, M20. Okay. So my point is, high-tech is, I mean, new knowledge is okay. But unfortunately, most of the practicing engineers, they are not applying the knowledge what they acquired from their studies in a very effective manner for the help of the society. In the sense, whatever they do is meant to be of use to the society, and it should be functional throughout, it should be maintained and economically established. Now, I wish these conferences give some importance to the field problems and field engineers, so that this can be an interactive session with the academia, so that, you know, both get benefited. That's my suggestion. Okay. Now, incidentally, because I have been talking to so many people, both in the academy here and other places, I did not get any positive this thing, because I talked and that is the end of it. Nothing much happened. So I stopped my active involvement. I have constructed some infrastructure facilities for 5 engineering colleges and 1 medical college within 3-4 years after retirement, fully in charge of. So having been in this area in a very active manner, I found still there is something lacking from the field engineers, and thereby what I decided was I wrote a book, and its title is Trials and Tribulations of an Engineer in Public Service. The wording itself will give you enough this thing, because I have faced a lot of problems, and you don't have much to, I mean, refer to in the recorded area. So what I did was, I wrote my experience in that particular book, Trials and Tribulations. Then, of course, that is personal experience. I thought I must record what is my feeling about the construction management. So subsequent to that, I wrote a book, namely Construction Management. Some of the topics they were discussing, contract management and so many other things, one-sided contract and things like that. These are narrated in a very concise manner in that book. Now those people, some big, I mean, renowned people, Justice Sukumaran and all, having read the first book, he wrote an email to me. I don't know the person directly. He wrote an email saying, this is scripting the story of ascending science. Okay. Typical of some comments that I have received. That's what I have done. So my point is, the field engineers and their field problem, we must get a forum to discuss, interact with academia, so that you are both way it is beneficial. Okay. Thanks. All the best, and a very wonderful arrangement done by the organizers, and hats off to you.
Thank you, sir. Now I invite Srimati Sri Priya Lal, Deputy Director, KHRI, to deliver the vote of thanks.
A very good evening to all. It's my pleasure to deliver the vote of thanks for the event to all the dignitaries assembled here. First of all, I would like to thank all the keynote speakers, Professor N. Raghavan of IIT Madras, Professor Manu Santanam, Dean, IC and SR IIT Madras, Professor Radhakrishna G. Pillai of IIT Madras, Dr. Satish Jain Consultancy Engineers, Professor Geetam Tiwari of IIT Delhi, Professor Arnab Banerjee of IIT Delhi, Professor Ankit Gupta of IIT BHU Varanasi, Srimati Minimol Korula, Head Strategic Initiatives and Projects, McAfee, Dr. Rajesh Krishnan, CEO, ITS Planners and Engineers, and Professor L. Boeing Singh, IIT Guwahati. I thank them for accepting our invitation and honoring this conference with their inspirational presentations on resilient infrastructure. Next, I would like to thank the entire NCRI 2022 team, including the faculties and students of IIT Palakkad, for their efforts to make this conference a grand success. Last but not the least, I thank our beloved audience for bringing color to this event. Thank you.
So we come to the end of our second edition of NCRI 2022. So thank you everyone for your support.